will be a Starfreelancer. Learn new skills. Set your goals, increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Hello dear students, in this lesson we'll create our first multi-threading program. It is time to put our theoretical knowledge on practice and learn new things. We'll start from understanding of thread lifecycle and in which states our thread may be, and when we'll jump to practical examples, you'll have enough knowledge to understand them. In this lesson I will show you how to create thread with 5 different ways. We are going to learn such basic class for multi-threading in Java like thread, and one of the most important interfaces, runnable. While showing you examples, I will focus your attention on main properties of thread class that describe its state. And once we run threads, we'll learn with you how we can interrupt execution of a thread. We'll discuss methods that are deprecated for a long time already and that you never should use. And also we'll talk about proper ways of thread interruption. Today we are going to have a lot of code examples. And as we will go over the examples, I will also explain specifics of some methods and behavior of threads. Let's start. And as I said before, let's start from the understanding the whole life cycle of a thread. A thread considered to be new when we just created an object of a thread. And you know that in Java everything is an object. That's why thread of execution is also an object. To run a thread we need to call start method, because start method creates separate thread of execution within the Java process. After that, thread is in running state. In this state we can make our thread non-running by turning our thread into waiting state or blocked state. During this course we will discuss all these scenarios, for example when thread is blocked and when it's waiting. For now you need just to understand that running thread may be put on pause and getting back to running state again. As engineers, we will learn how to do this. Sometimes threads waiting their chance to update a shared resource. Sometimes we want to make thread wait until other thread will adjust state of our shared resource. And the last possible state of our thread is a terminated state. This state tells us that thread finished its execution, or it was interrupted. Is it clear? Now when you know thread lifecycle, it is time to write our first multi-threading application. I open file with name first multi-threading program. I have main method here. Let me go line by line and explain you each row here. You can see that the first thing that I do here, I declare a variable of type runnable and initialize it with new object of type default runnable. Let me open source code of runnable type because you see this type the first time in this course. As you can see, this is an interface from the Java version 1. It is a functional interface with only one abstract method with name run. We see that this method returns nothing and return type is void. This is exactly the method that we need to implement and where we need to put a code that will be executed in a separate thread. To have separate thread, we need to have instructions about what this thread is supposed to do. And these instructions should be written somewhere. This is exactly the method that will be executed by thread. Let's now check the source code of a default runnable. We see here that default runnable implements runnable interface. Basically, this is my custom class that gives implementation to run method. Inside this method, I print such text to console. I am a new thread, my name is, and here I call static method on thread class. We'll learn this class in a minute, but just to finish explanation of this line, current thread is a static method of thread class that returns the reference to the thread object. And depending on where this method is invoked, we receive the reference to the object of current thread. And after that I just call getName method that returns the name of the thread. I want to print this text to console to prove you that we have separate thread of execution when we'll run our app. But before doing that, let's investigate thread class. Let me open the source code of this class. The first thing that you can notice here is that thread also implements runnable. What does this mean? This means that object of thread type also may be executed as a separate thread, and this class also has implementation of run method. Let's look at it. As we can see, the first thing that object will try to do is to check whether we have target field initialized, and if yes, then we will call run method on that object, and if not, then we'll just do nothing. Target field has runnable type, and we can see even a comment here above this field. This is something what will be run. So as you can understand, we can do two things here. We can pass runnable object to the thread class, or we can override run method in thread class. We can pass runnable to this class via constructor. We have really a lot of different versions of constructor for this type. And one of the constructor is to accept an initialized target field to store the reference to the runnable object. Interesting thing to notice here is that this constructor invokes another version of constructor. It passes null reference to the thread group. We'll discuss a little bit later what is it. Reference to our runnable object, name of the thread which consists of the word thread, dash and the sequential number. That is static variable with name thread init number. That is incremented every time we invoke next thread num method. And the last argument is a stack size. We pass 0 because according to documentation, in case this argument is 0, we ignore requirement for specific stack size for this new thread. And the new constructor in turn calls new constructor that passes two more arguments, null and true. Null value is passed to cover such constructor argument as access control context, and true value is the flag to indicate whether we need to inherit initial values for inheritable thread locals from the constructing thread. Let me explain what these things mean. Access control context is a type that is used to create objects that make system access decisions based on the context it encapsulates. Check permission method that is invoked on the context that access control context encapsulates inside, either allowed to process with access to resources or throw access control exception. Anyway, this is not the topic for the first lesson of multithreading, and this is not what you will use on daily basis directly while working with multithreading, but just an overview to let you know. Regarding the second argument, inherit thread locals. Do not pay a lot of attention to this one at this moment. We'll cover concept of thread locals and inheritable thread locals separately, but in short, this flag is to tell thread whether we need to inherit values from inheritable thread local from the constructing thread. And basically, after that, we proceed with constructing of our thread of execution. Besides the constructor with runnable that we have just discussed, we have also different constructors that initializes other properties of thread object. For example, thread that takes runnable and access control context, constructor that takes thread group and runnable. Also, another popular constructor for debugging purposes is constructor with runnable and string. String represents the name of the thread. And other different variations including constructors with stack size and boolean flag to indicate the state of the inherit thread locals flag. What other properties does thread class have? If we would scroll to the top of this file, we'll find properties that we also may use during the configuration of the thread. You already know about thread name property. By the way, here's also a new keyword for you, volatile. We'll cover it too in the separate lesson. We have priority property. This is a value from 1 to 10 that will be used by thread scheduler to decide what thread is more important to work with resources next. However, we never can rely on the priority property when we have concurrent thread executed. Let's call this recommendation, but not mandatory direction to follow for thread scheduler. What is a thread scheduler? It is part of JVM that decides which thread should run. Also, it decides which thread should wait. How it is work? This is a great question, but probably not for the first practical multithreading lesson. We'll also cover this topic separately. The next property here is daemon. By default, it is false. We'll discuss later in this course what daemon threads are. Interrupted flag is used to indicate whether thread is interrupted and we need to stop its execution, or we need to proceed execution of a thread. Later in this lesson, I will also show you how to interact with this property. Next fields here used by JVM. We will not focus our attention on them in this lesson. And probably the one property that we didn't talk yet is a thread group. This object is used to group threads together in one group. Thread group forms a tree, and every thread except original thread group has a parent. There are also some specifics of locking mechanism for thread in thread group, but probably we'll cover this in a separate lesson. And it looks like that's it regarding high-level overview of a thread class and its properties. Definitely there are more things to learn here, but we'll do it gradually and with practical examples case by case. Now let's get back to the demo file. Here you can see that I created thread object and passed the reference to the runnable object. Why option with the separate class might be needed? In this case, you can declare some fields if needed. Also, you can declare constructors and pass external resources to the new object if needed. Because by default, run method doesn't take anything as method argument. And here is just an example of constructor initialization of the state of this object. If we want, we can pass any external object to the constructor and use the state of our runnable object in run method if needed. In such way, you can adjust shared resource that we shared with this thread. This is basically first way to create a thread object that is ready to be executed and that is in new state. The next way is another variation of the first one. Instead of creating type that implements runnable, we can just pass instance of anonymous class. You can see here that I have similar run method implemented. Basically, nothing special to highlight here. And to be honest, this way of creating thread is not very popular. The next way to create thread is to extend new class from the thread and override run method. If you remember, when we were reviewing thread object, we saw that there is nothing to execute by default if we didn't pass the reference to the runnable object. That's why theoretically we can just override run method. You can see that the current class extends thread class and we override run method here. And after that in main method I simply create the object of the first multithreading program type. That's it. While this option often described in learning literature, don't recommend you to do this way. Why? Because you extend thread class just to override one method. Probably it is not the best approach from the single responsibility principle point of view. For such purposes we have runnable type, and we can use it to give implementation to run method. The fourth way to prepare a thread for execution is to use lambda expression to implement run method. Here you can see that I created lambda function that takes no arguments and returns nothing. Basically, I just print the same text. And the last but not the least for today is the way preparing thread with method reference. I have static method declared in this class with name execute that takes no parameters and that prints the same text to console. I just pass in method reference here that meets the definition of runnable interface. It doesn't take any arguments and it returns nothing, the same as run method. In case you are not familiar with lambda functions and method references in Java, but you want to learn them, check my functional programming course for Java engineers. We have really a lot of examples there. The next thing that you see in this line, I just print name of the current thread to console, and for the sake of example, I call run method. Remember, run method doesn't start the thread of execution. Only start method starts separate thread. But if you would call directly run method, you would just execute run method synchronously. And after that I call start method on each thread that we created here. Let's run the program to see what we have got in the console. In the first line we see printed text from my main thread. Here you can see the text current thread name is, and its name is main. Main is the name of the first thread that we have in our Java application. The next line is result of invocation of run method, and as you can see, thread name is still main. That proves that invocation of run method doesn't actually start a new thread. And to start a new thread, we need to call start method. After you can see multiple lines with different names of a thread. That is exactly what is returned by getName method on the current thread invoked from the thread. And you remember that by default, naming convention for each thread is thread word and sequential number of a thread. Can you understand now how to run a new thread? In real life, you will often use executors to run and manage your threads. We will learn executors later in this course. But what we have learned in this lesson, this is basics that you need to understand before moving further. Now, when we know how to start a thread, let's learn how to interrupt it and stop its execution. I have a separate file for that with name interrupt demo. Here is an interesting app that will help you to understand how thread interruption works. Let's start from the main method. The first thing that I do here, create a task for execution. I implemented runnable interface in this class for the sake of this demo and not having multiple classes in this example. I will show you run method in a minute. After this, I create thread object and start a thread. And I want to let the main thread sleep for 2 seconds and interrupt my task after 2 seconds. How I can do this? I invoke sleep method on the thread object. This method takes number of milliseconds as method argument. 2 seconds are equal to 2000 milliseconds. Sleep method is overloaded in thread class. Let's look at the thread class source code. We have 2 sleep methods here, one with milliseconds only and another one takes 2 arguments, milliseconds and nanoseconds. To be honest, I never use sleep method with nanoseconds. But still, it is good to know that such method exists. Let's get back to our demo file. Another really user-friendly interface of making thread sleep is to use time unit enum from Java util concurrent package. This enum represents time duration at a given unit of granularity and provides methods to convert across units and perform timing and delay operations in these units. For example, you may perform such operations as making main thread sleep, and the interface allows us to not calculate milliseconds and convert them between seconds and other time units when needed, but we can just take time unit that we need and pass the value of the specific time unit that we need. For example, here is the line similar to the one above. It also uses milliseconds time unit, and here is the line that uses seconds time unit, and I'm just saying 2 seconds. To be honest, in my opinion, using of this API is more preferable. And after this line, my main thread is in non-running state, in waiting state. And when thread is waiting, other thread may interrupt it. That's why sleep method may throw so-called interrupted exception. And that's why compiler makes us handle this exception case to describe how a system should behave in case somebody will interrupt the thread. In this example, nobody would interrupt main thread, but still, interrupted exception is checked. That's why we need throws declaration here in main method, because for the sake of this demo, I don't want to create try-catch block here. After that, I print to console that I interrupt other thread. To interrupt other thread, we should call interrupt method. Interrupt method change interruption flag inside the thread object. That flag basically has 2 possible values, true or false. With the help of this method, we can change the state of the interruption flag inside the thread. And the last line in my main thread is printing leaving to console. Let's now look at our task and understand how interrupt method interrupts execution of the thread. I open run method. I print text that indicates that I entered run method and the thread is about to execute work method. I invoke work method. Let's look at it now. Work method is started with the infinite loop. After that, we just print one word, working. In if clause, I check if thread is interrupted. IsInterrupted method returns the state of the interruption flag. And in case somebody from other thread called method interrupt, like we did in our main thread, then this method will return true. Right now you already know what is done by interrupt and by isInterrupted methods. But why do we need interrupted method? Interrupted method returns also Boolean value and it returns state of the interruption flag, but it also clears it and returns it back to false. So in case we would uncomment this line and we will execute it, interruption flag will be turned back to false again. To interrupt the thread, I will keep this line commented and will just leave it as an example for you. By the way, I encourage you to download this source code example from the GitHub and run it locally on your computer. By doing this, you can play with values and comment the lines that you are interested in. And as always, source code examples in attachments to this lesson. Okay, so now I believe you got the difference between these three methods: interrupt, is interrupted, and interrupted. Now pay attention that thread is moved to the wait state because I invoke sleep method here. And by the way, no matter how long sleep will be, I put 1 millisecond here for sleep, but still it is enough to interrupt the thread. What will happen once thread will be asleep? Taking into account I'm in this if block because interrupted flag is equal to true and the thread is in waiting state, my thread will be interrupted and interrupted exception will be thrown. This line will not be executed. Never. Because interrupted exception will be thrown. This method throws interrupted exception without any handling to the upper level. And here we should print interrupted invoke method and return from the run method. As you can see here, I have try catch block because sleep method may throw checked exception and work method doesn't handle this potential exception inside. Let's run this program now. For 2 seconds, program will print to console working until thread will be interrupted. And once it is interrupted, let's see what we have. The first thing that happened is thread interruption. And even after that, you can see that I printed working word. That is because I just changed interruption flag, and I still need to wait until thread will be in waiting mode. This text in main living tells us that main thread finished its execution, and after that we see that we entered if block, and here is the status of interrupted flag. It is equal to true. The next step in our app execution is entering catch block and printing that thread was interrupted in work method. That's it. So the rule of thumb when you are creating multi-threading app, think about what is the logical point in your thread to allow other threads to interrupt it. In case you have such possibility to introduce this point, do it. Usually, you would let your thread fall asleep after all resources are adjusted and state of the system is consistent. In this case, there is no harm to interrupt the thread. There are some methods that you should never use and that are marked as deprecated but not removed from JDK only because of the backward compatibility. They are stop, suspend, and resume. These are dangerous methods in terms they are stop, suspend, or resume thread execution instantly without bothering what process is happening right now inside the thread. Taking into account not all operations are atomic and performed with one single operation of updating data in the memory, you can stuck somewhere in the middle of data processing in your thread. At the meantime, resource will be updated in other thread, and when you will resume execution, you may end up with not consistent state of your objects. We will talk about atomic operations in other lessons, but I believe you understood that stopping or suspending and after that resuming execution of the thread in case it is midst some calculation process is not the best idea. And one more interesting and last thing for today's lesson, probably you saw one commented line here where I invoke join method. What is it? Let me uncomment it first and run app one more time. What changed now? In this version, line that prints in main living will always be printed last. Why? Because join method also put our main thread in wait state until this thread will be completely finished. So I gave a command with this line to join this thread to the current one. That's why my app will wait until previous thread will be completely executed. Join method also may throw interrupted exception, taking into account it puts current thread in waiting state. And other threads may interrupt this thread while it is in waiting state. Is it clear? Basically, that's all what I wanted to share with you in this lesson. Let's recap what we have learned today. In this lesson, we learned life cycle of the thread and how state of the thread is changed from the new to terminated. We learned 5 ways how to run a thread. Also in this lesson we performed overview of thread class. Now you know main properties of this type. We learned readable interface. Now you know how to use it to execute separate thread. And at the end of the lesson we learned how to interrupt thread. Hope you enjoyed the lesson and you liked examples. We still have a lot of other things to learn, but I think today we have enough information to remember. Make sure you understand this lesson before moving further, because multithreading is not the easiest topic, and we need to be very careful with understanding each concept in sequential order, because it would be hard to understand one thing without understanding previous one. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team, in this lesson we are going to learn more about thread scheduler, daemon threads and thread groups. Basically, that's all what we have in our agenda for today. As we will review these topics one by one, I will also explain you what race of condition is, how priority works with threads, and why do we need yield method. And also, at the end of this lesson, I will show you how we can throw an exception from the run method. And as always, we are going to review different code examples today that will help you to understand the topic better. All source code examples are in attachments to this lesson. Let's start. And the first thing that we are going to learn today is a thread scheduler. In previous lesson I already mentioned about thread scheduler and told you that this is part of JVM that decides which thread will be executed next and which thread should wait. Also I mentioned that thread scheduler will choose thread that is in runnable state. That means that thread is running, or waiting, or blocked. But imagine that you have multiple threads running right now and your computer doesn't have enough computing capacity to start work on all threads at once. Thread scheduler would need to make a decision in such case. What thread to run first and which one should go afterwards. Not an easy decision for a thread scheduler. But how it would make a decision? Or what factors will be part of the decision-making process? The first factor is priority. Do you remember priority property from a thread class? This is int value that may be in range from 1 to 10. The higher priority value should indicate to thread scheduler that this thread should be prioritized over threads that have lower priority. During the thread initialization, new thread takes the same priority as the parent thread. Also, we have set a method that should help us to set new priority if needed. But what to do in case multiple threads have the same priority? In this case, it is really hard to predict what would be the decision of thread scheduler. That's why it is fair to make an assumption that random thread will be selected. But we know that random is something human related only. There is a programming code in place to make the random decision. We'll discuss this in details later today. And the second factor is an arrival time. The thread scheduler also will take into the account the fact when thread arrived and how long each of them waiting. In case with similar priority of threads, arrival time is one of the things that will be considered by thread scheduler. But again, this fact is not the final one in making the final decision. So how the thread scheduler works? Let's try to understand. In a multi-threading environment, multiple threads executed concurrently. But processor allocates a small amount of time, that is usually called time slice, to each thread. So the task of thread scheduler is to verify each thread and make a decision what thread will get processor's time first. There is different scheduling algorithm used to answer this question. Let's review them. Preemptive priority scheduling. This is algorithm that we partially discussed already. Thread scheduler will select the thread that has highest priority. The rest of the threads will be ignored. But in this case, is it possible at all for other threads to be executed? Yes, in case other thread has higher priority, or current thread went to waiting state or was interrupted, or with the help of yield method. What is yield method? This is a hint to the scheduler that the current thread is willing to yield its current use of processor and execution time. But the scheduler is free to ignore this hint. But to be honest, regarding this particular method, it is really appropriate to use it. It may be usable for debugging or testing purposes where it may help to reproduce bugs due to race condition, We'll talk about what race condition is a little bit later in this lesson. The next algorithm is first come first served scheduling. Rules are simple here. Thread scheduler assigns CPU time to the thread that appeared to be the one who requested it first. Also, we shouldn't forget about time slicing scheduling. You already understood that piece of time for each thread is called a time slice. Each thread gets executed cyclically, one after another, and thread scheduler will track whether thread has finished his execution within a time slice or no. In case yes, this thread will be removed from queue and scheduler will work with other threads only. Is it clear? Now, let's check how all these algorithms work together on the simple example. Imagine that we have 5 threads and only one processor. Let's make an assumption that all threads have different priorities and different arrival time. The thread scheduler that uses algorithms that we have discussed, it will decide which thread to select to give it time of processor. At first, thread scheduler should select the thread that has highest priority, and in case other thread with high priority will request access to processor, then new thread will get access to the CPU during the first opportunity. And once we'll deal with threads that have same priority, scheduler will use first come first serve scheduling algorithm to those threads. So hope now you have the vision how threads are executed in concurrent environment. Now let me quickly explain you what is race condition. There are multiple definitions of this term. Let me share with you some of them. In some sources, race condition is explained like an issue, error, in multi-threading program design, when program execution depends on the sequence of threads execution. The error got this name from the similar mistake in electronic circuit design, signals race. In other literature, you may find definition of race condition as not an issue, but as a state of the system where substantive behavior of an application is dependent on the sequence or timing of other events. So is it an issue or just a state without any consequences and without any impact? Actually, race condition may cause various impact on your app execution. Let's review some of them. Memory leak. Uncontrolled access to the common memory during the race condition may lead you to having memory leak. It can be that memory that is needed is not released by some thread, for example. Inconsistent data. It may happen that both threads managed to get access to the same resource and one of the mistakes of concurrent interaction happened. Probably one thread updated a resource with one value, but another thread overrides that value with new one, and you have lost update. Or for example, one thread used resource to read data from it, but at the meantime, in parallel, other thread updating this resource and the first resource read outdated data. This is called dirty read. It is also possible to face other issues, but I believe you understand the potential impact for data consistency in your app. Deadlock and live lock. In the separate lesson, I will show you examples of deadlock and live lock. In short, this situation in your app decreases productivity of each thread to 0. They are technically working, but they don't produce any result. And also there might be other impacts caused by race condition. So these are just a few potential impacts that you may face with in race condition state. How to avoid race condition? We can avoid race condition by building proper thread synchronization in critical sections of execution. GTK provides different ways for thread synchronization, and we'll learn them in separate lessons. We already learned a lot of new things for today. Let's start practical part of our lesson and reviewing the source code of our examples. Let's start from priority demo. I will show you now that you never should count on priority property. As we discussed, yes, it will be considered, but take into account there might be different cases when thread arrived and ready for execution, when processor time is available to create this thread, and when processor ready to process it. A lot of things happen literally in milliseconds. I have file that is called priority demo. What do we have here? We have static method with name execute that I will use to create objects of a thread type. This is a similar method to one we had in previous demo. I just print name of the thread to console. I create 5 threads and pay attention to the naming convention of the variables. I'm starting indexing from 0. This will help us to match variable name and thread name in console. I use setter method to set different priorities to new threads. you can see that thread 0 has the lowest priority. Threads 1 and 2 have the highest priority, and the rest of threads also have different priorities here. Also, you need to know that thread class has different constants already to set priority. There are 3 constants. They are min priority, that is equal to 1, norm priority, that is equal to 5, and max priority, that is equal to 10. You can use these constants in setter methods if you want. And after I did all these configurations, I run my app. I will run it multiple times, try to pay attention what thread will be printed to console first and what will be printed last. And you can see that in most cases thread number 1 is printed most of the times to console in the first row. And the strange thing is that thread 2, that is also has priority 10, may be printed the last one. So something strange is happening here. Thread that has highest priority and not the last arrival time will be printed the last one. Why? What the magic is happening here? You're right, this is magic of concurrent execution. Imagine that you have multiple tasks at once. Create threads, run a thread, synchronize access to the println method. And we'll learn synchronization soon, and you will learn that println is synchronized method. And time slices for each thread are not infinite. And while a lot of things happening, not always our brains can understand why we see this result, but not another one. But at least my brain for sure not always can understand this. But anyway, this is what you should know about multithreading before you start creating multithreading programs. You can't always predict the sequence of threads execution. That's why we'll learn with you how to create programs that will not depend on the sequence of thread execution to avoid race condition and unexpected impact on the results of our application. Now, when I showed you that you shouldn't completely rely on priority property, let me also show you another thing. This time I'll show you yield method example. We have 2 threads. The first thread gives a hint to thread scheduler that the thread is ready to yield its current use of a processor, and after that prints its name. The second thread prints name of the thread straight away. I believe this is clear. Let's execute our app multiple times. And we can see that output is not deterministic. Sometimes thread 0 is printed to console first and sometimes otherwise. It looks like it doesn't make a lot of sense whether I'm using static method yield or no. We can even make an assumption that access to such synchronized method as println is random, no matter whether I use yield method or no. That's why in documentation it's clearly written that thread scheduler may ignore this hint. And all my life I asked different people multiple times the question, why then we need yield method and priority if they don't bring us to the same expected result every time? And I've been answered like I explained you. Different algorithms, time slicing, and probably even with invoking yield method, the chances are different to execute one or another thread. But in real life and in demo cases, it is almost impossible to visualize the benefit of these methods, unfortunately. That is something what you should know about multithreading. In previous lesson, when we performed an overview of a thread class, and I promised you to explain what daemon threads are. Actually, there are not so much things to learn here. JVM is stopped when there are only daemon threads running. This is very useful to create daemon threads like supporters of another thread. For example, in case when daemon thread can't exist without other thread, because its work not so important without another thread. In one of home tasks, I would ask you to create daemon threads that will listen events in another thread. And in case there is no another thread, there is nothing to listen. I open daemon threads demo class. I create a thread that contains infinite loop and prints that daemon is working each half of the second. I start the thread and make my main thread sleep for 2 seconds. And after that I print that the main thread is finished. I will keep this line commented for the first run. I run the program, and as you can see, even after 2 seconds and even after main thread was finished, another thread is still working. The only way for me to stop it now is to stop Java process. I press the stop sign here. Let's do another thing now. I will uncomment this line. I call setter method here and set daemon flag to true. Now T1 thread is daemon thread and will be stopped right after the thread that created it will be finished. Because after the thread that created it will be finished, only daemon thread will stay. And considering the fact that there are only daemon threads, JVM will stop execution. The Java virtual machine exits and stops execution when the only threads running are all daemon threads. Let's run our app now, and we can see that once main thread is finished, JVM is stopped. Is that clear? Hope that this example helped you to understand what daemon threads are. Also, in previous lesson I promised to show you how to work with thread groups. In this lesson I also prepared a demo file to share it with you. Let me remind you what thread group is. Thread group is a set of threads. The thread group forms a tree in which every thread group except the initial thread group has a parent. A thread is allowed to access information about its own thread group, but not to access information about its thread group's parent thread group, or any other thread group. This type helps us to manage a group of threads as a single unit. This is extremely valuable when you want to perform such group operations as interrupt, for example, for all threads. I will not lie to you, and I'm going to say that this type is not very popular today. In this source code you can find a mention that thread group is pretty old type that was created in Java version 1. That's why I don't see a lot of sense to go over each method here and show you an example for each method, because it is very less likely that you will use this class in production. But still, I believe it worth me sharing it with you for general educational purposes, at least on the high level, because programming languages is constantly improved and new types are introduced, but core principles are the same, and understanding such basics as this class will help you to grasp new knowledge faster. I open thread group demo file. The first thing that I do in this example, I create thread group object. Basically, there are different constructors. You can create thread group with name, or pass another thread group that's supposed to be a parent for the new one, and name. After that, I create multiple threads and pass reference to the thread group in constructor. Also, I implement runnable interface by passing the reference to the execute method. So each thread will have infinite loop and will print its name each half of the second. And one thread will be interrupted while sleeping. We'll break the loop. In main method I start all threads and make my main thread sleep for 2 seconds. And after that, I don't need to interrupt each thread separately, but instead I invoke interrupt method on a thread group, and I expect all threads in this group will be interrupted. Let's run this program and see what we have. And the result is expected. We interrupted all threads and broke infinite loop. JVM is stopped. This is how easily I can interact with a group of threads with the help of thread group type. And the last but not the least thing for this lesson that I wanted to share with you is how to throw exception from the runnable. If you remember, run method in runnable interface doesn't declare that it may throw any exception. That is exactly the reason why we should handle all checked exceptions inside the run method. But what if you don't know how to handle specific exception, and you need to throw the exception according to a logic? How to be in this case? There is a dirty trick that you can do if needed to throw exception from the run method. Pay attention, you can't leave without handling checked exceptions. But nobody set any restrictions on unchecked exceptions. Do you understand what I mean? We'll wrap our checked exception in unchecked. In our example, you can see how I try to imitate IO exception by passing a legal path to a source. I catch the exception and throw a new one. This time I throw runtime exception, and I pass IO exception to a constructor like a cause of the exception. Let's execute this thread and see what we have. Great! You have runtime exception which caused by no such file exception, and now your logger will be able to grab these logs to log the proper and actual issue that will help you during the investigation and debugging in the future. The information about root exception will help you to understand the reason of thread interruption. That's all what I wanted to share with you in this lesson. Let's recap what we have learned in this lesson. In this lesson we learned what is a thread scheduler and how it works. Now you know what race condition is and what potential impact it can bring. In this course we will learn how to avoid race condition. Also, I showed you on examples how priority property impacts multithreading execution, and how yield method works. We learned what daemon threads are. On examples I showed you how you can manipulate group of threads with thread group object. And at the end of the lesson I showed you how we can throw exception from run method. That's it for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students, in this lesson we are going to learn basics of synchronization. Synchronization is a huge topic and we will learn it with you during multiple lessons. This is the first lesson about thread synchronization that will give you basic knowledge. When you create concurrent programs, one of the most important things that you should care about is the synchronized access of multiple threads to the critical areas. What is critical sections? We'll learn with you today in this lesson. Also, we'll learn with you concepts of monitor and mutex. After this lesson, you will understand these two concepts very well. I will explain you what is atomic operation and what is not. Once you'll understand all this theory, we'll jump to practical examples and we'll create our first program with synchronized threads. I will explain you how a synchronized keyword works with methods. And at the end of the lesson, I will explain such methods as wait, notify, and notify all. All objects in Java have these methods. Let's start. To begin with, let's understand what a critical section is. It is important for us to learn this first, because the rest what we are going to do in this lesson is to synchronize access to critical sections. That's why understanding of this term is critically important. Imagine that you have multiple threads that are executed concurrently, and there is block of code that is theoretically may be available simultaneously for two threads. This means that in some point of time, it might happen that two or more threads will interact with some resource simultaneously. That may cause mistakes in calculations and data inconsistency. In other words, critical section is a group of instructions that should be executed concurrently only by specific number of threads and performing specific operations. Usually it is one thread. But as we will keep learning multithreading to advanced level, you would understand that sometimes we wanna allow multiple threads to perform one operation with resource and allow multiple threads to perform another operation. For example, imagine that you have collection, let's say array list. Operation of adding new elements to array list should not allow other threads read value from any index. Add method should block access for all other threads to read elements from specific index. Because I can add new element in that position, and that would cause dirty read by other threads. At the same time, there is no need to block other threads in case all threads only read data from my array list and don't change its state. That's why I may allow as many threads as there exist to read data from array list only until moment of adding new elements to container will come. Does it make sense? Now let's understand what is an atomic operation. Atomic comes from Greek word atom, that literally means uncuttable. In computer science, atomic operation is the operation that is performed with single processing cycle. In other words, atomic operation is an uninterrupted operation. Let's understand this on example. Imagine that you perform an increment of your object's property and you want to update its state. What do you think? Is this atomic operation? It is not. Why? Because you have to read value that is stored in the piece of memory dedicated to the class property variable first. After that, you need to perform an increment and add 1. After that, you need to store the result of addition in some place. And only after that, you need to assign the result of increment to another variable, our class property. Is it clear? So even such simple operation at the first glance, like increment, is not atomic. But in this case, what is an atomic operation? In simple words, read and write operations are atomic. For example, assigning value to a variable is atomic operation. Reading value from array is atomic operation. Assigning value to array is an atomic operation too. Does it make sense? Also in Java, we have a special package that contains only types that execute not atomic operations by nature, but actually execute operations that looks like atomic. For example, you know that increment and addition is not atomic operation by itself, but atomic integer, for example, may perform addition of another value in synchronized manner to not allow any other thread interrupt execution of this operation. Later in this course we will review with you Java util concurrent atomic package that contains such types to perform atomic operations. We did a great thing already. Now you know what is an atomic and non-atomic operations. Also you know what critical section is. Let's look at example now, so that you can understand the problem of performing non-atomic operations with multiple threads and why we need to synchronize access to critical section. I open non-synchronized increment file. Let's look at the main method here. And I will say you before we start that the code below is a spaghetti code because we don't use executors in this example. Considering the fact that by this moment in our course we don't know executors, I will show you this example with basic thread class and readable interface that we all know. Later in this course I will show you another solution which is, in my opinion, more elegant. But I will show it to you once we'll learn executors topic. I create lists that will contain references to all my thread objects, because I am going to create 10,000 thread objects. Why I need so many thread objects? To be able to demo you issues that may happen in case we would perform non-atomic operation with multiple threads. Here I have for loop, and you can see that in condition I verify that I made 10,000 iterations. On each iteration I create new thread object with the following implementation of runnable interface. I increment my static int variable that is present in this class, and I will perform this increment 10,000 times. So what value will be here once all threads will perform increment 10,000 times? We'll look at the answer in a minute. After that, in loop, I add reference of this thread to the common list of threads. I need this to be able to request each thread to join main thread and make main thread wait until all other threads will be executed. And again, you need to see this code to feel relief later when you will start use executors, because you will understand how executors would simplify interaction with multiple threads. And in body of the loop, I start each thread. After that, in for each loop, I ask each thread to join main thread and make my main thread waiting until all other threads will be executed. When all threads did increment, we can print our variable to console and let's see its state. I will run program multiple times to let you see the issue. Can you see that the result is not always 10,000? Do you understand why this is happening? That is because at some moment of time, two threads entered this method simultaneously, and both threads read the same value of counter variable, and each thread made increment. But logically, this is two increments, but in fact, one thread override increment result from other thread, and we got lost update. Is it clear now? And what to do and how to solve this issue? You already can easily spot where critical section is. We need to synchronize access of different threads to our critical section where we perform non-atomic operation. That's why I started lesson from explanation of critical sections and atomic operations, to make sure that by this moment of time in our lesson, you would understand what I'm talking about. Let's now try to solve this issue. To solve this issue, we need to control concurrent access to the critical area. The basic tool in JDK for this is synchronized keyword. Let me open synchronized increment class. This is similar example to the previous one with only one difference. My increment method has synchronized keyword here. Let's run our program now multiple times. And you can see now that I constantly have 10,000 in console. That is because this synchronized keyword doesn't allow two threads access this block of code simultaneously. That's why we just eliminated all possible errors. How the synchronized keyword works? We need to understand this to create more complex solutions with better performance. To understand how synchronized keyword works, we need to understand such important concepts in multithreading programming as mutex and monitor. Let's start from understanding of what monitor is. And once we learned what a monitor is, I'll explain the difference between mutex and monitor. My own definition of monitor sounds like this. Monitor is a mechanism to synchronize threads' access to critical sections. More complex definition from Wikipedia also includes other properties of monitor, like ability to allow threads to have both mutual exclusion and the ability to wait for a critical condition. By the way, mutual exclusion is also a term from computer science and describes a property of concurrency control which should prevent a race condition by not allowing any thread entering critical section if some other thread currently executing code of critical section. Somewhere you may read another definition saying that monitor is a thread-safe class, object or module. That is partially also makes sense. We can use an object as a flag and as a monitor to indicate which thread captured the monitor of the object and which thread released monitor of the object. So in Java, monitor is implicitly associated with an object. Let me support my explanation with visualization. Let's look at the example with my car. Here is my Audi RS5 that can reach 60 miles per hour in less than 3.5 seconds. This has nothing in common with multithreading yet, but we'll jump to the details soon. Imagine that this car is a monitor, and critical sections here are accelerated pedal, brake pedal, steering wheel, and so on. I am a thread, and girlfriend of mine is another thread of execution. Two threads can't simultaneously interact with pedals. It will be a horrible thing in case me and girlfriend of mine will be pushing on different pedals simultaneously. I can capture monitor and do operations with the car that I need. I opened the car and drive to an office, and when I got back home, I released monitor. When monitor is released, another thread, my girlfriend, can take it and can go to the beauty salon, for example. Is it clear so far? There are also some methods that allow to interact with monitor. They are wait, notify, and notify all. Wait method is overloaded and has versions with arguments. There are time-related arguments, milliseconds and nanoseconds. These methods inherited in all types from object class, because all objects in Java implicitly extend object class. What these methods do? Let's review an example. Imagine that my girlfriend took a car, and all of a sudden something happened with the car and it was stopped unexpectedly. She called me and asked me pick up her with the car and help. When I found her in the city, she went out of the car and let me in. What she did? She released monitor of the object temporarily and let me capture monitor. She still has intention to drive further, but she just let me also perform some actions with the car. That is exactly what wait method does. It just releases monitor and let other threads capture monitor. I was happy to discover that my girlfriend just didn't deactivate immobilizer and the engine appeared to be blocked. I fixed that and told her that she can drive further wherever she needs. What I did? I called notify method on the monitor. Notify method makes all threads that were waiting aware that they can proceed their work. That means we use wait method to let other threads perform some actions and modify the state of some objects if needed, of some shared resources. And after that, other threads should call notify method to update all threads that their work done. Another example of wait and notify. You're going to have coding exercises soon, and there will be a task about readers and writers. For example, readers interact with some buffer of memory, where readers should find information to read. Readers capture the monitor of buffer object and doesn't allow anyone to work with it. Once readers read all information from buffer and buffer is empty, they are turned into the waiting state and they wait until writer put new information into the buffer. Once writer finished its job and put all information in buffer, it notifies all readers that were in waiting state by calling notify all method on buffer object, and now readers continue read information from buffer and so on. Notify all is a method to notify not only one thread that is in waiting queue, but notifies all threads that are in waiting queue. Hope that now you understood what is a monitor. Now let's understand the difference between two terms, monitor and mutex. Conceptually, these two terms are similar. The only difference is how they implemented inside. Usually the implementation of monitors is faster, lightweight, since it is designed for multiple threaded synchronization within the same process. Also usually it is provided by a framework library itself and not requesting the operating system. Usually mutexes are provided by the operating system kernel. What is OS kernel? In simple words, it is a computer program at the core of the computer's operating system and has complete control over everything in the system. It also handles data processing instructions for the central processing unit. It is a portion of the operating system code that is always resident in memory. Usually libraries, frameworks simply provide an interface to invoke mutex. This makes them heavyweight, slower, but allows us to achieve expected result to synchronize threads between each other.
A lock or mutex, for mutual exclusion, is a mechanism that enforces limits on access to a resource when there are many threads of execution. A lock is designed to enforce a mutual exclusion concurrency control policy. A monitor consists of a mutex lock object and condition variables. A condition variable essentially is a container of threads that are waiting for a certain condition. Monitors provide a mechanism for threads to temporarily give up exclusive access in order to wait for some condition to be met, before regaining exclusive access and resuming their task. So monitor is different than mutex, but they can be considered similar in the sense that monitor is built on top of mutex.
In this lesson I will use monitor term further, but just in case you will heard that somebody uses mutex term, you already know the difference. Now let's look at the coding example and we'll try to understand how monitor works, how synchronization happens, and practice example of wait notify interaction. Let's get back to synchronized examples that we already saw today. There is one more method here that is similar to synchronized one. Pay attention that this method doesn't have synchronized keyword in the same line with method name, but it contains synchronized block. What is this? So when you have synchronized method, it is fair to say that you captured monitor of this object, which you used to invoke the method. But what object you used to invoke the method in this case? And also, how it works with static methods. With static methods, you capture monitor of this class. To create synchronized block, you have to pass the reference to an object where you wanna capture monitor. Right now, in this block may enter only one thread. And once the thread will leave this block, it will release monitor of this class. And the next thread will enter this block and will capture monitor of class. With synchronized methods that principle is the same, but you just have synchronized access to the whole method, and not only for a specific part of it. Why you might want to use synchronized blocks? That is part of multithreading optimization, because it may be that actually not all lines in your methods is a critical section. Probably there are some operations that your multiple threads may perform in parallel. There might be really different cases. For example, here you want to print some text to console, or you just want to log that you entered this method and you want to log some message after critical section, or it can be some preparation activities before the operation. Anyway, logging printing text to console in this case is not a critical section. This will not bring you to inconsistent state of your system. That's why there is no need to make your threads wait to do operations that they can do now without waiting. So all code outside of the synchronized block may be executed concurrently. When you will create a multi-threading program, always ask yourself, do I need to synchronize access to this chunk of code or no? What will happen if two threads will execute this code simultaneously? And in case you would discover that nothing bad would happen, do not put this code in synchronized block, because in this case, you would improve performance of your app by not making your threads waiting when they shouldn't be waiting. In general, this is rule of thumb, to have as small synchronized block as possible. In case this method won't be static, you will capture monitor of another object. In this case, you would capture monitor of this object, the one that invokes this method. So these two methods now are similar. What potential drawback you see in using synchronized blocks? With synchronized blocks, you can't capture monitor in one place and release it completely in another place. You can't describe synchronized block in multiple methods. But there is so-called log API that we are going to learn also in this course that will allow you to capture monitor in one place and release it somewhere else. Now let's look at wait notify example. I grouped all classes related to this example in a separate package here with name wait notify. Let me open demo file and we'll start from client code. Imagine that I have some message. I create object of this type and left some message to process it. Let's have a look at the source code of message type. Message has one property that describes its state. It is called message. I need this type for string processing because you already know that string itself immutable object. Once I create object of type string, I can't change its state. That's why I created separate type that has API that allows me to update the state of the same object. Also, there are two methods here, getter and setter. That's it. Let's get back to the demo file. The second object that I create here is reader object. I pass the reference to the message object via constructor. After that, I create thread object, pass reference to the reader there, and name a thread as reader1, and start a thread. Probably you already understand that reader implements runnable interface, and you are right. We'll review source code of reader type in a few seconds. Also, I have another reader, and pay attention. I pass the same message object to the constructor. This would be exactly the object that I would use for multiple thread synchronization. Here I create another thread object with name reader2 and run this thread. So after this line we would have 3 threads running, my main thread and 2 readers threads. Let's learn what will be executed inside our readers in run method. As you can see, reader class implements runnable interface. It has one property. This is property of message type. Inside the run method, I get name of the thread for our demo purposes to print its name to console. And after that, I have synchronized section. I didn't make synchronized method because in this case,
All reader objects would have separate monitor.
I need common monitor that is shared between 2 threads. This is additional advantage of synchronized block, because you can pass any object as a reference to capture monitor. And I have this message object that is shared between 2 waiters. So I capture monitor of message object. After that I print thread name to console and indicate that this thread is waiting to be notified and print current milliseconds. After that I call wait method on my message object. One more important thing. You can call wait method only in specific context. You can call this method only from synchronized sections and from synchronized methods. In case you would invoke wait method not in synchronized context, you will get runtime exception with name illegal monitor state exception, because thread is not an owner of a monitor. Once I call wait method, this thread is in waiting queue to proceed execution when it will be notified. At the same time, the second reader managed to enter this section. Considering the first reader called wait method on monitor, that means that monitor is not blocked and another reader can enter this section. Now it is time to learn what is happening next. Let's get back to our demo file. Now it's time to create a notifier object. Notifier type is my custom type that I also described in this package. Pay attention that I pass the reference to the same message object. Create new thread with name notifier and start it. After that I print that all threads are started. Let's investigate what does notifier do. As you can see, objects of this type also will store the reference to the message object. This is our monitor. In run method we get name of the thread and indicate that this thread started its work. After that I make this thread sleep for 100 milliseconds. That is to ensure that reader objects captured monitor first. Once the thread waked up, I try to enter synchronized block. And until any other thread is capturing message monitor, all other threads, including this one, will stay right before the critical section and wouldn't enter it until get notified from the thread scheduler that monitor is released. You remember that in other threads we invoked wait method. That means that notifier may enter this section and capture monitor. In this critical section we perform message processing. We change the text to indicate which notifier updated the message. And after that I invoke either notify or notify all methods. In case I would invoke notify method, only one thread will be notified, either reader1 or reader2. Let's check this. I run demo file. Here is a notification about reader1 thread started. Notifier thread started here, and reader2 started and waiting to get notified here at this time. And once I called notify method, reader finished its execution. So now you can see that reader1 got notified and reader1 message processed. In the source code of reader class, you can see that I print this text to console after wait method at the end of run method. So after notification, all code that is below wait method got executed. Pay attention that our JVM isn't stopped yet. You can see the thread stop sign that tells us that I can stop JVM, but it is running. But why? Another reader thread is working now. It actually does nothing at the moment. It is just waiting to be notified in this line. But only we know that there are no threads left in the app right now that would be able to notify this reader object. All other threads, I mean main thread, reader1 thread, notifier, already executed and finished. And this is the last thread that is waiting right now. Let me stop the JVM. If you know that such case may happen, in case you know that two or more threads may enter critical section and wait until being notified, you should think about your multithreading logic very carefully to avoid cases like this. One thread is waiting and there are no other threads to awake this thread. How to fix this? You should control how many times you call wait method and how many times you call notify method. Considering we have one point in our app where we call notify method in our single notifier thread, and we have two reader objects where we call wait method, let's invoke notify all method in our notifier. I open notifier class and will invoke notify all method instead simple notify method. Let's run our app one more time. Now you can see that all threads finished their work and no other threads running. We have both reader1 and reader2 notified. You can verify this by investigation of console output. Is it clear? It is great that now you know how to work with wait notify methods and synchronization basics. Let's recap what we have learned in this lesson. In this lesson we learned what critical section is. You understood what atomic and non-atomic operations are. And we are still going to learn with you Java util concurrent atomic package in the next lessons. So stay tuned. Now you know what monitor and mutex are and what is the difference between them. Also you know what is synchronized method and what is synchronized block. And at the end of the lesson we have learned what wait, notify and notify all methods are. That's all for today. Hope you enjoyed this lesson. Thank you for your attention. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello team, today we're going to have interesting lesson. You know, sometimes it happens that there are topics that I need to explain you, but they are either too small for a separate lesson or highly connected with other topics. That's why I grouped such topics and decided to put them in one lesson. We'll start from understanding of memory management in Java in multithreading programs. This will give you an information about how data is managed by different threads. It is also important to understand hardware memory architecture. It is different from Java memory model, but Java memory model works with hardware memory and is built on top of it. That's why as software engineers, we need to understand how all this is connected. Knowing this information, it will be easier for you to understand volatile keyword and how it works. In previous lessons, we already talked about atomic operations and I mentioned that the Java util concurrent atomic package that contains types that support atomic operations. In this lesson, we'll review this package. At the end of the lesson, we'll learn what thread local variables are. I will also share with you some use cases when you might need to use thread local, but it will be up to you how to use this tool. Also, we will talk about inheritable thread local, and I will show you code examples. Let's start. And before we start learning thread locals, volatile, and other concepts, let's understand first memory management and how threads use in memory. Why it is important for us? Because we need to know and understand when different threads can use values written to shared variables by other threads, and how to synchronize access to shared variables when necessary. When I have multiple threads, JVM divides memory between thread stacks and the heap. There is a separate stack for each thread, and you can see the visualization on the slide. What is stored in thread stack? If you remember lesson about Java memory model from my Java course, you might guess what is stored in own stack of each thread. The information about methods that we invoked from the thread, all local variables for each method being executed. Local variables created in the thread obviously are not visible to all other threads. Hope you remember that heap memory stores objects. Objects are instances of all reference types that we know. And it doesn't matter if an object was created in the thread and assigned to a local variable, or even if it is created as member variable of another object. The object is still stored in the heap. But the references to these objects are stored in threads stack. Let's look at more detailed version of previous slide. Here you can see where information about methods, local variables, and objects is stored. So nothing new to you in case you are familiar with Java memory model. Also, important thing to highlight here that the variable may be of primitive and reference type. Variable of primitive type contains value in itself and completely stored in thread stack. In case variable has reference type, in this case, a reference to the heap is stored in stack memory and object is stored in heap memory. What about static variables? Take into account static variables don't belong to any object but belong to class itself. They are stored in the heap memory along with the class definition. So in case thread has a reference to an object, it can access object in heap memory using the reference. And each thread may do this in case it knows the reference to an object. And now, let me share a really interesting thing. Imagine that two threads call a method on the same object at the same moment of time. These threads, both of them, will access objects variables. But we have just learned that local variables are stored in stack of each thread. So each thread will have its own reference to the object in the heap and its own copy of the local variable. That is important for understanding for data manipulation from different threads. So in this case, some local variables are completely copied to each thread, and each thread has copy of the reference to an object in heap memory. Now, let's talk about hardware memory architecture. As I already mentioned in the agenda of this lesson, it is important for us to understand how hardware memory is architected because Java memory model is built on top of it. So modern computer often has two and even more central processing units. That is why they are called CPU. What does this mean for us? That means that we can physically have calculations done in parallel, because each CPU can run one thread at any given time. Each CPU contains a set of registers. These registers considered to be memory of our CPU. That's why CPU can perform operations on these registers much faster than it can perform on variables in the main memory. Besides registers, CPU also have CPU cache memory layer. And again, if we will talk about performance, it was to say that CPU is able to access cache memory much faster than the RAM memory, but obviously not as fast as it can access internal registers. RAM stands for Random Access Memory. It is a form of computer memory that can be read and changed in any order, typically used to store working data. For example, you start Google Chrome. Some RAM is reserved for Google Chrome. You start your Java app. JVM reserves RAM memory for the Java process. All CPUs may access the RAM, and the RAM is typically much bigger than the cache memories of the CPUs. Let's understand how process of reading and writing data is happening. In case CPU needs to read some data from RAM, it will read some part of the data from RAM into the CPU cache, and it is also possible that CPU will read some part of data into internal registers, and only after that operate on that data. And in case CPU needs to write result back to RAM, we are going through the same road but just in other direction, from CPU registers to RAM. CPU will flush the result of computation from its internal register to the cache memory and at some point flush the value back to the RAM. Eviction policy from CPU cache is simple. When memory is needed for something else, then cache memory is flushed back to the RAM. So, as you can see, Java memory model and hardware memory architecture are not the same thing. There is no separation between thread stack and heap in hardware memory. But how it is connected then? Let me show on the next slide. Both stack and the heap memory are located in RAM memory. That is reserved for Java process. Parts of thread stacks and heap may sometimes be present in CPU caches and in internal CPU registers. What problem may occur in case objects and variables are stored in different memory areas in the computer? There are two main potential problems. They are visibility of thread updates, and the second problem is race condition during the reading, checking, and writing shared variables. Let me explain what these issues are about in details. The first issue is visibility of thread updates. Imagine that some thread updated copy of the variable. There is no guarantee that other threads will be able to see this update. In case two threads has the reference to the same object without using proper synchronization or volatile keyword, there is a chance that updates to the shared object made by one thread may not be visible to another thread. How it may happen? Let's imagine the next case. Initially, shared object is stored in RAM memory, main memory, and imagine the one thread that is running on CPU updating the state of this object. As long as CPU cache has not been flushed back to the main memory, the updated version of the shared object is not visible to threads running on other CPUs. Is that clear? This may end up that each thread contains its own version of the same variable that's sitting in different CPU cache. On the slide you can see how two threads update the same count variable. And until CPU cache memory isn't flushed, these updates are sitting there. To solve this issue, we may use volatile keyword. I will explain later what volatile keyword does. Let's discuss the second issue, race conditions. Imagine that you have variable count of a shared object. This variable in CPU cache of one thread and in CPU cache of another thread. Both threads do the same thing. They add 1 to the count variable. Count has been incremented 2 times, and in case program would run sequentially and each thread updates the variable one after another, in this case the value of count variable would be true. However, this is not the case. 2 increments happened concurrently and we got last update. Because no matter which thread will update version of count variable in main memory, the updated value will be overwritten by another thread. How to solve this? Synchronized blocks. In this course you will learn how to use synchronized blocks properly to synchronize access of multiple threads to critical sections. I believe that now you understand how memory management is performed on different levels in multithreading programs. I promised you also to explain what volatile keyword is and how it works. As you already can understand that during the multithreading we should consider a lot of other things. The processor may flush its cache buffer in any order. JIT compiler may optimize our code execution via reordering. Reordering is an optimization technique for performance improvements. When you write a program, you expect instructions will be executed in order as written in the program. But that is not always the case. For example, you may declare two fields, int I that is equal to 10 and int j that is equal to 5. It might happen that j variable, the second one in the row, will be initialized first, but I variable still wouldn't be initialized and has default 0 value, but not 10. Because 0 is a default value for I. So for non-dependent operations like initialization of class fields, in some case, compiler may apply some optimizations and reordering is one of such techniques. And in case I will use volatile keyword with the fields, this will be a sign for runtime environment that I need predictable order for operations with these variables. Reordering won't be applied to such variables. And also I need to flash any updates to these variables instantly to make updates visible to all other threads. Does it make sense? To explain how volatile works and why do we need it, I had to explain you hardware memory architecture and Java memory model. But now I believe it is crystal clear what problem we are trying to solve by adding volatile keyword. And now I wanna break huge myths that you would find in the internet. Adding volatile keyword doesn't mean that all operations with such variable will be atomic. You may find statements in internet and sometimes even on Stack Overflow that volatile variables behave like atomic in operations. That is not true. The effect of volatile keywords is that approximately each individual read or write operation on that variable is made atomically visible to all threads. However, operations that requires more than one read-write cycle, such as increment for example, will not be executed as atomic. Because we need read value of the variable, add 1 to it, save result of calculation and assign it to this variable. These operations won't be atomic even if you would work with volatile variable. Remember that only atomic operations are with types from JavaUtil concurrent atomic package. We talked about these atomic types for a long time already. Let me show you in the demo how to work with these types. First of all, and as always, I recommend you to start from the official documentation from Oracle. From documentation we see that this package is a small toolkit of classes that support lock-free, thread-safe programming on single variables. Here you can find class summary. It is easy to remember these class names because most of them have atomic at the beginning. Atomic boolean, atomic integer, atomic long. I bet you can understand what type of values these atomic types work with. Atomic reference is a type that describes an object reference that may be updated atomically. Each of these types provide its own API to perform necessary operations. Also, there are types to execute thread-safe operations with arrays. Atomic integer array, atomic long array, atomic reference array, and there are even more types, for example double adder. You can use this type to perform thread-safe addition of doubles. Let's jump to the code examples and I will show you how to work with these types. For example, here is the code that creates 10,000 threads and update counter variable by calling increment method. Pay attention that increment method is not a synchronized one, and I also don't have any synchronized blocks here. But this code is thread safe and is secured from any multithreading issues. Why? Because my counter has type atomic integer that supports thread-safe operations. In increment method, I use API of atomic integer type. In case I need increment value, I can use either get and increment or increment and get method. These two methods are logically different in terms of what value you wanna get, before or after an increment. Let's run this example, and in console you will always find 10,000. That is because during increment operation other threads were not able to update counter variable in parallel. Let me open the source code of this type. If you would look at methods outline, you would find that there are plenty of useful methods. Some of them are get and set methods, get and add as a single operation if you want to sum integer values. Also there are atomic decrements, decrement and get and decrement, and methods to convert atomic integer to other primitive types. The rest of the atomic wrappers types work pretty similar. And as always, in case of any questions, feel free to leave your question in comments below this video. And the last but not the least, what I'd like to share with you for today is a thread local. I have separate file with name thread local demo. But before we jump to an example, let's understand a little bit more about thread local type. Thread local is a type that is declared in Java lang package. That means you don't need any additional import statements to start using this type. Thread local allows us to store data that will be accessible only by a single thread. Why you might need this? There might be cases when you don't want other threads interact with data of other threads and adjust it. The variables of thread local type differ from their normal counterparts in that each thread that accesses one has its own, independently initialized copy of the variable. Thread local instances are typically private static fields in classes that wish to associate state with a thread. For example, a user ID or transaction ID, something very specific to one single thread. Now let's start with practical part. I declare a private static field of thread local type parameterized by string. Thread local will be similar to wrapper. You will get and set object of parameterized type into it. You can just create an instance of thread local type like you usually do with all other reference types, with the help of new keyword. You can also use static method with initial that takes supplier as method argument to initialize the variable. If you're not familiar with lambda expressions and supplier type, I recommend you to pass my functional programming course for Java engineers. There are a lot of examples that will explain the topic of lambda expressions and functional interfaces. Let's move on. For the sake of the demo and to make it as simple as possible, I will keep my thread local parameterized by integer type and I will create object with new keyword. After that, I implement runnable interface in this type. In run method, I set random value from 0 to 100 to the transaction ID thread local variable. After that, I made my thread sleep for 1 second. I am doing this for the sake of the demo. During 1 second, we can guarantee that both threads will be started. And it is 100% assurance that this set method will be invoked in one and another thread. After sleeping 1 second, I print value of thread local to console in all threads. Technically, I need to create threads objects now and start them. And pay attention, transaction ID is a static variable and we may assume that it exists in single copy. But both threads will have different values associated with this variable. Don't believe me? Let's run the program. After 1 second pause, I see in console that two threads printed different values of the same static variable. How this has happened? You can imagine that thread local is a map. In this map, the thread is a key and the value is the value that we set to our thread local variable. And when I get value, I just extract it using the key, my thread object. That's why you shouldn't worry that another thread will access value from another thread, and that value that you set in one thread will be overwritten in other thread. And one more thing related to thread local. We have another type that extends thread local. It is inheritable thread local. What is the difference? Instead of each thread having its own value inside a thread local, the inheritable thread local grants access to values to a thread and all child threads created by the thread. Let's look at the example. I have thread local variable. This is parameterized by type string. Nothing special here, and the next field has inheritable thread local type. I create instance of this type with the help of new keyword. Let's run this app and look at the main method now. I create the first thread, and I set thread local value and inheritable thread local value. After that, I print values that are stored inside these two variables. And as you can see in console, everything is straightforward here. I can see value of two variables. After that, inside this thread, I create another thread. This thread is a child thread and I print values of thread local and inheritable thread local variables here. And in console you can see that I don't have access to the thread local variable on this level, but I can see inheritable thread local value. And after that, I create separate thread, thread number 2. I make it sleep for 1 second, and after that I won't print the values of thread local and inheritable thread local. And as you may already understand, neither thread local nor inheritable thread local is accessible from another thread. Hope that this example is clear for you and you know what is thread local and what is inheritable thread local. Let's review what we have learned in this lesson. In this lesson we learned how memory is managed in multi-threading programs. Also, now you know hardware memory architecture and how Java memory model uses the main memory. All this let us understand better volatile keyword and why we need it. After that, we performed overview of JavaUtil concurrent atomic package and saw atomic integer example. And at the end of the lesson, we learned thread local type and inheritable thread local. That's it for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team, in this lesson we'll talk about deadlocks and live locks. At the beginning of the lesson I will explain you what a deadlock is and what live lock is. On the real examples we'll reproduce with you such states and you will understand what to do to avoid states of deadlock and live lock. Let's start. Let's understand first what a deadlock is. The definition is simple. Deadlock is a state where two or more threads are blocked forever, waiting for each other. How it may happen? This situation may happen when two or more threads require the same locks but obtain them in different order. And to be honest, it is really hard to fall into the trap of deadlock nowadays, because modern tools for working with multithreading provide us with API to try acquire lock within the specific time and proceed execution in case lock is not acquired. I will explain such concepts in the next lessons. But you need to understand deadlock case so that you would understand the motivation to use other tools and classes that we are going to learn in the following lessons. You may have deadlock state in your app when you use synchronized methods or synchronized blocks. Let's review the next theoretical example. Imagine that you have two threads, and you have two locks. Thread number 1 captured the first lock and tries to acquire the second lock, but at this moment thread number 2 already got the second lock and tries to get the first lock. And here is a deadlock. Thread number 1 will never get the second lock. Why? Because thread number 2 holds the second lock and will not release it until it would get the first lock. But you already know that the first lock is not released by thread number 1 until thread number 1 will get the second lock. And here is the case when two threads are waiting for lock that is acquired by another thread. How to solve this theoretical example and avoid a deadlock? There are actually a few options here. The first and the easiest one, avoid acquiring multiple locks by a thread. In case threads need to acquire multiple locks, there are next options. The second option is to make sure you follow this rule. Always request locks in the same order in all threads. For example, if only we requested the first lock by thread number 1 and the first lock by thread number 2, we wouldn't be in deadlock state. And another solution is to use time restrictions to limit time of lock acquiring. For example, in case thread didn't obtain lock within the specific time, thread keeps execution. In this case, thread is not blocked for infinite amount of time in case it is unable to acquire a lock. Hope that now it is clear for you what a deadlock is and how theoretically to avoid it. Let's now look at code examples. We'll reproduce deadlock state and we'll fix it. I have deadlock issue demo class. You can find the source code of all examples in attachments to this lesson. I declared two fields here. I called them lock1 and lock2. I will use these objects for synchronization. In main method I declare two threads and instantly start them. In the first thread I capture lock number 1 and imitate some time-consuming operation by making my thread sleep for half of the second. Instead of this sleep operation could be any other time-consuming operation. After that, I try to capture lock number 2, but in this example we will never enter this block, and thread will be waiting to capture monitor of the lock number 2 object. Because the monitor of the second lock will never be released. Let me explain why. So this thread is started and I create a new thread. In this new thread, I capture second lock and after that I try to capture lock number 1. But I can't, because it is still captured by the first thread. And the first thread can't capture lock number 2 because it won't be released until the second thread will release the lock. And that's how we get to the deadlock state. Let's run this program. And you can see that I printed information about capturing lock objects, and JVM is working. It is actually does nothing at the moment because two threads just waiting until locks will be released, but we understand that they won't be released. Let's now try to fix this. So the first fix is not to use multiple locks in one thread. That is the easiest one, and I believe I even don't need to demo this. Just remove the second synchronized block and that's it. The second fix is to capture locks in the same order. I open deadlock solution demo class. This is a similar example with only a few changes. In the second thread, we'll capture lock 1 first, and after that we'll capture second lock. Let me run the program. And you can see that all lines of code are executed because in this case we don't have deadlock. And the third fix is to use timed lock attempts. But we'll learn how to use lock API in other lessons dedicated to lock API. So that's it. Now you know what a deadlock state is and how to avoid it. Let's now learn what a live lock is. Another issue that might appear during the execution of multi-threading program is a live lock state. What is it? Live lock is similar to the deadlock in terms of the end result. Program will not produce any useful output, but different in terms of the root cause and actual state of the program. In live lock, 2 or more threads keep on transferring states between each other, instead of just waiting like we saw in deadlock example. In case of live lock, threads are not blocked actually. They are just too busy responding to each other to resume work. This is comparable to 2 people attempting to pass each other in a corridor. So imagine that you're faced with a friend of yours in a corridor, and you decided to move left to let your friend pass you. But your friend is also polite, and he decided to move right to let you pass. But you blocked each other again. Now you decide to move right, but friend of yours thinks that he is also responsible for what happened, and he decided to move left this time, and both of you are blocked again in corridor, and so on. How to avoid live lock? To avoid live lock, we need to investigate the condition that causes live lock state to come up with solution accordingly. So it is no universal solution to address live lock issue. A thread should stop repeating the same actions if no progress has been detected. And real-life scenarios may be very different case by case. Let me show you live lock example. We'll reproduce live lock state and we'll fix it. I open live lock issue demo class. We'll imitate family dinner. Imagine that we have 1 spoon and 2 spouses, wife Nastya and husband Igor. They are going to have a dinner, but they have only 1 spoon. By default, husband captured the spoon. And after that I run 2 threads. 1 thread for husband, where I call eatWith method, and I pass spoon and spouse. And the similar thread with calling the same method for wife. Here is the class of the spoon. It has owner, getter, setter, and use method. Setter and use methods are synchronized. When use method is called, I print the name of the spoon owner to indicate who used the spoon. And here is the spouse class. It has 2 properties, name and isHungry flag. By default, isHungry property is true. Let's look at eatWith method. This is exactly the method that we are executing in our 2 threads. I have loop here that checks whether spouse is hungry, and if yes, then I check whether the spouse owning the spoon at this moment. If no, I just wait for 1 second and go to the next iteration in a loop. During this 1 second, I expect my spouse would eat and will give me the spoon. But this logic will bring us to the state when 2 spouses constantly changing the owner of the spoon. When spouse is an owner of a spoon, I verify whether my spouse is hungry. Pay attention, I pass the reference to my spouse in the method eatWith. That's why I have the reference to object of other spouse and I can verify its state. And as you remember, all spouses are hungry by default. That's why I enter this if block and we changing owner of a spoon. Because each spouse is worrying about another one, and once spoon is passed to a spouse, I jump to another iteration of this loop. Let's run the app and see what we have. And as we can see in console, the threads are not blocked. They are working, but they are constantly passing the spoon to each other without eating at all. Because I call use method on a spoon only after that last if block, and my app never reaches this point in neither of the threads. How to solve this? I stop the app first and start syncing. Let's analyze how to solve this case. Actually, there are different ways to solve this issue, and only one of them is to limit number of passing spoon between spouses. For example, if Igor passed spoon to Nastya once and she returned it back, that means Igor may eat. The same rule applies for Nastya too. I open lifelog solution file where I resolved the issue. To solve it, I introduce two more fields in spouses type. The first one is spoon yield times. This number of times we pass the spoon to the spouse and let he or she eat first. The next new int field is spoon yield limit. This variable will store the limit number of passing spoon to a spouse. I initialize this field with 1. This means that in case I already passed my spoon at least once in the past, I am not passing it to another spouse again. I increment spoon yield times when I am changing owner of a spoon. And before changing owner of the spoon, I also verify whether I passed the spoon to a spouse previously in past or no. In this case, each spouse can pass the spoon only once, and after that, he or she will start use the spoon to eat. Let's check this. I run the program. In console, we can see that Igor suggested Nastya to eat, but Nastya refused and suggested Igor to eat. This time, Igor didn't play this game of polite husband and he started to eat. In console, we indicated that Igor has eaten. After that, we told Nastya that Igor is stuffed and is not hungry anymore. And after that, Nastya has eaten. Pay attention that this time JVM is stopped and we don't have lifelog. Is that clear? Great! Now let's review what we have learned in this lesson. In this lesson we learned what a deadlock is and what a livelog is. We reproduced with you deadlock and lifelog on code examples. After this lesson you know how to avoid deadlock and how to avoid lifelog. That's it for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students, in this lesson we are going to learn really powerful tools to work with multiple threads and to manage all threads. In this lesson I will explain you the concepts of executors. We will review executor and executor service interfaces. You will learn what a thread pool is. Today we are going to have a lot of examples and you will see how you can start threads with executor service. Also, today we will learn what a callable interface is and what feature type is. And at the end of the lesson we will learn how to interrupt all threads in executor service properly. And as I already said before, today we are going to have a lot of examples. Let me start screen sharing and we will learn with you this topic by reviewing source code and examples. I open executor interface. Let's understand first what this type is about and why do we need it. Objects of executor type execute submitted runnable tasks. This interface provides a way of decoupling task submission from the mechanics of how each task will be run, including details of thread use, scheduling, etc. An executor is normally used instead of explicitly creating threads. For example, rather than create a new thread object, pass runnable as constructor argument and call start method for each task, you may use execute method of executor type. So, as you can see, this interface declares only one method, execute, that takes runnable. Executors are capable of running asynchronous tasks and typically manage a pool of threads, so we don't have to create new threads manually. Probably this is the first time in this course when I mention thread pool. What is it? A thread pool is a software design pattern in multi-threading programming. Thread pool maintains multiple threads waiting for tasks to be allocated for concurrent execution by the supervising program. By maintaining this pool, the model increases performance and avoids latency in execution due to frequent creation and destruction of threads for short-lived tasks. Because creation of a thread object also takes some time. And why I should create 10,000 threads for 10,000 tasks that are relatively small and fast? It would be a great idea to reuse threads that were created already for new tasks, agree? But how much threads we need to create initially? We'll get back to this question later. all threads of the internal pool will be reused under the hood for relevant task, so that we can run as many concurrent tasks as we want throughout the lifecycle of our application with a single executor. There is another popular interface that extends this one. It is called executor service. And to be honest, there is not so much popular direct implementations of executor interface. More often we'll use implementations of executor service interface. Let's try to understand what is the difference between these two types and why we need executor service. This type introduces new behavior. With help of executor services, I may manage termination of all threads and not completed tasks. And in addition to that, we can submit tasks for execution that will return us future object. We will be able to get the result of computation by a separate task in the future. Here in method outline, you can see group of methods that allow us to terminate all tasks properly. I will show you in a few minutes how to work with them. We have submit method that allows us to submit tasks for execution. I can submit both types, runnable and callable. I will also explain what callable type is in this lesson. Also, we have a group of methods to manipulate with group of tasks during the task submission. I'm talking about invoke all and invoke any methods. Let's jump from source code of interfaces to code examples. I have separate package here that is called executors. It contains all examples related with executors and executor services. I open our first example. The class name is execute with executor service. In main method I create our first executor service. How to create it? We have factory methods in executors class. If we open executors class source code, you may find a lot of static methods that return the reference to the executor service. These factory methods are started with new word. We will learn with you the difference between different implementations of executor services. But at this moment, let's start from the simple things. Let's get back to the demo file. One of the most popular executor services is a cached thread pool. I create the object of executor service here. After that I call execute method and pass the runnable. Simple runnable that just prints thread name to console. And I can execute another task in similar way. Let me run the program now. And in console you may see name of the thread from our cached thread pool. Probably you won't ask me right now, Andrei, are you kidding with us? This example is much simpler than creating a thread and starting a thread. Please, don't think like this. This is easy for you because you already understand what is happening under the hood. We'll keep learning new things, and you need to understand how thread interruption is happening, what state thread has, what daemon threads are, how priorities impact thread scheduler decisions, and many other things. You just need to understand this. Let's move on. Let me now explain what a callable type is. Callable is a functional interface that declares one method, call. Pay attention that callable is a parameterized type and call method returns value of a parameterized type. Also, call method may throw exception. This is also an important difference between call and run method from runnable. If you remember, run method returns nothing and has return type void and doesn't throw exception. That's why we need to handle all checked exceptions inside run method. But we can throw to upper level exception from call method. Now I open callable demo. I create executor service, and to submit task that has callable type, we have to call submit method. Execute method only takes runnable, but submit method is overloaded and may take either callable or runnable. In this case, with the lambda function, I implement contract of callable interface. If you are not familiar with lambda expressions, I recommend you to complete my functional programming course for Java engineers. At the meantime, we proceed. So in this case, callable should return the value as a result of addition. Submit method returns as reference to the object of type future. What is it? The object of this type represents the result of an asynchronous computation. Methods are provided to check if the computation is complete, to wait for its completion, and to retrieve the result of the computation. Let's review what methods we have here. Cancel method with boolean flag. The method attempts to cancel execution of this task. This attempt will fail if the task has already completed, has already been cancelled, or could not be cancelled for some other reason. Boolean flag here is to indicate whether we wanna interrupt tasks that are in progress and not completed yet. To achieve this, we need to pass true value here. Or we wanna interrupt only tasks that are not started. In this case, we need to pass false here. Is cancelled. I believe that this is self-describing method. Returns true if task has been cancelled before it completed normally, and false otherwise. Is done. Returns true if task was completed and false otherwise. Get. This is a key method of future type in my opinion. Pay attention that this method blocks thread of execution until computation of task will be completed. That's why this method may throw interrupted exception, in case thread will be interrupted while it waits result of a task. And potentially, this method may throw execution exception, in case some exception will happen during the task execution. Get method is overloaded, and we have get method that takes first long argument and time unit. I love this method because it allows me to not block thread constantly waiting for result. You can tell wait result of computation, for example, 10 seconds, and after that, proceed with thread execution. Additionally, this method may throw timeout exception if the wait timed out. Let's get back to our callable demo and proceed with our example. Now I wanna print to console result of task computation. I call get method with timeout. Let me run this app. And in console I can see result that was returned from the future object. Can you understand now how callable works? Now when you know callable type, let's proceed learning executor services. I'd like to review with you invoke all and invoke any methods and how they work. I open invoke all demo file. I create executor service. After that, I create a list of tasks. I can use executor service to submit multiple tasks at once. Invoke all has overloaded version with timeout. So this method may return results when all complete or the timeout expires, whichever happens first. Invoke all may throw interrupted exception. That's why you need either to handle it or to let other know that this piece of code may throw interrupted exception. Let me run the program. And I see in console results of each task. Pay attention that invoke all method returns list of future objects. In our case, future is parameterized by string. I create a stream from this list and apply function to each future object that retrieves value from it. And I print all values to console. Basically, that's it. I believe you feel relief that you don't need to create a new thread object for multiple tasks. You don't need to call start method on each thread. As you can see, starting multiple threads much easier with executor services. The next example is invoke any demo. The precondition is similar to the one I had in invoke all demo. I have a little bit different tasks here. Each task sleeps different amount of milliseconds, and afterwards I call invoke any method on my executor service. I don't have list of features returned. Return string value. This is result of completion of the task that was completed first. Let me run the program. And it doesn't matter how much I would run this app, I would get the same result. Why? Because the task number 2 has the shortest sleep timeout, and it will be always completed as the first one. This method also has overloaded version with timeout. In case timeout will be over before any task would be completed, timeout exception will be thrown. Invoke any may throw interrupted exception and execution exception. Execution exception will be thrown if no task successfully completes. Do not forget about this. Now let me show you the next example. I will show you how nice and elegant you may interrupt multiple threads. I open executor service interruption demo file, and here we have our next example. I create executor service and submit different tasks here. I use intStream to generate stream of values from 0 to 9, and for each I perform the next operation. I submit task for execution. Task contains sleep for timeout in seconds. Pay attention that sleep interval is different in each task. The longest sleep timeout is in the last. And now, when we submitted all tasks, let's focus on threads termination. Why we need to shut down our executor service. Executor service manages threads and process tasks when there are any. But in case your app is finished, JVM may still work because executor service will not be automatically destroyed, and waiting executor service may keep JVM running. So how to close all threads that are managed by executor service? The rule of thumb is to follow the next algorithm. The first thing we need to do is to call shutdown method on executor service. Shutdown method makes executor service stop accepting new tasks and shut down after all running tasks will be finished. So theoretically, you may just call shutdown method and let executor service finish its job, and that's it. In case you will try to submit any new task after we called shutdown method, you would get rejected execution exception. Source code of this example you may also find in attachments to this lesson. And you can try to uncomment this line and execute an example. You would have rejected execution exception. This is because I submitted task after I called shutdown method. We'll keep this line commented for our example. You can check this later if you don't trust me. And you should never trust me, always verify everything by yourself. Check documentation and experiment with different code examples to understand the topic better. After we called shutdown, it is recommended to use another method, await termination. This method takes long value and time unit to define timeout, how long we should wait for all tasks being completed. Why we need this? You already know potential issues of concurrent programs. Deadlock may happen, or live lock, or probably some operation just takes significantly more time because of waiting response from other server, or something else. But you don't want to keep your threads and tasks working if the time exceeds. That's why we set specific timeout for our executor service to finish all tasks. Await termination method returns true in case executor terminated, and false if the timeout elapsed before termination. Await termination may throw interrupted exception because thread is waiting in this line for specified amount of time. And at this moment, theoretically, other thread may interrupt the current thread. That's why compiler makes us handle interrupted exception. So we ask our executor service to wait for 2 seconds to complete all tasks. And then finally block I call shutdown now method. This method waits nothing and just attempts to stop all executing tasks and returns the list of tasks that were awaiting execution. We call it to make sure that our executor service is terminated. So let's review one more time. We called shutdown to stop accepting new tasks in our executor service, then we gave time for executor service to complete all tasks, and after that we try to interrupt all tasks that are executing. Let's run this program and investigate console output. Shutting down text is printed after that we managed to complete these tasks. But all other threads were interrupted, and you can see text from catch block. That proves that all tasks terminated not instantly, but in places where it is possible. So tasks will be interrupted when thread is in waiting state. And you can handle interrupted exception according logic of your program. As I already said, shutdown now method returns list of runnable objects. This is list of tasks that never commenced execution. Basically, that's all what I wanted to share with you in this lesson. We still need to learn executor service implementations, but I believe we will have enough time in a separate lesson for that. Now let's review what we have learned in this lesson. In this lesson we learned executor interface. Also we learned another important interface, executor service. After this lesson you can understand what a thread pool is. I explained what callable and feature types are. And you saw how you can manage multiple threads with executor service. Now you know how to execute multiple tasks with the help of invoke all and invoke any methods, and you know how to interrupt all tasks. That's it for today. Thanks a lot for your attention, have a great day, and see you in the next lesson. Hello dear students, in this lesson we'll learn implementations of Executor Service Interface. In previous lesson we learned what Executor Interface is and what Executor Service Interface is. To show you demo, I had to use one implementation of Executor Service, but today we'll review different implementations of this interface and different use cases, so that you know when to use what specific implementation. Today we'll review fixed thread pool executor, cached thread pool, single thread pool, scheduled thread pool. As we'll go over each executor one by one, I will also explain what thread factory is and how you can use it during the initialization of threads. You'll understand what a thread starvation is and how to calculate perfect number of threads for your thread pool. I'm going to show you formulas and will teach you how to calculate blocking coefficient. And as always, we are going to have a lot of examples today. Source code of all examples is in attachments to this lesson. Let's start. Today we'll learn with you everything from official documentation and code examples. So let me start screen sharing. I open source code of executors class. I believe you remember that we have factory methods in this class that allows us to create instances of different implementations of Executor Service Interface. And considering amount of these factory methods and level of details, I would like to focus your attention on the difference between all of them and main features, rather than on the source code of each particular executor. So let's go one by one. We will start from the top, from the first factory method. This method is called new fixed thread pool and takes int value as method argument. You can see that we return object of thread pool executor type. Let me open this one. Thread pool executor type extends abstract executor service. This is abstract class that is used by different implementations of executor service. There are common implementations of some methods that are appropriate for all concrete classes that extends this abstract one. And as you can see, abstract executor service implements executor service, which in turn implements executor. Hope that the hierarchy is clear for you. It will be similar for other executors for our lesson today. Let's now get back to executors. So this method, new fixed thread pool, creates an executor service that reuses fixed number of threads. The fixed number of threads is passed to the method as method argument. The idea is simple. All threads work on tasks in parallel. Depending on your computer characteristics, the number of threads running simultaneously and in parallel is different. In case there are more tasks than current threads available to execute, those tasks will wait in a queue until any thread from the pool will be available again. What will happen in case any threads will be terminated because of the failure during the execution? New one will be created and take its place to execute subsequent tasks. Let's look at the example now. I open fixed thread pool demo class. All executor examples that I will show you today located in executors package. You can find the link to the package with all executors examples in attachments to this lesson. I create my thread pool executor. Pay attention, I create a pool for 3 threads. Also you can see that I cast object here, because factory method new fixed thread pool declares that executor service will be returned and recommends us to operate with object on this abstraction level. But we know that this concrete implementation of executor service will be used. I need this to show you class-specific methods that are absent in executor service. After that, I submit 4 similar tasks to the executor service. Each task sleeps for 1 second, and that's it. I need the sleep for the sake of example. I call shutdown method here to not allow anyone to submit any other tasks to this executor service after this line. After that, I print pool size and queue size. These are class-specific methods that are absent in executor service, but that will allow us to show the feature of fixed thread pool. Let me run the program. I run the program and I can see that pool size is 3, the number of threads that I have in my pool. I passed this number to the factory method, and number of tasks in queue is 1. That is because each task sleeps 1 second. And the 4th task has no threads that would process it. That's why it is in queue for the execution. But once these tasks are finished, one of the threads processes the last one. Once all tasks are processed, JVM is finished. That is because I call shutdown method. In perfect world, I should call await termination, handle potential interrupted exception, and call shutdown now, but we discussed this in previous lesson. And to not write a lot of code that doesn't directly relate to the topic today, I will skip it. But please, make sure you learned well previous lesson and you know how to terminate multiple threads with the help of executor service. My students often ask me how to define ideal number of threads to create in fixed thread pool. I mean, what criteria we should use to define whether we need to create 4, 8, or 10 threads in pool? It is not an easy question, but I will try explain it as simple as possible. Before calculating perfect number of threads, you should understand your limits. And I am talking not only about number of CPUs in your computer. I also want to draw attention to other limits. For example, there might be limit on number of connections to a database. Does it make sense to have 100 running threads that interact with database and have limit in database connection pool with 10 connections only? The answer is obvious. Or, if your thread interacts with other system and sends requests to the API that can process only few requests simultaneously, this fact also needs to be considered. Because in the most pessimistic case, we may end up with thread starvation state or even with out-of-memory error. What is thread starvation? Starvation describes a situation where a thread is unable to gain regular access to shared resources and is unable to make progress. This happens when shared resources are made unavailable for long periods of greedy threads. And of course, another important factor to consider is number of CPUs. You can identify number of CPUs like this. Call runtime static method on runtime class, you would get the reference to the runtime object, and invoke available processors. You will get int value, this would be the number of cores on your computer. Be careful with this method. When you will work with containers, this approach might provide you with wrong information. Without any specific constraints, a containerized process will be able to see the hardware on the host operating system. And it might happen that your containerized application supposed to use 2 cores only, but your operating system has 8. So just be careful when you rely on this value. Here we have another variable, executor service 2. And I want to show you that you can initialize your executor service just like this in one line by passing the number of cores to the method. But still, I mentioned different factors that would impact our decision and that will help us to answer what is ideal number of threads I need to create in my thread pool. Let's review formula from book Java Concurrency in Practice. Number of threads equal to number of available cores multiplied by the result of the next expression. 1 plus the result of division between wait time and service time. Don't worry, it is not so scary formula as it looks like at the first glance. Let's review it in detail. And we need to understand first what is a wait time and what is a service time. Waiting time is a time spent waiting for input and output bound tasks to complete. For example, this might be amount of time you're waiting for HTTP response from remote server. And this is just one example, because it might be not only input-output tasks, but any tasks that makes thread execution wait for some event. Another examples might be getting monitor log. What is service time? Service time is a useful time, the time spent being busy. For example, processing HTTP response, data filtering or transformation, etc. So dividing the waiting time by service time we get the result that is often called blocking coefficient. A computation-intensive task has blocking coefficient close to 0. Now let's assume that we have 4 CPUs and let's substitute numbers in the formula with your data and 0 for blocking coefficient. What result you have? In this case, the number of threads is equal to the number of available cores. If all tasks are computation-intensive, then this is all we need. And having more threads won't help us to improve performance, because we respect restriction of having limited number of CPUs. Now let's review another example. Imagine that our application processes different amount of data that is read from the server in the internet. You just send a request and await the response with the data. Program reads batch of data and processes it. After that, program reads another batch of data and processes it again. Having the performance benchmark evaluation, you know that process of reading one batch takes 200 milliseconds, for example, and time of processing of this data takes 20 milliseconds. Let's substitute numbers in our formula. And in this case, following calculations in formula, we need 44 threads. It seems to be a big amount of threads, but think about it from other point of view. You are going to have tasks that will be blocked, waiting for 200 milliseconds. And what these threads should do? Just sitting and waiting? They are doing exactly this thing, sitting and waiting. And at the meantime, we have processors that are ready and happy to execute any other computations. That's why in this particular case, with such waiting and service time, it is reasonable to have 44 threads in the fixed thread pool. There is a good practice to have separate executor services for each set of tasks. In this case, each executor service may be configured accordingly for a specific class of tasks. And when we have multiple executor services, we need to adjust our formula by adding CPU utilization parameter to it. What value may be in target CPU utilization variable? Values from 0 to 1 inclusively, where 0 means that thread pool won't use processors at all, and 1 means that thread pool will use 100% of processor's work time. The formula becomes look like this. In the similar case, and if I plan to grant only 50% of processor's time to the batch data processing, and another 50% will be dedicated to other activities or other executor service, we are going to have another result. I added 0.5 to reflect target CPU utilization, and as a result we have 22 threads. This number of threads you need to create in thread pool to be efficient with this group of tasks. Definitely, life cases are different, and it is not always so easy to calculate waiting and service time for each task that you are going to create. That's why these formulas are just a great starting point for you, and hope that these formulas will help you to understand the motivation to make a final decision regarding number of threads in a thread pool. Okay, now when you know this, let's get back to our demo. New fixed thread pool method is overloaded and has version that accepts int value and thread factory. What is a thread factory? Let's open the source code of this type. Objects of a thread factory type are used to create new threads. By giving implementation to the new thread method, you can define the process and activities that are needed to be executed during the thread creation. Let me explain it to you with the example. I open thread factory demo file. I create a variable that would store value of number of threads in a thread pool. I create executor service and have fixed number of threads in pool. And when I create executor service, I call method that also takes thread factory as method argument. I pass object of default thread factory type. What is this? This is my own implementation of thread factory interface. For the sake of the demo, I decided to keep all types in one demo file, to not navigate between multiple files during the one example. And here I implemented new thread method. But why we need to override process of thread creation and control it? The motivation to implement custom thread factory is different. You may need to perform some additional actions before creating a thread, or you need to create daemon threads, or for the debugging purposes you need to name threads in different way. There might be different cases why you want to control process of thread creation. So you implemented new thread method. In this case, I want to name threads following different pattern. You can see that I created atomic integer counter and name threads by adding value of my counter, incrementing it afterwards. That's it. Now I submit the same number of tasks. I have 4 threads in pool and 4 tasks. Each task prints thread name to console. You can submit either callable or runnable. Don't pay attention that in new thread method we are accepting runnable. This is not directly connected. In new executor, you create a thread. Threads are created during the executor service initialization in this case. And once threads are created, I submit tasks that will be implemented by these threads. Tasks may be either of type runnable or callable. I keep commented here example with callable task submission just in case you would like to uncomment it and try, once you would get the source code. Let's run this example. And in console you may see that threads name are different from default. This proves that method of the thread factory was used to create threads in the thread pool. Is it clear? Great, let's move on. Now let's look at other implementations of executor service interface. Probably you remember that when we just first time created executor service, I used cached thread pool. Let's investigate this one. In the source code of executor class, you can see that when I call new cached thread pool, I also create thread pool executor, but just with different arguments. So, as you may already understand, these methods return us different versions of preconfigured thread pool executor. To understand better what is the difference between cached thread pool and fixed thread pool, let's compare constructor arguments that are used during the initialization of thread pool executor object. You can see that in cached thread pool, first two arguments are 0 and max integer. These arguments are responsible to set core pool size and maximum pool size. What is core pool size? This is the number of threads to keep in the pool even if they are idle. How it is different from fixed thread pool? In fixed thread pool, I create specific number of threads. The number I pass as method argument is the core pool size and the maximum pool size. The third argument is a keep alive time. When the number of threads is greater than the core, this is the maximum time that excess idle threads will wait for new tasks before terminating. We can see that the keep alive time in cached thread pool is 60 seconds. And in fixed thread pool, this value is 0 milliseconds. And the fourth argument is a queue that is used to store tasks before they are executed. We can see that in cached thread pool we use synchronous queue, and in fixed thread pool we use linked blocking queue. What conclusion we may do based on these constructor arguments? These argument values mean that the cached thread pool may grow without bounds to accommodate any number of submitted tasks. But when the threads are not needed anymore, they will be disposed of after 60 seconds of inactivity. When it might be useful? For example, when we have a lot of short-living tasks in application. In a synchronous queue, each insert operation must wait for a corresponding remove operation. So we can say that pairs of insert and remove operations always occur simultaneously. That means that the queue never actually contains anything. Is it good for most cases? As I said before, it is good in case we have a lot of short-living tasks, but this is not always the case. In other cases, using of thread cached pool may impact performance of our application. In case with cached thread pool, each new task will create a new thread if all existing threads are busy. And I already flagged potential issues that might happen during the high load when we reviewed fixed thread pool. In best case, we may get a thread starvation situation, at worst, out-of-memory error. This is something what you need to consider when you decide to use preconfigured thread pool executor, created by new cached thread pool factory method. Let's look at example now. I open cached thread pool demo file. Here we have similar example to one we have in fixed thread pool demo file. The only difference is that I use different factory method from executor's class. I call new cached thread pool method, I submit 4 tasks and print pool size and queue size. And as we expected, pool size will be equal to the number of submitted tasks in this case, because each thread has sleep inside, and by the moment new task is submitted, there are no available threads, and new thread is created. And queue size will be equal to 0 because we use synchronous queue inside the thread pool executor. Does it make sense? And also there is a factory method that takes thread factory as method argument, so you can use it when needed. That's it regarding cached thread pool. Let's continue. The next factory method probably not worth for a separate demo. You can call new single thread executor. This method returns you an executor service that manages one thread. If this single thread terminates due to a failure during the execution prior to shutdown, a new one will take its place if needed to execute subsequent tasks. Tasks are guaranteed to execute sequentially, and no more than one task will be active at any given time. Additionally, this thread pool executor is decorated with an immutable wrapper, so it can't be reconfigured after creation. Let's learn now scheduled thread pool executor. We have two factory methods in executors class that allows us to create executor service of this type. They are new scheduled thread pool with int parameter that describes the number of core threads and overloaded method that takes thread factory as an additional argument. In the source code we can see that we return an instance of scheduled thread pool executor type. Let's open it and investigate this type. As we can see from the type declaration, it extends thread pool executor and implements scheduled executor service interface, which in turn extends executor service interface. We need to understand what new behavior is introduced by scheduled executor service. Basically, 4 new methods are introduced. Overloaded schedule method that takes either runnable or callable object. This method allows us to run a task once after a specified delay. Also, we have schedule at fixed rate method that allows us to run a task after a specified initial delay and then run it repeatedly with a certain period. The period argument is the time measured between the starting times of the tasks, so the execution rate is fixed. Schedule with fixed delay method is similar to scheduled at fixed rate in that it repeatedly runs the given task, but the specified delay is measured between the end of the previous task and start of the next task. The execution rate may vary depending on the time it takes to run any given task. Let's open scheduled thread pool demo class to review code examples with this executor. The first example just shows us how to execute some task after initial delay. I create executor called schedule method. I just wanna print thread name to console after 1 second delay. That's all tasks that I wanna schedule. Let's run this program. In console we can see that thread name has been printed. This is how simple you may schedule task for execution. Now I open scheduled thread pool demo 2. In this file we have demo of schedule at fixed rate and schedule with delay. I create executor and invoke schedule at fixed rate. Initial delay is 500 milliseconds, and after that start of each new task in each 1 second. After 7 seconds waiting, we shut down our executor service. I print a separator here, and after that I create new executor and invoke schedule with a fixed delay. I'm going to run the program, and I'd like you pay attention to the fact that these two methods will work slightly differently, because they track the same interval a little bit differently, from start of one task to start of another task, and from finish of one task to start of another task. I intentionally added sleep in each task. In this case, we may notice how in the first case, new task is executed each second, and in the second case, each task is executed approximately 1.5 seconds, because interval is measured between end of the one task and start of another task, and each task has sleep inside. I run the program, and you can watch the result and feel the difference. Can you see the difference? Hope that with this example it is clear how scheduled thread pool executor works. Also, we have similar factory method, but just for executor with one thread. You can use new single thread scheduled executor factory method to create similar executor with one thread. You can see that there is a wrapper here that exposes only the scheduled executor service methods of a scheduled executor service implementation. And there is overloaded method that takes thread factory as method argument. We reviewed almost all factory methods to create different executor services. We still need to learn fork-join framework to understand how fork-join pool works. That's why we'll review new work-stealing-pool method in the next lesson. That's it for today. Let's review what we have learned today in this lesson. In this lesson we learned different implementations of executor services. We learned thread pool executor class and how to create a fixed thread pool and cache thread pool. Now you know the difference in these pre-configured thread pools. Also you know the formula and the rules that will help you to calculate the ideal number of threads to create in the thread pool. Also we learned how to work with thread factory. After this lesson you know how to work with single thread pool and scheduled thread pool executor. That's all what I have for you for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hello dear students, in this lesson we are going to learn with you fork join framework. We'll start from the high-level overview of fork join framework and understanding of its basic principles. When we'll understand the theory of forking and joining, we will jump straight to the source code to learn fork join pool class. I will explain what work stealing algorithm is. After that we are going to have practical code examples and I will show you how to submit tasks for execution with the help of fork join pool. We'll review recursive action and recursive type tasks. And at the end of the lesson we are going to discuss drawbacks of fork join framework that we need to be aware of for making decision about its usage. Let's start from understanding what fork join framework is. The first time it was presented in Java version 7. Why it was needed? The framework helps to speed up parallel processing by using all available cores. It is designed for work that can be broken into smaller pieces recursively. The goal is to use all the available processing power to enhance the performance of your application. Why it is called fork join then? It is named after the way how it works. The framework forks, recursively breaking the task into smaller independent subtasks until they are simple enough to be executed asynchronously. And after that, result of all subtasks are recursively joined into a single result. This is join part. That's why the framework is called fork join. The fork join framework distributes tasks to worker threads in a thread pool. Workers that are sleeping or waiting, not actually sleeping and waiting. They are working on other smaller tasks. Fork join uses work stealing algorithm. Worker threads that run out of things to do can steal tasks from other threads that are still busy. Fork join pool doesn't create a separate thread for every single subtask. Instead, each thread in the pool has its own double-ended queue, or DAQ, which stores tasks. Let's talk a little bit more about work stealing algorithm. If put it simple, threads that are free try to steal work from DAQs of busy threads. By default, a worker thread gets tasks from the head of its own DAQ. When it is empty, the thread takes a task from the tail of the DAQ of another busy thread, or from the global entry queue, since this is where the biggest pieces of work are likely to be located. Today we are going to review a lot of JDK source code and code examples, so let me start screen sharing. The center of fork join framework is fork join pool class. I open source code of this class. Similar to other executors, it extends abstract executor service class that in turn implements executor service. All threads in the pool attempt to find and execute tasks submitted to the pool and or created by other active tasks that are either blocked or waiting at the moment. This enables efficient processing when most tasks spawn other subtasks, as well as when many small tasks are submitted to the pool from external clients. Let me open now fork join pool demo class. I created it in fork join package. Don't worry, you will be able to find the reference to the source code in attachments to the lesson. I am going to walk you through each line in this demo file. The first thing that we do here is creating a fork join pool object. We can do this in different ways. The first one is to use static method common pool. This will provide a reference to the common pool. This pool and any ongoing processing are automatically terminated upon program termination, in case we will call exit method of system class, for example. Another way to create an instance of forkJoinPool is just call a public constructor. The int parameter describes parallelism level. This level indicates how many threads or CPUs you wanna work concurrently on tasks passed to the forkJoinPool. In this case, we have parallelism level of 4. We can create forkJoinPool without passing int value. In this case, parallelism is equal to the int value that is returned by available processors method. Do you remember in previous lesson I showed you available processors method that we can call on the runtime object to define the number of processing cores we have on the machine? Basically, if you don't have any specific reasons to set specific level of parallelism, you may use default constructor. Also, there is another constructor that allows you to pass to the constructor thread factory and error handler. We already reviewed similar examples with thread factory in previous lesson. And another argument of type uncaught_exception_handler is a functional interface that requires you to implement logic of handling exceptional case during the thread execution. It will depend on how you would like to address the exception. Now we can proceed with submitting task to our executor. Similarly to all previous examples with runnable and callable, we can submit two types of tasks: actions and tasks. Action: this is something what doesn't return any value after execution, just set of instructions that needs to be executed in a separate thread. And task: it is a type that will return the result of the execution, similar to callable type. Recursive action is a type that will not return the result of the execution, and objects of recursive task type will return the result of execution. Both of them has an abstract method compute, in which the task's logic is defined. Also, both of these types extends forkJoin task. Let's review examples with each of these types. But before we jump to review code example, let me share a basic template for our tasks. On the slide you can see pseudocode. If my portion of the work is small enough, do the work directly. Else, split my work into two pieces. Invoke the two pieces and wait for the results. That is how we should implement compute method. There should be some conditions that will tell us whether we can proceed with work execution directly or we should create subtasks. Now let's look at code example. So, as you may already understand, recursive action is just a set of instructions that are needed to be done. A recursive action may still need to break up its work into smaller chunks, which can be executed by independent threads or CPUs. Recursive action is an abstract class that extends forkJoin task. So, to create an object of this type, we need to have concrete implementation of this type. In a separate file, I have default recursive action class that extends recursive action. This is not a very meaningful example, but I decided to keep it super simple in order you would understand how it works. We have private int field with name workload. We would initialize it with some value during the default recursive action object instantiation. And here is implementation of our compute method. Like you saw in template implementation on the slide, we start with definition of a condition that should describe when we are good to proceed with action execution with the thread and when we should split our action into multiple subtasks. In this case, we check if the workload value is less than 18. 18 in this case is a random threshold, just for the sake of example. When workload is less than 18, we just proceed action execution in the same thread. But in case it is equal to 18 or more, then we jump to else section, where we create subtasks and call fork method. Here you can see two alternative ways how to achieve the same result. We can create subtasks and call fork method for each subtask like you can see in the for each loop, or alternatively, we can use forkJoin task class and call invoke all method and pass all subtasks there. The result would be the same. I decided to keep for each loop here because the visualization is better in this case. Let's understand how we create subtasks. Basically, following our template, we split my work into two pieces. Here you can see that I create two objects of the same action type, and in constructor I pass workload divided by 2. I add all subtasks to the array list and return it from the method. We use this list in for each loop or in invoke_all method. To submit this action for execution, let's get back to the fork_join_pull demo class. I just create an instance of my default recursive action and I pass 32 to constructor. I call invoke method and pass the reference to my action object. Let's run this program. And you can see that I split the workload and created 2 subtasks. To sum it up, in your action task, you need to find the way to reflect the total amount of work. Also, you need to define suitable thresholds that will be used to split action in subtasks, like in our example. This can be a separate method that knows how to divide the work. And in implementation of compute method, you should describe the conditions that would define whether it is time to split work into subtasks or proceed with execution. Hope that it is clear now. Let's look at the second type of tasks that we can submit into fork_join_pull. Now we are going to learn recursive task. Recursive task is also an abstract class that extends fork_join task. We want to submit a recursive task when we want to get the result of the calculation in response. The logic of interaction with objects of this type is similar, with only one difference. We have to join the results of computation from different subtasks. Let me open default recursive task class that extends recursive task and that implements compute method. As you can see, we have similar constructor and the same field as we had in recursive action. In case our condition tells us that we shouldn't split activity in different subtasks, we just return the result. In this example, we just want to get value that twice the original value. In case we need to split our work into subtasks, we do this, but also we need to join the results of all subtasks. I call join method on each subtask that's supposed to return the result of computation. I aggregate result in one variable and after that I return the result. To demo this case, I have fork_join_pull demo2 class. I create an instance of fork_join_pull and call invoke method. I pass an instance of default recursive task with workload 40. I run the program, and in console output you can see that I get 80 as a result. That is exactly what my task is supposed to do. Great! Is it clear for you how the recursive action and recursive task work? If yes, then we are good to proceed. In case there are things that are still not clear, please leave your question under this video and I will be happy to answer. Now we are going to learn more about such factory method from executors class as new work stealing pull. This method is overloaded and has versions with int parameter and without parameters. In the source code of executors class you can see that this is nothing more than fork_join_pull instantiated with a specific level of parallelism, or with the default level of parallelism that is equal to the number of available processors. And how to work with fork_join_pull you already know, and we reviewed examples. I believe that you already understood potential benefits that we expect to get from fork_join_pull. Effective usage of all cores by splitting tasks into subtasks supposed to improve performance. But will it help us in all cases? Let's talk about disadvantages of fork_join_pull. Probably after this lesson you got an impression that fork_join framework is something extremely cool, efficient and super fast. Probably you even started to think that you have to use it most often. The evaluation of fork_join_pull vary between different engineers. Not everyone agreed and share benefits of this type. If you would search in the internet pros and cons of fork_join_pull, you would discover that there are a group of people who doesn't like fork_join_pull because of different reasons. On the slide you can see a list of the issues and drawbacks of fork_join_pull based on different people's opinion. That makes sense in some degree and in my opinion worth to share with you. So the drawbacks of fork_join_pull are: a faulty task manager. The fork_join technique splits the work into fragments and joins the results together. A subordinate practice that allows an intermediate join for each fork can only work successfully in a controlled environment. A fatal flaw with fork_join framework, by opinion of some group of people, is that it is trying to manage an intermediate join in a task outside of a controlled environment. Only the operating system or pseudo operating system can manage an intermediate join in a task. Additionally, there is the problem of errors exceptions in subsequently fetched tasks. And the answer to most of the edge cases that may happen in real life is uncertainty. But this is not why people choose Java. When we want to create robust application, we need tools and techniques to deal with uncertainties. Inefficient. Since all forked tasks go into the same worker thread deck, the stealing worker threads will fight each other at the top of the deck over the forked tasks. This framework can never function efficiently in high-performance environment. Special purpose. There are some restrictions to follow to make sure we can benefit from using fork-join pool. Recommended restrictions. Must be plain, that is mean between 100 and 10,000 basic computational steps in the compute method. Compute-intensive code only. No blocking. No input-output. No synchronization. Slow and unscalable. Only works well on small number of processors. This design can never scale to hundreds or thousands of processors. The overhead and thread starvation would nullify the benefits of additional processors. Exceedingly complex. You can spend more time if you wish to investigate the source code of fork-join framework with all nested types and how it is connected with the rest of concurrent tools in JDK. And you would agree that this is not the easiest and clear for understanding piece of JDK. Lacking in professional attributes. As a professional software engineers, we always striving for excellence and following the best practices. Some of them are: programs fail, usually at the worst possible time. Consequently, error recovery is paramount. Software needs tuning, balancing of resources. Administrators sometimes need notification, also called alerting. Logs are necessary. The software should be useful across a wide range of computing needs. The fork-join framework has none of this. Inadequate in scope. The fork-join framework is only designed to work in a trivial segment of the computing world. On Java Standard Edition only, on high-performance workstations, 16+ CPUs without hyper-threading, doing compute-only work, with no task input-output, no inter-task concurrency, and no networking. So this is just some of the criticism against fork-join pool. At the end of the day, it will be up to you how often and when to use it, and now you have all necessary information to make this decision. Let's recap what we have learned in this lesson. In this lesson we learned what fork-join framework is. Now you know the main methods of fork-join pool class. In the lesson we had some examples with recursive action and recursive task. We executed these types of tasks with the help of fork-join pool. And at the end of the lesson we have discussed fork-join framework drawbacks. That's it for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students, today we are going to have a really interesting and useful lesson. We are going to learn how to work with completable future. This is something what personally I use very often when I work with multithreading. And in my opinion, this class and its features underestimated among engineers. So today I am going to show you how powerful this type is and when we may use it. We are going to learn how to execute tasks with completable future. During the lesson we'll learn the concept of the callback and how to work with callbacks with the help of completable future. Besides that, today we are going to learn more advanced concepts, namely, I am going to show you how we can combine future objects together and work with them. And at the end of the lesson we'll learn how to manage exceptions in completable future. Let's start learning this topic with the help of official documentation and the source code. Let's understand first what completable future is and what problem it solves. Creating multi-threading programs is not an easy thing. Especially, it's hard to manage asynchronous computations and build dependencies between those. In case you have multiple steps in multi-threading program and each step may depend on execution of the previous step, you try to find out ways how to implement this in code. It may end up with having multiple callbacks and logic may be scattered across the application. And what about handling errors that happened on one of the steps? Should we handle the same error in different places, or we can find a way to create an exception handler for multiple connected steps during multi-threading processes? Completable Future helps us to solve this issue and even more. Completable Future was released in Java version 8 to improve Future interface. Future interface was released in Java version 5. It was a great improvement, but its introduction doesn't solve an issue of connecting multiple tasks between each other and API for error handling. Along with Future interface, Completable Future also implements another interface that was introduced in Java version 8. It is called completion stage. This type defines the contracts for behavior for an asynchronous computation step that we combine with other steps. In the source code of this type, you may find a lot of different methods, most of them are overloaded. So implementation of completion stage and Future interfaces in Completable Future gives us around 50 methods available to use. Those methods primarily for composing, combining, executing asynchronous tasks and error handling. Let's start watching Completable Future code examples. I created separate package for examples only with Completable Future. I shared the link to the package with you in attachments to this lesson. In the demo number 1, I am going to show you the simplest and probably one of the most popular usage of Completable Future. It is super easy to run asynchronous tasks with this type. It has multiple static methods that allow us execute tasks in a separate thread without long configuration of a thread object or creation of executor service and shutting down it later. In case I just wanna execute asynchronous task, I just call runAsync static method of Completable Future class. That's it. For example, you just need to notify another service about work being started or done, and you don't care about response from the client. Such or similar cases may happen sometimes. When you call runAsync, fork join common pool is used. This approach is good for intensive and fast tasks. Considering the fact when Java process is finished there is no common pool, I put sleep here to let the thread be executed and print the stacks to console. RunAsync method is overloaded. There is a method that takes runnable object and executor as method argument. In the next example here I pass the same lambda function for runnable and executor service. Considering the fact that second example here uses separate executor service and doesn't use fork join common pool, I don't need to put any sleep here to not afraid Java process termination. And you can see in console thread name and console output that imitates some work that may be done in a separate thread. By the thread name you can understand that thread is executed with the help of fork join pool. Make sure you watched my lesson about fork join pool if you want to learn more about it. In the second case we use thread pool executor, that's why thread name is different. That's it regarding this example. Let's move on. The next example is related with one of the features of Completable Future type. You can complete task with method. To be honest, I have never used this method beside learning and educational purposes. But this method is like one of the main things in Completable Future, when you potentially need to use it. Let's say you need to fetch some data from another server. This operation would take some time. That's why you decided to run this task in a separate thread. But something happened and the remote server doesn't respond for a specific amount of time, and you already need to proceed with execution. In this case, you may complete the future by returning the default value. Let's look at the example. I want to print to console result of asynchronous calculation. I call method calculateAsync that returns me future object, and considering the fact that Completable Future implements future interface, I can return Completable Future when needed. I create an instance of Completable Future. After that I create cache thread pool and submit callable for execution. I imitate a call to external server. Imagine that I want to get some price, double value that I will assign to the result variable and will return it. By making my thread sleep, I imitate the delay in request to a server. After that I shut down executor service, and I call await termination. I am waiting for 2 seconds only. Having the reference to the future object, I can verify whether all calculations are done or not done. If calculations are done, I return the reference to the future object. If calculations are not done, I call complete method on my completable future object and I pass some default price value that I am happy to return. In this case, future won't be done. And we are going to have false here. Because we wait termination only for 2 seconds, but we expect task to be completed in 5 seconds. After calling complete method, completable future will be considered as completed. And I return the reference to the completable future. When I get the reference to the future, I just call get method and I extract completed result. Let's run this program. And you can see that in console we have 9.99. This is our default price. And we don't get new value. Is it clear? If no, ask question below this video and I will be happy to answer. If everything is clear for you, then let's proceed. The next example is located in the file with name demo3. This time I am going to show you supply async. Similarly to the run async method, we can submit a task without boilerplate code. But the only difference is that in run async we passed runnable object, and here we need to pass supplier. In case you're not familiar with supplier type, feel free to watch my course about functional programming for Java engineers. In that course we have plenty of examples that will help you to understand a lot of functional interfaces, including supplier. Basically, that's it. Supplier returns the value. That's why I can get future after calling supply async and extract result from it. Let's run this program and print result to console. And as you can see in console, I managed to extract text from the future object and printed it to console. So feel free to use this method in case you have something to execute in a separate thread and you need to get the result of the execution. Hope that this example is clear. Let's move on. Now we'll create with you a sequence of steps that should be executed one after another in a separate thread. Because it might happen that you need to perform another action based on the previous step completion. So basically you connect completable future which should automatically get called when the future completes. That is also often called a callback. It is also known as call after function. We have 3 methods that allow us to do this. Then apply, then accept, then run. We are going to review examples with these methods now. Let's start from then apply method. In the file demo4, I create super simple example to help easily understand how this works. The pattern is the same, so you can apply it to any other tasks and calculations. Imagine that you want to fetch user ID by email from one API, and once you have user ID, you can request total number of purchases for this user from another API. And you need the result of first task execution to get ID in order to be able to execute the second request. I call supply async to submit my first task. This is supply that produces some result. And after that, I call then apply method and pass a function that takes result of previous task execution as an input argument and that returns other value. I have console output in first and in second task just to imitate some work. The result of then apply method is a future object that you can use to retrieve result of computation of last step. You can build multiple steps like this by calling then apply and using the result of execution from previous step as an input argument for the next step. Is that clear? If yes, then great. Also, there is another similar method, then apply async. What would be the difference between then apply and then apply async? Basically, the main difference is the executor that is used to execute these tasks. By default, then apply method uses the same thread that was used by the first task and uses the same executor that was defined by completable future on which it is called. Then apply async uses independent executor. By default, it is fork join common pool, but there is an overloaded method that allows you to pass executor service. Like in the similar example below that will bring us to the same result, I use executor service in then apply async method. In general, if you have multiple tasks for execution, I would just recommend you to have executor service configured and use it for tasks execution. That's it regarding then apply method. Let's move on. I open demo5 file. So, as you already understood, then apply method returns you some future object. But in case you don't want to create return statement to return result of the execution after the final step, and you just need to have some code got executed, you have to use either then accept or then run. We are going to talk in a minute what is the difference between these two. Let me just start explaining of then accept first. In this case, imagine that we need to extract full and complete user profile, and in the first step of multithreading process we received text representation of user profile. And after that I just call then accept method to perform some operation that doesn't require me to return a result. For example, just saving this information somewhere in the application, probably in the user session object, or in local database, it doesn't matter for this example. Then accept also returns completable future, but this is completable future that is parameterized by void type. In case you would try to extract value from this future, you would get null. Let's run this program. And as you can see in console, I printed to console null. So we can say that extract value from the future after calling then accept doesn't make a lot of sense. Similar to the previous example, then accept method has methods that allow to use separate executor for each step. Then accept async method uses separate executor for tasks execution. Is it clear? Now let's look at the next example with the run method and understand how it is different. I open demo 6, almost similar example, but in this case I just want to save user profile to another server, and when this task will be executed, I want to log that user profile has been saved or perform any other actions after the first one. In this case, there is no need for me to call supply async, because the result of computation of the first step will not be passed to anywhere. That's why it wouldn't matter at all what value will be returned from the first step of the execution. And after it, I just call the run method to perform some actions. In this case, just to notify that user profile has been saved, and I can proceed with other operations that were dependent on the first one. And again, we have future object returned, but it contains nothing in response. And also we have similar method to then run, which is called then run async. This method will use separate executor service, either fork join pool or the one that is specified. Hope that you understand now how to work with these methods. Let's continue. I'd like to talk about combination of different future objects. I open demo 7 file. Imagine that you already have two methods, and both of them return completable future object. The first method extracts user details by ID, and the second method extracts credit rating by user details. You already know how to use an apply method. Let's look how it would look like. In this case, when you would call one method and after that you would call another method that also returns completable future, you would get as a result completable future that is parameterized by completable future. It is not too convenient to work with the result now. You should call get method twice to extract the results that you wanted. Especially for such cases, there is a compose method. In case I call then compose instead of then apply, I get completable future parameterized by the type of my result. And that's it. This solution is more elegant in case you want to compose one future object out of two. If you know Stream API in Java, I am sure you remember that there is such method as flat map. That method is similar to this one, so you can extract completable future from another completable future and get flat representation of the result. Also in this case we have one task running after another, so two dependent tasks. We have also similar methods that are called then compose async. I believe you already understand what is the difference. Then compose async use separate executor. Let me open demo 8 now. In case two tasks are independent and you just want to complete two of them in any order, you can call then combine method. In this case, you can perform some actions after two tasks are completed. So again, we have two methods that return completable future. One method returns weight and another method returns height. Each method has sleep for 1 second inside. This is just to imitate some operation time. In main method we get weight in kilogram future, and after that we call then combine method and we pass height in centimeters future there, together with by function. As you remember, by function can take two arguments and return the result. These two arguments would be the result of these two future objects. And once we get the result, we apply the function. Inside the by function, I want to calculate body mass index by following specific formula here. Let's run the program. And you can see in console that after retrieving weight and height, I start calculating body mass index. And the main thing here is that I don't need to have connection between execution of the first and the second task. They can be executed in parallel, but I just need the result of both computations. And following convention, we have then combine async method, which is overloaded and has version with default executor and with a separate executor argument. I open demo9 file, and you already know that then combine method returns the result of computation of two future objects. We have another method that is called then accept both, that instead of by function takes by consumer. That means it doesn't return any value and just consumes the results of execution of two tasks and works with two future objects and return nothing. So in this case, you can see that I supply lambda expression that returns first, I call accept both, and after that I supply lambda expression that returns the second. And we just print concatenated string to console. And in case I would extract the value from the future object, I would get null, because then accept both method returns completable future parameterized by void type. Let's run the program. And you can see that I printed concatenated string. The null value proves that my future contains nothing. Also, we have similar method following conventions. We have then accept both async method. So far we learned methods that allowed us to combine only two completable future objects. Now we are going to learn methods that allow us to combine multiple completable future objects. There are two methods, all of and any of. Both of these methods accept variable arguments of completable future type. Let's review these two. I open demo 10. We have here a simple but very interesting example. We are going to cover with you a few more methods that I didn't share with you before. The goal of this example is to create a list of strings and turn them into capital case. Pretty simple scenario. And we will solve this task with completable future, not because I love complicating things, but just to help you understand this example. I create list of strings. After that I create string from this list. I call map method and pass in function there. Completed future method returns a new completable future object that is already completed with the given value. After that I call then apply method for each string and invoke delayed uppercase. Delayed uppercase sleep for a random amount of time but up to 1 second and returns the current string in uppercase. This random sleep imitates some operation time in case there would be more actions here. After that we have list of future objects. I call all of method and pass array of future objects, considering the fact that all of method may accept variable argument. All of method will return new completable future that is completed when all of the given completable futures complete. But what would happen in case one of the given futures complete exceptionally? Then the returned completable future also does so. The results, if any, of the given completable futures are not reflected in the returned completable future, but may be obtained by inspecting them individually. After that, I call onComplete method. This method returns a new completion stage with the same result of exception as this stage and executes that given action when this stage completes. OneComplete takes byConsumer as method argument. In this byConsumer, we receive the result on null if none, and the exception on null if none of this stage as arguments. To get the results, we need to go over our features one more time. In this case, I just print each updated string to console. Pay attention that I call getNow method of completable future. We didn't discuss this method yet. GetNow returns the value if computation is finished and returns default value that we pass as method argument if result is not ready. In our case, we use onComplete method So we assume that all of the features were done by this moment in our program. So I print all uppercase string to console. Let me run this program. That's it. Any questions regarding all of method? Leave them under the video in case of any. The next demo is related to any of method. Let me open demo 11 file. Here we have absolutely similar example but with only one difference. Instead of all of, I call any of method here. Any of method returns a new completable feature that is completed when any of the given completable feature complete. So in this case, the first feature that will be completed will be printed to console. Let me run this program. That's it. I have been processed first and that's it. Nothing else is printed to console. Does it make sense? Great, let's proceed. And the last but not the least for today, I am going to show you how to handle exceptions with the help of completable feature. This type allows us to handle errors in a chain of asynchronous computation steps. Instead of having try-catch block, we have handle method that receives two arguments. The first one is result of computation, in case all processing was finished successfully, and the second argument is exception thrown in case there was some exceptional case. I open demo 12 file. In this file we have examples of error handling. I supply async the next task. I have int variable that is equal to 5, and I divide it by 0. We are going to have arithmetic exception in this line. But taking into account this is runtime exception, compiler doesn't warn us about potential handling. But I am smart enough to call handle method after the last step. And by the way, you may have multiple steps, handle method will catch exception on any step of execution. In case there are no exceptions, result of execution would be in the first argument. And in case there is an exception, I have the reference to the exception object passed as the second argument. Let's run this program. And in console output we can see that we entered this if block. I printed class of the exception, it is completion exception, and it is caused by arithmetic exception. So we can see how a completion exception wraps the original exception. We have also another method for error handling. It is called exceptionally. The difference is that it takes not by function like handle method, but it takes function and has parameter of throwable type. The same way I check exception here, and considering the fact that I don't have any result available, I can return some default value, for example. That's it. We learned a lot about completable feature. In case there is anything else you want to know about completable feature, please ask questions. Now, let's recap what we have learned in this lesson. In this lesson we learned completable feature. As I said in the beginning of the lesson, it is a very useful class that I use very often when I work with multithreading. It helps to solve a lot of pain points. We learned different methods that describes how to execute tasks with completable feature. Also, now you know what a callback is and how to work with callbacks with the help of completable feature type. We managed to build multi-step multithreading processing. On real examples, you saw how we can combine feature objects and work with them. And at the end of the lesson I explained how we can manage exceptions with completable feature type. That's all for this lesson. Thanks a lot for your attention, have a great day, and see you in the next lesson. Hello dear students, in this lesson we are going to learn a new tool for synchronization of access to critical sections. Today we are going to learn Log API. We will start from general overview of Log API, what advantages it has over synchronized blocks and when we need to use it. I will provide you with detailed comparative analysis what we have in Log API and what we don't have in synchronized methods and synchronized blocks. This will help you to understand better what problems Log API intended to solve. In the lesson we'll discuss such important interfaces as log and read-write log. Once we learned interfaces, we'll jump to concrete implementations and we'll learn with you today reentrant log, reentrant read-write log, and stamped log. We are going to have a lot of examples, and I will show you how to use lock conditions and achieve lock fairness with respect to waiting threads. Let's start. And as usual, before diving into the details, let's try to understand what problems lock API is supposed to solve, and how it is different from synchronized methods and synchronized blocks. Lock implementations provide more extensive locking operations than can be obtained using synchronized methods and statements. They allow more flexible structuring, may have quite different properties, and may support multiple associated condition objects. The first time Lock API was introduced in Java version 5. To put it simple, it is easy to explain why we might wanna use Lock API sometimes and how it is different from synchronized keyword through the discussion of Lock API advantages and comparison with synchronized blocks. Lock may be obtained and released in different places. For example, you may acquire lock in one method and release lock in other method when needed. This is something what you can't do with synchronized block, because all blocks should be located in one single method. Time limit to acquire lock to avoid deadlocks. Do you remember deadlock example? That is something what may never happen if only we use all features of Lock API. There is a specific behavior in place that allows us to try to acquire lock for a specific interval of time. In case lock is not acquired, we build our logic in the way where we just proceed with other activities to not wait for lock infinite amount of time and come into the deadlock state. Work with conditions. What are conditions? Condition is a separate type that provides the ability for a thread to wait for some condition to occur while executing the critical section. Why we might need this? This can occur when a thread acquires the access to the critical section but doesn't have necessary condition to perform its operation. For example, a reader thread can get access to the log of a shared queue which still doesn't have any data to consume. Traditionally, Java provides wait, notify, and notify all methods for thread intercommunication. Conditions have similar mechanism, but in addition we can specify multiple conditions. Another advantage of Lock API is a fairness for threads that are waiting for lock longer than other threads. We can't achieve fairness in synchronized blocks because each thread may capture lock once it is released. But in Lock API, we can achieve fairness by specifying the fairness property. It makes sure that longest waiting thread is given access to the lock. Also, in case thread is waiting for monitor to enter synchronized block, it can't be interrupted. Lock API allows us to interrupt thread when it's waiting for the lock. Basically, these are both advantages of Lock API and main difference that differ locks from synchronized blocks. I believe that you already understood that knowing how to work with this API, you would be able to create more robust multi-threading application with higher performance. I can confirm that personally I ask about Lock API at least few questions during the interview, but probably not all interviewers do so. And also, not all candidates, unfortunately, can explain why we need Lock API and what is more important, how to use it. In this lesson, we are going to learn how to work with Lock API by examples. So probably it is a good time for me to start a screen sharing and learn with you Lock API by examples. Before we jump to code examples, let's look at the source code of Lock interface. Lock interface declares 6 methods. We are going to review these now. The first method in this list is lock. Very simple, it acquires a lock. In case lock is not available and already acquired by another thread, the current thread waiting until the lock will be acquired. This is similar to capturing monitor in synchronized method and in synchronized blocks. The next method that I'd like to review with you is unlock. This method releases the lock. It is similar as leaving synchronized block. But as you already understand, I'm more flexible with locks rather than with synchronized blocks. I can release lock in the scope of other method if this is needed. Also, we have methods that allows us to acquire lock only if it is free. I'm talking about try-lock method. Also, this method returns boolean value. It returns true if lock has been acquired and false otherwise. Nothing special. You can just build your logic around this method to make sure you execute alternative steps in case lock can't be acquired. And the next one, probably my favorite one, try log with time constraints. Probably because of this method, logs become so popular. Well, definitely not only because of this method, but I really believe that this method is something what was needed in JDK so long time before Java version 5 release. It is similar to the previous one with one difference. You try to acquire log within the specified amount of time, and in case time is elapsed, you proceed with alternative steps. This method allows you to wait for specific time and after that proceed execution. This will help us to avoid deadlocks and at the same time acquire log in case it was released after some period of time. Log interruptibility method was partially discussed already when we talked about advantages. This is similar to the log method, but it allows the block thread to be interrupted and resume the execution through a thrown interrupted exception. And the last method in this list is new condition. We are going to talk about it also later today. And it would be easier for you to understand this method with example. But in short, you can declare log conditions that will help you to coordinate work between multiple threads. So, as you can see, this interface has different methods that allows us to support certain level of flexibility during the development of multi-threading programs. But this comes with the requirement to know how to use this API. Agree? We already reviewed log interface. Now it is time to learn implementations and look at code examples that will help us to understand each specific method and how it works. And one of the most popular direct implementation of log interface is a reentrant log class. That's why our first demo class today is called reentrant log demo. The first thing that I do here, I declare a static count variable that will be incremented concurrently by different threads. This is going to be my shared resource. After that, I declare a field of log type and initialize it with the object of reentrant log type. After that, I have the same example that I already shared with you when we started learn synchronization for the very first time. Do you remember example with counter that is incremented from two threads? Here we have the same example, but instead of synchronized method or synchronized block, we are going to use log object. Let me quickly remind you what do we have here in main method. But before we start explanation of what is written below, it is must that you watched previous lessons, especially about synchronization and synchronized blocks. In this example, I would refer to that one, and you need to be able to compare these two examples. And also, if you are not familiar with functional interfaces and functional style of coding in Java, please watch my functional programming course for Java developers. Now, let's proceed. I create the instance of the current class to be able to invoke non-static methods with the help of this reference. I create executor service that I am going to use to execute all tasks. In this line, I execute 10,000 tasks. I use inStream object to generate range from 0 inclusively to 10,000 exclusively, and after that I call for each method to execute task with my executor service on each iteration. I pass the reference to the method that meets the contract of runnable interface. Considering that runnable is a functional interface, I can pass method reference here. So each task will increment count variable, but pay attention to the implementation. I call log method on my log object to acquire log. After this method invocation, only one thread will be able to execute next lines concurrently. And to make sure that I would release log, the rule of thumb is to invoke unlock method in finally block. Why? Because theoretically, some exception may happen between log and unlock methods invocation, and the unlock method in this case won't be executed. And in this case, we would never release log, and all other threads would wait for an infinite amount of time until log will be released, and until then, we will be in a deadlock state. Definitely, it is hard to imagine that some exception would happen after increment, but still, it is a rule of thumb, and I want you to start to create this habit. Unlock method is invoked in finally block, to make sure that I would release log 100%. So this is task that I'm going to execute 10,000 times. After all of this, I shut down my executor service and wait in maximum for 3 seconds till all tasks complete. And print result of counter variable to console. Let's run this program. And I'm going to run this program multiple times to prove you that the counter is always equal to 10,000 and we don't have lost update. In this specific case, this method, increment with log, is similar to this one with synchronized log. If you can't understand why then we need to use log, please refer to the slide with advantages of log API. It is less likely that you would use log API for such simple example. Most likely, you're going to use more complicated solution where you would need log API. And also, I doubt that you would use just log method. Most likely, you're going to use try log with timeout or try interruptibly. Is it clear? If yes, let's proceed. So why this log is called reentrant log? A log is called reentrant if the thread that holds the log can lock it again. A non-reentrant log is a log which cannot be locked again if it is locked, not even by the thread that holds the log. Non-reentrant logs may result in reentrance lockout, which is a situation similar to a deadlock. So, I hope that from the name of the class it is clear that the reentrant log class is a reentrant log. That means that even if a thread holds the log, it can acquire it again. Consequently, the thread must unlock it as many times as it has locked it, in order to fully unlock the reentrant log for other threads. Let's now review example when reentrant log acquires the same log multiple times for the same thread. I open reentrant log demo2 file. I create an object of reentrant log first. The goal of this demo is to hold such operations as addition and subtraction with 2 operands only. In the main method, I create an object of this demo class, because I need to use it to call non-static methods. I create executor service that I am going to use to execute my calculation operations in different threads. I have calculate method here that holds app's logic. Let's look at it. The method takes 3 arguments. The first one is operator, either plus sign or minus sign, and 2 operands for operation. Based on the operator, I execute either add method or subtract. But the main thing is following. I call log method when I just enter calculate method, and I call log method again when I enter either add or subtract. So I call log method 2 times. This is called reentrant log. The same thread may acquire the same log multiple times. Definitely we need to call unlock method twice now to make sure that our log is completely released and other thread may acquire log. That's why I have finally blocks with unlock method invocation in add and subtract methods and in calculate method too. Pay attention that after each log and unlock methods, I log message to console. This will help us to investigate what is happening inside this app. Let's run this program. And in console output we can see the same pattern. Log is acquired 2 times. That is output from calculate and from either add or subtract methods. And after that we have log is released 2 times. That means that only one thread acquiring and releasing logs, and only after log is released, another thread acquire and release logs, and so on. And results of computation are correct. Is it clear? Can you understand now what does reentrant log means? In case you have any questions, please do not hesitate to write your questions below this video. Let's move on. As I said in the beginning of our lesson when we discussed advantages of log API, we can ensure a fair order of threads to acquire log. What is fair and unfair? Imagine that you have 10 threads that are waiting to acquire a log. Some of them waiting more, and some of them just arrived in the queue and not waiting so long. So not fair log doesn't guarantee the order in which threads waiting to acquire the log. And this might bring us to the thread starvation state, when thread will wait for log access forever. So does reentrant log fair or unfair log? By default, this log is unfair, but we can make it fair. Let's learn how to do this. I open the source code of reentrant log class. There is a specific constructor in reentrant log that takes boolean parameters specifying whether the reentrant log should be fair or no. So just call the constructor and pass true value here to enable fairness for all waiting threads. Easy peasy. So now let's review how log with timeout works. I open reentrant log demo3. I have reentrant log instance created on the class level. I create executive service that has 2 threads only, and I wanna execute 2 tasks. I use method reference to refer to the method inside this class that describes the logic that should be executed in the separate thread. I try to acquire log during the 2 seconds. In case log is acquired, my task will sleep for 3 seconds. That is specially for demo purposes, because when first thread would acquire log, the second thread would wait here for 2 seconds only trying to acquire log. But I would get false here, and the second thread would execute alternative actions, because log wasn't acquired within the time specified. Here is a catch block to handle potential interrupted exception that may be thrown while thread would be sleeping. And finally, block here is to unblock the log. Let's run this program. In console output we can see that first thread managed to acquire log and enter if block. And while first thread is sleeping for 3 seconds, the second thread tries to acquire the log during the 2 seconds. And after that, we see console output from else block. Basically, that is how try log with timeout works. Let's continue. Let's learn now how to work with conditions. What is a condition type? Condition interface provides a thread ability to suspend its execution until the given condition is true. A condition object is necessarily bound to a log. Do you remember how we worked with wait, notify, and notify all methods? We have similar thing here with condition. The idea is the same, but the way how it is implemented is different. Also, you may have multiple conditions attached to the one log. The condition is important to be verified by a thread when it tries to access the critical section, but doesn't meet specific condition to proceed with the execution. The simplest example is when a reader thread got access to the log of the shared queue, but that queue still doesn't have any messages to read. Let me open condition interface to explore its methods together with you. The first method in this list here is await. Basically, this is similar method to the wait from object class. It just makes thread wait for notification. In case of interruption, thread will be interrupted and we would get interrupted exception. The next method is await uninterruptedly. This method has self-describing name. This is similar to await method, but with only one difference. In case thread would be interrupted during the waiting, thread would keep waiting until got notified without interruption. Await nanos method waits until thread would be either interrupted or notified, or the specified waiting time elapses. We have another variation of await method here. You can specify waiting time in any time unit you wish. Await until takes date as method argument to track waiting time. Signal method wakes up one thread only. This method is similar to notify method from object class, and signal all method is similar to the notify all method. Now, when we know the interface and understood the theory, let's look at the code example. I open condition demo file. In this file we have simple demo. We can push messages to stack and read messages from the stack. I have value for maximum stack capacity. I have stack variable that is initialized with linked list object. After that I declare log field. Using this log field, I create 2 conditions. Condition for the case when stack is empty, and condition for the case when stack is full and reached its maximum capacity. Now let's review 2 methods. Push to stack and pop from stack. In push to stack I acquire log. After that I verify the condition. In case stack size would reach maximum of its capacity, we would stay in the loop here, waiting to be notified that state is changed and redirect messages from stack. In case we still didn't reach maximum stack capacity, then we just add in message to a stack. And we notify all threads that were waiting for stack empty condition updates. Now the stack is not empty, and readers may read messages. In finally block, we release the log. The next method is pop from stack. I acquire the log, and in case stack size is 0, and there is nothing to read, the thread is waiting to be notified. And once thread is notified, we just return the message from the stack. In finally block, we notify all threads who were waiting for stack full condition. After this method executed at least once, stack is not full for sure, because we read one message from the stack, and we need to notify threads which wanna put new message in stack that this is possible to do now. Also, I release the log in finally block. In the main method, I create instance of this demo class. I create executor service and I submit 2 tasks. No matter in what order I would submit these tasks, the result would be the same. I submit the task that reads text from stack first. After that, I submit tasks that push message to stack. Let me run this program. And in console you can see that message from stack has been read. In case reader task started first, it reached to point of condition check and was moved into waiting state. After writer task added message to a stack, reader got notified and returned string value that was read. Is this clear? Also, sometimes methods of reentrant log also might be helpful. Personally myself don't use reentrant log methods very often. I still prefer to work on the log abstraction level. But I must inform you that there are also useful methods that you may use to build your logic. I open the source code of reentrant log. Get hold count returns the number of holds on this log by the current thread, or 0 if this log is not held by the current thread. Is held by current thread returns true or false. True is returned if current thread holds this log and false otherwise. Is logged method returns true if any thread holds this log and false otherwise. Is fair method returns true if this log has fairness set true. Has queued threads returns true if there may be other threads waiting to acquire the log. Get queue length returns the estimated number of threads waiting for this log. Has waiters method takes argument of condition type and returns as true in case there are any waiting threads for this condition. Get wait queue length returns the estimated number of waiting threads for the specific condition. Now you know all the methods of reentrant log class. Sure, this will help you someday. Great, let's continue. Now, let's learn read-write log. There is a separate interface that declares 2 methods, read log and write log. These methods should return you object of log type. When you should use read-write log? It is a good way to improve performance by separating logs for reading and logs for writing. The rule is simple. If there are no write logs and nobody is writing to the container or changing state of the object, this means that there is no harm in all threads reading the state of the object. Thus, read log may be acquired by multiple threads simultaneously. And in case somebody is reading, it is not allowed to update state at this moment to avoid inconsistency. When nobody is reading and we are writing, updating the state of the object, we can't acquire read log to not read data that is going to be updated in a few seconds, and only one thread can acquire write log simultaneously. Does it make sense? And performance is better because threads are not waiting for log in cases when there is no harm in concurrent execution. Understood? The most popular implementation of read-write log is a reentrant read-write log. This class implements 2 methods from read-write log interface. And also this class has methods similar to reentrant log class, the methods that we reviewed, like isFair, getQLength, getWaitQLength, and others. But all methods are considering the fact that they are working with 2 logs. For example, getQLength method estimates the total number of threads that are waiting to acquire both logs, read and write log. Such methods as has waiters that take specific condition as method argument will be the same for specific condition of specific log, read or write. Besides that, there are methods to check state of read and write log separately. They are getReadLogCount returns the number of read logs held. is write locked returns true if any thread holds the write lock and false otherwise. Is write locked by current thread returns true if the current thread holds the write lock and false otherwise. Get write hold count returns the number of holds on the write lock by the current thread, or 0 if the write lock is not held by the current thread. Get read hold count, the same but for read lock. Has queued threads returns true if either read or write lock has threads waiting to acquire the lock. Basically, I believe that we performed a nice overview already, and now it is time to look at the code example of reentrant read-write lock usage. In this example, we are going to implement basic operations with the hash map and will make it available to use in concurrent environment. To keep performance of our interaction with the hash map on the top level, we are going to use reentrant read-write lock to control access to critical sections. In the class, I declared field of hash map and read-write lock. After that, I use object of reentrant read-write lock to keep the reference to the write and read locks. Basically, inside the methods, you can use read-write lock and get the reference to the read or write lock when needed, but in this case, when I use read and write locks multiple times, I would like to extract those as separate variables. I have two write methods that update state of my hash map. They are put and remove. And you can see that before actually update the state of the hash map, I acquire write lock. I'm doing the same thing when I add, update or remove an entry in the map. In all cases, I acquire write lock and release it after operation is finished. Also, I have two read operations in this case, get and contains key methods. Considering the fact that these methods don't change state of the map, and also we need to be sure that when we read data from the map, no other threads update in the hash map, I acquire read lock before proceeding with operations. And obviously, I release lock after operation is finished. In this case, I can secure all reading operations to avoid any inconsistencies during reading-writing operations. Press a pause for a minute and look one more time at this example. Make sure how read and write locks are connected and try to understand one more time the logic. Once you are sure that you don't have any questions regarding this example, we are good to proceed. And the last but not the least thing for today is stamped lock class. It also supports both read and write locks. It also has a feature for optimistic locking for read operations. Lock acquisition methods return a stamp that is used in other methods. For example, to release a lock or to check if the lock is still valid. In all cases, stamp has long type value. The state of a stamped lock consists of a version and mode. Try methods may return the special value 0 to represent failure to acquire access. There are three modes of stamped lock. Writing mode. When you try to acquire a write lock, it can be done using method write lock, which exclusively acquires the lock, blocking if necessary until available. This method returns a stamp that can be used in method unlock write to release the lock or in conversion of the lock. In a minute I will explain you what conversions methods are and how we can apply conversions across three modes. When the lock is held in write mode, no read locks may be obtained, and all optimistic read validations will fail. Reading mode. When you try to acquire a read lock, it can be done using method readLock, which non-exclusively acquires the lock, blocking if necessary until available, returning a stamp that can be used to unlock or convert mode. Versions with the time limit of try read lock and without time limit are also provided. Optimistic reading. This is new mode added in stamped lock. This locking mode can be visualized as an advanced booking attempt for a read lock, which may or may not be granted. Method try optimistic read is used to read in optimistic mode. This method returns a stamp only if the lock is not currently held in write mode. Method validate is used to validate if the values read optimistically are correct or not. Validate method returns true if the log has not been acquired in write mode since obtaining a given stamp. For cases where the read logs are needed for very short segments, optimistic read log acquisition can help improve performance. However, this has to be used with caution, as the write threads can change the field values and cause logical issues in the code. To be assured of thread-safe behavior, read logs should be used. Stamped log class in Java also supports methods that conditionally provide conversions across the three modes. There are three conversion methods to convert to three possible modes. Each conversion method takes long argument. This is a stamp to identify the log. For example, method try_convert to write log that takes stamp as an argument attempts to upgrade a mode, returning a valid write stamp if one of the next conditions is met. Obviously, that in case log is already in writing mode, it is instantly returned. The second condition is log is in reading mode and there are no other readers, or log is in optimistic mode and the write log is immediately available. In all other cases, 0 is returned. The next conversion method is try_convert to read log. If the stamp represents a write log, releases the log and obtain a read log. If the stamp represents a read log, then it is returned. If the stamp is for an optimistic read log, then a read log is acquired and a read stamp is returned. This method returns 0 in all other cases when the log can't be acquired. And the third method is try_convert to optimistic read. If the stamp represents holding a log, then it is released and an observation stamp is returned. If the stamp represents an optimistic read, then it is returned if its validation is successful. This method returns 0 in all other cases. The important thing about stamped log is that it is not reentrant, unlike reentrant log. So critical sections are secured with stamped logs should not call other unknown methods that may try to reacquire logs. Also, you may pass a stamp to other methods that can use or convert it. In conclusion about stamped logs, I want to say that this is really very powerful class that provides you with a lot of flexibility to tune your concurrent program execution when needed. But also, this flexibility comes with a lot of opportunities to shoot in your own leg in case you use this tool incorrectly. So in case you decide to use this class to win some milliseconds in the performance of your multi-threading program, or to save even more time, think very carefully about each line of code and how you acquire, release, and convert modes between each other. That's it regarding Log API. So if you would only think how much we learned about Log API today, you would be amazed. I believe today was a very efficient lesson. Review it multiple times if it is needed to understand more complex concepts, because knowing information from this lesson, you would be able to create concurrent applications like a pro. Now let's recap what we have learned in this lesson. In this lesson we have learned what is Log API. Now you know advantages of using Log API over synchronized blocks and synchronized methods. We learned concrete implementations of log interface and read-write log interface. After this lesson you can easily use reentrant log and reentrant read-write log classes. Also, I explained you how to use log conditions. And at the end of the lesson we have learned stamped log. That's all for today. Thanks a lot for your attention. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello dear students, in this lesson we are going to learn other synchronization tools that will help you to coordinate execution of multiple threads. The group of such classes often called synchronizers. This doesn't mean that all of them are connected with one single interface and has the same methods, but this means that this group of classes are intended to solve similar tasks in different way and with different features. In this lesson we are going to learn 5 synchronizers. They are cyclic barrier, countdown latch, semaphore, exchanger, and phaser. Also we will focus on the differences between these classes. So, if you have a set of threads that communicate with each other, we can simply reuse these classes from JDK instead of trying to come up with a custom solution with a set of logs and condition objects and the synchronized keyword. Let's start our lesson. And let's start our lesson today from cyclic barrier. And as usual, let's understand first why we might want to use this class and what problem it is going to help us to solve. In short, this class implements barrier pattern, but this doesn't tell us a lot of things. This pattern describes the case when any thread must stop at the one point, barrier, and can't proceed until all other threads reach the same point. And you can see nice visualization of this pattern on the slide. All threads should reach one barrier, and after this condition is met, we proceed our execution. Let's look at the source code of cyclic barrier class and at code example. I open source code of cyclic barrier class. Let's look at the constructors. We have 2 constructors declared in this class. One constructor with int parameter only, and another one with int parameter plus runnable parameter. So, it looks like in all cases we need to pass the number of threads that should reach the barrier. And in other constructor, we may pass the same number plus runnable that would describe action that is needed to be done once barrier is reached. I believe you already understood that we will use this class when we need a fixed number of threads that must wait for each other to reach a common point before continuing execution. How we will notify that we reached the point? Each thread should call the await method on the barrier instance to signify reaching the common execution point. The threads that need to synchronize their execution are also called parties, and calling the await method is how we can register that a certain thread has reached the barrier point. So once the await method is called, the thread calling this method suspends execution till a specified number of threads have called the same method on the barrier. This situation, where the required number of threads have called await, is called tripping the barrier. Let's look at my code example that demo how to work with cyclic barrier. Let's consider that you need to find maximum value. By the way, you are going to have the similar homework. I will not share with you here all of the solution, but in this lesson you will get significant hint how to solve the home task. The task would be about finding maximum number in multi-dimensional array with multiple threads. Each thread would find maximum number in each row. Even despite this example doesn't completely reproduce the similar scenario, it is very close to the solution. In this example, each thread would generate random number several times and would put it in the shared list. Once all threads generated enough numbers, we need to find the biggest one in the list. Is that clear? Okay, let's come up with the solution on the words at first, and after that we will put this logic in code. So, we need cyclic barrier with a specified number of threads. Once each thread would generate all numbers, we need to call a wait method on the barrier object to indicate that thread has been reached the barrier. And once all threads reach the barrier, we need to run a separate task that would find the biggest number in the list. Does it make sense? Let's review my implementation here. I declare a few constants in this class. The first constant stores the number of threads in my app that are going to be executed concurrently. The next constant is an amount of numbers to be generated by each thread. And the third constant is used to generate random number. This is maximum amount of values that may be generated. After that, I declare that I am going to have a cyclic barrier. We will initialize it later with number of threads and the callback function. Here we initialize our list variable. This is container where all threads will add generated numbers. Considering the fact we have multi-threading program here, I initialize this list variable with the reference to the thread safe array list. This is copy on write array list. And also I have random variable here initialized. I am going to use it during the generation of random numbers. Let's investigate my main method now. I create an instance of this demo class. I'm going to use this variable to invoke non-static methods and to be able to create method references to non-static methods declared in this class. After that, I initialize my barrier. I pass the number of threads that I expect would reach the barrier, and I pass the reference to the method that should be executed once all threads would reach the barrier. It is called number generation callback. In case you are not familiar with the method references and other functional style syntax in Java, please refer to my functional programming course where I explain a lot of concepts about functional programming style in Java. Now, let's look at this method. I use benefits of Stream API to find max number among generated ints. I convert my stream into int stream that has max method. Max method returns optional int, and I extract int from it. And after that I print all numbers that I have in my generated list and the biggest number. In main method I create executor service. This is fixed thread pool for 4 threads. In the next line I submit 4 tasks that are going to be executed concurrently. Let's look at the method that I use in method reference here. Generate numbers method should generate numbers and put all of them into the shared container. Here I use object of the random type and call next in specifying limit for the range to generate random value. And after we finish the loop and generated all numbers that thread should generate, we are moving further. When thread reaches the barrier, we need to call await method to indicate that thread is arrived to the point and is going to await other threads. I print the returned value by await method. Await method returns the arrival index of the current thread, where index returned by expression getParties -1 indicates the first to arrive, and 0 indicates the last to arrive. For demo purposes, I decided to print the result of getParties method after we submitted all tasks. GetParties returns the number of parties required to trip this barrier. It looks like this is all code. Let's run this program now. In console output we can see the result of getParties method. So we have 4 here because we initialized our cyclic barrier with 4 int value. After that I printed a list with generated numbers and maximum value. You can check everything is correct here. Also you can see the result of await method printed by each thread. You can see how the arrival index is different depending on when thread arrived. Press pause for a minute if it is needed to understand this example better. In case of any questions, let me know below this video. Let's proceed with the next example. The next class that we are going to discuss is a countdown latch. Countdown latch is used to make sure that a task waits for other threads before it starts. We can simplify this even more. A countdown latch has a counter field which you can decrement as we require. In other words, this is a class that allows one or more threads to wait until a set of operations being performed in other threads completes. But probably the main question here is how the countdown latch is different from cyclic barrier that we have just learned. We are going to answer this question too. But let's first have a demo of countdown latch to understand what we are going to compare with cyclic barrier. Okay, I open countdown latch demo file. In this file we are going to have a very simple example. I have constant here that is equal to 4. This is the value that we are going to use for a countdown. In the main method I create countdown latch. This class has only one version of constructor and int argument is mandatory, so we can't initialize countdown latch without count. After that I create executor service. Pay attention, I create fixed thread pool for 2 threads only, not for 4. In the next line I'm going to submit 4 tasks that will be executed by 2 threads. Let's look at the task that is going to be executed. I create here instance of a worker type and pass into constructor the reference to the countdown latch. For the sake of the demo, I created worker class that relates to this example inside the same file. Let's look at it. It implements runnable interface. With the help of constructor, we initialize in a field. In run method, we imitate that we are doing some work. We also log the moment before we call countdown on my countdown large object. In the main method, we call await method on the countdown large object right after we have submitted 4 tasks. And when task will be executed 4 times, and we will call countdown 4 times until counter will become 0, only after that we are good to proceed with program execution after await method. After that, we will print large is released and program will finish execution. Let's run it now. In console you can see that we called countdown 4 times until we print large is released. So this is how countdown large works. And now, when you know how countdown large works, let's ask question. What is the difference between this class and cyclic barrier? Let me answer this question. It also will help us to understand the countdown large better. The first difference is that cyclic barrier works with threads, but countdown large works with tasks. Do you remember that in the last example I put your extra attention on the fact that 4 tasks will be executed by 2 threads? You can find source code examples in attachments to this lesson, and you can try to do the same trick for cyclic barrier. I mean having less threads than tasks. It would be hard to accomplish because in cyclic barrier you call a wait method that makes current thread waiting for other threads, not for other tasks completion. In countdown large we calculate number of countdown method invocation, and in cyclic barrier we calculate number of threads that called await method on the barrier. Do you understand the difference? Another thing is that cyclic barrier allows you to execute function once all threads reached the same point. You can't do the same thing in the countdown large. The next thing is related to reusability. You can reuse cyclic barrier once barrier is broken and all threads are released. When the barrier trips in cyclic barrier, the count resets to its original value. Basically, you can use it multiple times without any restriction. Countdown large can't be reused. When count arrives at 0, it can't be reset. Another difference is that in a cyclic barrier, if one thread is interrupted while waiting, then all other waiting threads will throw broken barrier exception. Whereas in countdown large, if the current thread is interrupted, it will throw interrupted exception. It will not impact other threads. This is the difference between cyclic barrier and countdown large. Hope that it is clear now. Okay, if this is clear, let's proceed with the next synchronizer. Let's learn now how to work with a semaphore and what it is. Semaphore term is not specific to JDK only. It is a common pattern in multithreading programming. Usually, it is a variable or abstract data type used to control access to a common resource by multiple threads of execution and avoid potential concurrency issues that may happen because of multiple threads accessing the same piece of code simultaneously. The simplest semaphore implementation is a plain variable that is changed, for example, incremented or decremented or toggled, depending on programming-defined conditions. Another way to imagine semaphore is to imagine a system that stores information about number of threads that got access to particular resource to adjust this resource safely and track number of threads that released the resource. And in case it is not allowed to grant access to the shared resource for more threads than it is specified, threads should wait until semaphore would allow to enter critical section again. Let's look at the source code of a semaphore class, and after that, let's investigate the code example together. I open the source code of a semaphore class. Let's look at constructors that we have. We have 2 constructors available, one with int parameter and another one with int parameter and boolean value. So you have to pass the number of permits available. These are permits to enter the critical section. This value theoretically even may be negative. In this case, releasing must happen before any acquires will be granted. But practically, most likely you would never pass negative value to the constructor. And in the other version of constructor, you should pass boolean flag. In case you pass true here, That means you want to create a fair semaphore. Fair means that this semaphore will guarantee first in, first out granting of permits under contention. False would mean opposite. Let me also show you a few the most important methods from this class. Try acquire method. Returns true if a permit is available immediately and acquire it. Otherwise, returns false. In case permit is not available instantly, thread is blocked and waiting until the one will be available. This method is overloaded and we have different versions of this method. Try acquire with timeout, where you can pass different time unit values. This method will return false in case waiting time elapsed and permit wasn't acquired. Also, there is a try acquire method with int parameter. This method acquires the given number of permits from this semaphore, only if all are available at the time of invocation. And combination of the previous two. You can pass the number of permits you want to acquire and timeout that you are happy to wait. As you may also notice, acquire method may throw interrupted exception. Taking into account thread is in waiting state trying to acquire a permit, it may be interrupted by another thread. In case you want to make sure that thread won't be interrupted while waiting for a permit, you should use acquire uninterruptibly method. The next method that I'd like you to know is release. This is an important method that we should never forget to invoke when we want to release a permit and return it to a semaphore. Also, this method is overloaded and we can call release method with int argument. In this case, I may release more than one permit and return it to the semaphore. Available permits method returns the number of permits that are available for acquisition at this moment of time in this semaphore. I believe that you already understood that we can use semaphores to limit the number of concurrent threads accessing a specific resource. I open semaphore demo class. In this example, we will implement a simple login queue to limit the number of users in our application. We are going to use methods that we have just reviewed. Try acquire, release, and available permits. Let me run this program and I will walk you through the console output line by line. I declare a variable that will store the number of available login permits. So in this case, only 10 people can be logged in simultaneously, and all other users who want to log in should wait until one of the users who is already logged in would call logout method. I create executor service with 4 threads. After that, I create an instance of this demo file and pass in the number of permits to constructor. In constructor, you can see that we just initialize the semaphore property of our demo class with number of permits that we have passed to the constructor. Assuming that we submit the same amount of tasks as we have permits to access the command to login, we should run out of tasks after all of them are completed. Try login method just acquire permit from the semaphore, and in case permit has been acquired, I print text to console about successful login. In case permit hasn't been acquired, we recommend to try one more time later. But this is just an example. Actually, you can put any logic you need based on the status and if you manage to acquire permit or not. I wait 2 seconds only to let all threads be completed. This is again for the sake of the demo. In this case, when I would check amount of available permits to log in, I would print 0 to console. By the way, this method just calls available permits method on my semaphore object. And when I next time try to log in, there are no permits already, and I would enter else block in my try login method. But what would happen in case one of the users will log out? I call logout method that simply releases the permit and returns it back to semaphore. Now I can try to log in one more time, and it is a success. I managed to log in. So semaphore is like a counter that tracks how much permits are acquired, how many left, and how much again released. And you saw in the example how it works. Now it is time to learn Exchanger. Let's understand how Exchanger class may be helpful. Exchanger helps us to exchange data between threads at some point. Exchanger is a generalized type. so you can parameterize the instance of this type with the type of exchanging data. There is a synchronization point where threads may pair and swap elements. Actually, there is not so many unique behaviors in this type. Let's look at Exchanger class source code and code examples. I open the Exchanger class source code. Basically, there is only one public method, exchange. It is overloaded. You can call exchange method and pass the value that you wanna send to another thread, and you receive another value in return. This method puts thread in waiting state, because thread needs to wait until other thread would arrive to exchange point. An overloaded version of the exchange method defines additional parameters, long and time unit. We can define how long we allow one thread to wait for another before complete exchanging. Let's review code example. I open Exchanger demo. The first thing that I do in main method, I create Exchanger object parameterized by string. After that, I declare two tasks. In the task number 1, I call exchange method on the Exchanger object to get message from other thread and pass the message to another thread. After that, I print message received. Considering that exchange method moves our thread into waiting state, we should handle potential interrupted exception. The second task is similar one. The only difference is the text that I send to another thread and a little bit different console output here that indicates that this console output from another task. After that, I create executor service and submit my two tasks. Then I shut down my executor service. Let me run this program. And in console output you can see how messages from different tasks has been exchanged when each thread reached the exchange point. Basically, that's it. And this is how Exchanger works. Let's continue. And the last but not the least for today is Phaser class. Similar to cyclic barrier, Phaser implements barrier pattern, but provides us with more flexibility. With this type, you can synchronize threads that represent separate phase, step of the whole execution goal of the common action. The number of threads that participate in this process is not fixed. It can be configured dynamically. The same as cyclic barrier, Phaser represents a synchronization point where multiple threads should meet each other. When all threads arrived, Phaser goes to the next phase and waits all threads at the next point. Important thing to mention here is that in most of learning literature, often Phaser is compared with cyclic barrier. But why? Why we don't compare it with countdown latch? Phaser tracks threads, but not actually tasks. So recommended to call register method for the same amount of threads that will call one of the methods that indicates arrival. Let's compare Phaser with cyclic barrier. During the comparison, it is worth to mention next things. Let me flag the things that Phaser has and cyclic barrier doesn't have. Support of multiple phases. Each phase has a number. The number of threads that are participating is not limited and is not fixed. Thread may take part and after that cancel all participation. Thread shouldn't necessarily wait for other threads reach the synchronization point. To continue its work, it is just enough to notify about arrival and proceed execution. This is something what is available in Phaser but not available in cyclic barrier. In comparison to cyclic barrier, there is not action attached that potentially might be executed after all threads reach specific point. Definitely, these are not all of the differences, but just a few main differences. We are going to learn Phaser deeper in a few seconds, and you would be able to find another differences too. So let's have a demo. I am going to start from the source code of the Phaser class. Let's review main constructors and methods. To create Phaser object, I recommend you to use one of the two possible constructors, the default one without parameters and with int parameter. If you create Phaser with default constructor, barrier will be closed until all registered participants would reach the barrier. In case you create Phaser with int argument, barrier will be open once specified number of threads would reach the barrier. Also, there is a constructor with phasor argument to pass the reference to the parent phasor, but we are not going to review it now because it is very rarely used. Register method should be called when thread wants to participate in phasor. The method adds a new unarrived party to the phasor. Note that this only increases the number of registered parties, and we can't check whether the current thread is registered or not. When the thread is arrived to the barrier, we should signal that it is arrived. To do this, we need to call arrive and await advance method. This is blocking method that moves thread into waiting state. When the number of arrived parties is equal to the number of registered parties, the execution of the program will continue, and the phase number will increase. In case a thread doesn't want to wait for other threads and just wants to continue with the next phase, we need to invoke arrive method. This method signals that the thread reached the barrier. Usually, different variations of methods that indicate arrival return int value. This is usually the number of the phase. If we know that our method will not participate in the next phase, we need to call arrive and deregister method. This method deregisters thread from the phasor without waiting others to arrive. Current thread should no longer be accounted for in this particular phase and the following phases. We can get the current phase number by calling the getPhase method. Also, you can check status of phasor using these methods. GetRegisterParties will return the number of registered threads. GetArrivedParties method will return the number of arrived parties at the current phase. Let's now review code example and learn how to use this. I open phasor demo class. Let me run the program, and I will walk you through the console output. In the class, I have one constant here. This is just to be able to configure number of threads quickly. I create phasor object that I am going to use to synchronize work of multiple threads. In main method, I create executor service. I have fixed thread pool. For demo purposes, I print phase number before we start the execution of tasks. And when we have just created phasor, the phase number is equal to 0. After that, I submit the same number of tasks as total threads number. I have nested class task here that implements runnable interface. For the sake of the demo, I decided to keep all related examples inside the class. Let's look at it. We have phasor property here that is initialized via constructor. All threads should have the reference to the same phasor in order we could make synchronization of those threads. Also, in constructor, I call register. In run method, I have console output for demo purposes. Once run method is started, you can execute any code you wanted that contains your business logic. In our case, I just print thread name and call arrived and await advance method. After that, thread sleeps for 100 milliseconds to make sure that other thread arrived to the same point. This is for demo purposes only. Arrive and await advance returns arrival phase number. We are going to have 1 here. After the sleep, I call getPhase method, and I am going to have the same number 1 here, because we are in phase 1 already, and phase with number 0 is over already. The next thing I do here, I log again thread name and signal that thread is arrived. Arrival phase number would be 2 now. And I print the result of getPhase method one more time. We are going to have 2 here too. And once we are done with all steps and all phases, we can call arrive and deregister method. In main method, I wait for 1 second to make sure that all threads are deregistered. I call getRegisteredParties method to make sure that no threads are registered in my phasor anymore. Is that clear? Press a pause for a minute and review this example. Also, as usual, you are going to have links to the all source code examples, and I recommend you to run this example on your computer to understand it better. Play with different methods of phasor object. This should help you to understand this class better. And anyway, in case you have any questions, please let me know. You can leave your question below this video. Now let's recap what we have learned in this lesson. Now you know what synchronizers are. We learned with you cyclic barrier, countdown latch, semaphore, exchanger, and phaser. Now you know how these classes are different and how you can use them. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team, in this video we are going to review home tasks for multi-threading topic. Now you have enough knowledge to deal with them. And even more, by this moment we learned so many things that you can solve the same tasks with multiple ways. For example, you can solve synchronization task with synchronized methods, synchronized blocks, locks, or synchronizers. Let's review tasks first, and after that I will tell you where you can find solution for these tasks in order you could check your solution later. So, in this file you can find all home tasks that I recommend you to implement to make sure you have enough skills in multi-threading programming. We are going to start from the super simple and gradually come to more complex tasks. You can find the reference to this file in attachments to the lesson. Let's review these tasks together, and I will give my comments as we go. The first task is simple one, and just to practice your skills in creating threads in different ways and being able to interrupt threads. It is recommended to create and start a thread in 4 different ways. By implementing runnable interface, by extending from thread class, by passing lambda function to constructor of thread class, and by passing the method reference during the thread object instantiation. All of these ways were reviewed in this course, so don't hesitate to navigate between the lessons to find the answer to this question. The next task is a little bit more complex than the first one, but still, I am sure it will be easy for you to implement. You need to create spam type that will spam messages with the specified interval of time. And also, you need to implement logic of thread interruption after enter key press. I can give a hint you here. You can try to implement this logic by creating a separate daemon thread that would constantly listen for new line character that is similar to pressing enter during the program execution. And once new line character is received, we interrupt the spam thread. Besides the knowledge of multi-threading, this task also needs knowledge of input-output streams in Java. In case you have never worked with I/O streams, please watch my Java course, namely section about input and output streams in Java. The third task is already about thread synchronization, similar to the ones that we have reviewed in lessons, but again, seeing task solution in the lesson and trying to implement it by yourself, it is different things. So, try to implement this task and understand better how synchronized block works. Task number 4 is a little bit more complex. In short, you have to find maximum number in multi-dimensional array. It is recommended to create multi-threading solution and single-thread solution in order you could see the benefits of concurrent computing. Also, I recommend to solve this task twice in order to practice different things. The first variant will be implementation with scalable and future objects, and the second variant will be implementation with countdown latch object. Implementing this task with 2 different ways will let you understand how these 2 solutions are different and what would you prefer to use in your projects. And the last but not the least, task number 5. The standard task about writers and readers. Few students of mine has been asked to implement tasks about readers and writers during the interviews. This proves that this kind of tasks are popular during the interviews. You have to implement reader and writer type and create objects of these types that would work together. Writer writes to the buffer, readers read from the buffer. Everything is simple. In case there is nothing in buffer, something should be written there. In case buffer is full, messages should be consumed. There are some specific conditions that I'd like you to implement in your solution. For example, limit your demo with 3 cycles of writing and reading. Limit your demo to 3 readers and 1 writer only. Total duration of the program execution should not be longer than 2 seconds. This check is also important in order you do not build logic of thread synchronization only using thread sleeps. Similar to the previous task, I'd like to ask you to implement this task in 2 different ways. The first option is implementation with dummy objects that will be used as monitor to synchronize all threads. Also, you can practice in using wait, notify, and notify all methods. And the second option is implementation with log API. It would be just perfect for you to understand how to use logs in places where we use synchronized blocks and how flexible they are. The reference to the source code of the solution to these tasks you can also find in attachments to the lesson. In general, if you already pulled my learning project, you can find all solutions and different versions of solutions in the multithreading package in homework sub-package. All tasks have number in their name, so I am sure it would be easy for you to navigate between them. But try to solve tasks by yourself first, and after that look at the solution. In case for some reasons it is hard for you to solve some task, try to watch lesson about the specific topic one more time. If this still doesn't help, try to look at the solution and rewrite it as you understood. The thing that I am trying to achieve is that you're trying to understand the solution, but not just do it. And remember, you're going to make mistakes, and that is fine. Not learning from that mistakes, it is the biggest mistake. These are all tasks. You are more than welcome to ask questions under the video in case of any. That's it. Thank you for your attention and see you in the next lessons. Hello team, in this lesson we're going to start learning JDK API that will allow us to work with date and time in our Java programs. I can say already at the beginning of the lesson that working with dates and time in JDK is probably the most chaotic topic. Because you can work with different classes from different packages that are doing either the same thing in different way or slightly another thing. But still it works to know different classes that exist, because different classes from JDK relies on different abstractions and you need to use specific implementations that work the best in conjunction with other specific classes. In this lesson we are going to start from theory in order you could understand what a time is. I'm sure you know what a time is, but I would like to cover specifics of different time standards that are used across the world and in programming. After we learn theory, I will start explaining such basic classes from JDK as calendar and date. Both of these classes are located in Java util package. This is important to understand because there is also another date class from Java SQL package that is completely another class and used for other purposes. We are going to learn that one when we'll learn JDBC. In this lesson you are going to understand what Unix epoch is, how to parse date from string and format it according to specific time zone, and lots more. In this lesson we are going to have a lot of examples, and at the end of the lesson I will explain drawbacks of calendar and date type and why there was a need in releasing Java time package in Java 8. By the way, we will also cover classes from Java time package, but not in this lesson, in the next one. Let's start. But before starting learn JDK, let me share with you a small piece of theory about time that will help us to understand this topic better. They are different, I would call them time measurement standards in the world. There are such terms as Greenwich time, UTC time, Unix time, UT time. You already know what a Unix time is, but let's now understand what do other terms mean. Universal time is a time standard based on Earth's rotation. There are several versions of universal time, which differ by up to a few seconds. The most commonly used are Coordinated Universal Time, UTC, and UT1. Also there are different versions like UT0, UT2, UT1R. All of these versions of UT, except for UTC, are based on Earth's rotation relative to distant celestial objects, stars and quasars, but with a scaling factor and other adjustments to make them closer to solar time. Whereas UTC is based on International Atomic Time, with leap seconds added. GMT stands for Greenwich Mean Time. It is the mean time at the Royal Observatory in Greenwich, London, counted from midnight. At different times in the past, it has been calculated in different ways. including being calculated from noon. As a consequence, it cannot be used to specify a particular time unless a context is given. People usually use GMT as a synonym for Coordinated Universal Time, UTC. In modern usage, this is incorrect. GMT is now a time zone, not a time reference. The term GMT should not thus be used for purposes that require precision. Although the date class is intended to reflect Coordinated Universal Time, it may not do so exactly, depending on the host environment of the Java virtual machine. Nearly all modern operating systems assume that one day is equal to 24 hours times 60 minutes in an hour times 60 seconds in a minute, that is equal to 86,400 seconds. In UTC, however, about once every year or two, there is an extra second, called a leap second. The leap second is always added as the last second of the day and always on December 31st or June 30th. For example, the last minute of the year 1995 was 61 seconds long, thanks to an added leap second. Most computer clocks are not accurate enough to be able to reflect the leap second distinction. What you need to know is that the Earth's rotation is not uniform. It slows down and speeds up in complicated ways. UT does not always flow uniformly. Leap seconds are introduced as needed into UTC so as to keep UTC within 0.9 seconds of UT1, which is a version of UT with a certain corrections applied. There are other time and date systems as well. For example, the timescale used by satellite-based global positioning system, GPS, is synchronized to UTC, but is not adjusted for leap seconds. And now, when you know all this, we are good to proceed with learning time and date in Java. Today, mostly we will be learning APIs of different classes, so I'm starting screen sharing right away in order to review with you source code of classes and examples. The main classes that we are going to focus our attention on are calendar and date. Definitely we'll discuss other classes too as we go, but these two are main for today's lesson. Let's start from calendar. I open demo file that is located in date package in our training project. Feel free to find the reference to all demo examples in the attachments to this lesson. In this demo file, I am going to have separate methods that will demo either separate piece of functionality or separate class. I am going to run this program and walk you through the console output as we go. The first example is related to calendar class. Let's open calendar class. The first thing that is worth to mention here is that calendar is an abstract class. This means that you need to choose which implementation you would like to use. Let's open type hierarchy and see what implementations do we have here. To be honest, Gregorian calendar probably is the most popular one. But also we have here Japanese imperial calendar and Buddhist calendar. Let's talk a little bit more about calendar as a type. This type provides methods for converting between a specific instant in time and a set of calendar fields, such as year, months, day of the month, hour, and so on, and for manipulating the calendar fields, such as getting the date of the next week, for example. An instant in time can be represented by a millisecond value that is an offset from the January 1st, 1970s midnight GMT. This is called Unix epoch time. Unix time is a system for describing a point in time. It is the number of seconds that have elapsed since the Unix epoch, minus leap seconds. The Unix epoch is midnight UTC on January 1st, 1970s, an arbitrary date. A lot of classes uses this date as a 0 point to calculate time in milliseconds. Every positive number represents the time after January the 1st of 70s, and negative value represents all times before this date. The class also provides additional fields and methods for implementing a concrete calendar system outside the package. Let's now get back to the demo file in order you could see how to work with this type. I believe this will help you to understand this type faster. I declare a variable of calendar type and assign to it object of Gregorian calendar. This class has a lot of different constructors. Let me open the source code of Gregorian calendar and investigate this with you. The constructor without any parameters creates the object using current time in default time zone. Or you can create calendar object for current time but in different time zone. In this lesson I will also show you how to work with time zones and use them. We can create calendar in different locale. We are going to have separate lesson about localization and internationalization. I will cover locale topic in that lesson. Just for the sake of this lesson, you can imagine locale as an object that stores configuration and information about specific data format representation for a particular region. An operation that requires a locale to perform its task is called local sensitive and uses a locale to tailor information for the user. Also, we have constructors that allows us to instantiate calendar object with different time units: year, month, day, hour of the day, minute, seconds, milliseconds. Let me go back to demo file. After I created calendar object for the specified date, I can work with it. I use get method that takes int argument. Instead of pure int value, I pass constants that describe specific calendar field. Here is how I can extract the value of each field. For the sake of the demo, I print these values to console. Let's move on. Now I want to review with you source code of another method, simple date format example. Another interesting class that is used together with calendar endurance date formatting. Simple date format from Java text package. The idea is simple. We can create an object of this type and pass the pattern that would describe how I wanna format the date. And each time unit has its own placeholder. For example, use Y for years, use capital M for months. Pay attention that the number of placeholders also will impact the final formatting. For example, in case you put 3M in a row, this means that you want to print certain name of the month, but not month's number. If I would have 2M here, that would mean I want to print sequential month's number with heading 0 in case I have months that is less than 10. Does it make sense? Day is small d, hours are capital H, and after that we have minutes and seconds. The whole list of placeholders and formatting rules you can find in official documentation of simple date format class. Probably the most popular placeholders and rules we have just discussed, but just in case you want to learn more, open documentation for the class, either Java doc or just source code, and you would find all the details. In the source code, probably it will be hard for you to read this documentation, because it uses HTML markup, but still it is possible to understand. After I created simple date format object, I wanna print to console the string that will be returned after invocation of format method. Format method takes date object as method argument. You can easily convert calendar to date object by calling getTime method that returns date object. And considering that I have Russian default locale on my computer set now, I see shortened version of month's name in Russian. But a simple date format also has different constructors, and one of the constructors takes locale as method argument. Now I can pass United States locale and format the same date with this formatter object. I format date with the help of this formatter, and let's look in console what we have. Now I have February printed in English. This is because of locale. And let me create one more simple date format object and print result of formatting to console. I created new object of simple date format with slightly different pattern. Pay attention that we have the same letters but different number of them. For example, I have 2 Y's and 1 M. Besides that, I pass locale. And what we have in console in this case? You can see that in console after formatting I see only two last digits of year, only one digit to represent the month. February is the second month, so everything is correct here. That's how date formatting works. Press a pause for a minute to think about this example. In case you have any questions, do not hesitate to write them below this video. Let's review date example now. Similarly, I have separate method that is called date example that contains all related lines of code. So let's review this method. Date class represents a specific instant in time with millisecond precision. Date has also different constructors, including constructors that allow us to set year, month, day, and other time units. But these constructors considered to be deprecated in JDK in favor of calendar class. There are only two constructors that are not deprecated. They are constructor without arguments that represents the time when it was created, and constructor that takes milliseconds argument. You already know what the Unix time is and what these milliseconds mean. So, here an example. For the sake of the demo, I create three objects of date type. And you can see that Eclipse tells us that constructor with specific date is deprecated. In the third constructor, I passed actually random long value and printed this date to console. Just look at the year. I don't know whether solar system and Earth still will exist by that time, but you can be sure that long time has enough milliseconds to cover even this date. What are other ways to get date object? We can parse date object from the string. Imagine that you are either parsing some web page or you get date string as request argument. Anyway, there might be different cases when you receive date as string and you need to convert it into date object in order to proceed working with this data. To do this, we again need help of simple date format class. I create object and describe the date pattern that I wanna parse. Then I call parse method of simple date format object. This method returns me object of type date. Also, pay attention to the fact that this method may throw parse exception. This may happen in case pattern was specified in simple date format object can't be applied to the string that we have passed into the parse method. In our specific case, format of date meets our pattern and we successfully get date object. I print it to console here. I can convert date object back to string without any problems. We already have our simple date format. I just call method format and pass date object. And as a result, I have the string that is formatted according to the pattern. Now, let's look how to work with Java util time zone object. In the separate method time zone example, I have few lines of code that demonstrates how to work with time zone. I create simple date format object, specify pattern, and with a special setter method, I can set time zone for this object. This time zone will adjust the specified date according to the specific time zone. I call getTimeZone method and pass timezone ID there. This can be either an abbreviation such as PST, a full name such as America/Los Angeles, or custom ID such as GMT-8. Working with time is always hard, and also it is always hard to consider all possible time zones and work with them properly. But personally myself faced multiple times with business requirement to consider local time of the user at the specific moment of time of program execution, and the formatting we have just learned may help you in this. Later in this course, we will learn also other classes from Java time package that will do the same work. I create object and format it. Time zone itself also has a lot of different methods. You can get specific offset, or you can call observe daylight time method to check if some time zone is currently in daylight saving time. As a part of your homework, look through the source code of this class. In my opinion, the most popular usage of this class is invocation of getTimeZone method. Also, after releasing Java Time package, existing classes were updated with API that allows to convert type between each other and work with different types. For example, we can easily convert TimeZone into ZoneID object from Java Time package. Later in this course, we will also learn ZoneID type in details. You can call toZoneID to convert TimeZone object. Also, we can use ZoneID to get TimeZone. In my demo file, I have another example. I call overloaded version of getTimeZone method that may take ZoneID as method argument. Static method of from ZoneID class may return ZoneID by string ID or by offset. In case string is started from plus or minus, the string is taken as offset. If the zone ID consists of a single letter, the zone ID is invalid and date-time exception is thrown. I print two dates to console and you can see that actually the same date during the formatting, considering different time zones, shows different values. Time zone objects also used in calendar type. For example, there is a static method that is called getInstance to instantiate calendar object based on your default locale. The method takes time zone as method argument. You can also set time zone with the setter method. Let's review another class now that is called ZoneID. As you saw, we already used it, but primarily this type is used in other classes from Java Time package, but I believe it is worth to review it now because we can use it to create time zone object. I have another method, ZoneID example. In this simple example, I decided to call getAvailableZones and print all of them to console in order you could investigate all the variety of time zone IDs that you can use during the instantiation of time zone objects. getAvailableTimeZones method returns a set of strings with time zone IDs. If you're interested how to work with streams and method references, you can check my Java Collections Framework and Functional Programming in Java courses. I review such topics there in details. And here I have examples that shows how to convert date and calendar between each other. To convert date to calendar, just create an instance of a calendar and call setTime method and pass date object as method argument. And if you want to convert calendar to date, just call getTime method. It returns date object. Easy. Now, when you know calendar and date classes, let's try to understand why there was a need in releasing new tools to work with time in Java Time package. On the internet, you can find different criticism against these classes, but in my opinion, none of comments is critical enough to declare these classes as deprecated in JDK. I am talking about calendar and date. That's why you may use these types whenever it is needed, and they are still actively used by other classes in JDK. But still, I would like to draw your attention to some points, at least to make you aware of. Thread safety. The date and calendar classes are not thread safe, leaving developers to deal with potential multi-threading issues and to write additional code to handle thread safety. On the contrary, the new date and time APIs introduced in Java 8 are immutable and thread safe, thus taking the concurrency headache away from developers. API design and ease of understanding. This drawback is also mentioned in the internet by other engineers from Java community. I am not completely agree with it, but it contains seed of truth. The date and calendar API are designed with inadequate methods to perform day-to-day operations. I would say that it depends what day-to-day operations you perform, but definitely the new date-time API is ISO-centric and follows consistent domain models for date, time, duration, and periods. There are a wide variety of utility methods that support the most common operations. Zoned date and time. Developers had to write additional logic to handle time zone logic with the old APIs. And you already saw examples and what it took us to format date according to the time zone we are interested in. The things are different in Java time package. With the new APIs, handling of time zone can be done with local datetime and zoned datetime APIs easier and in more natural and object-oriented way. These are few of the main items that naturally led Oracle to release of the Java time package. But this is actually all what I wanted to share with you in this lesson. Let's review what we have learned in this lesson. In this lesson we have learned a lot of interesting things. Now you know what GMT and UTC is and what is the difference between these standards. We learned calendar and date classes. In the lesson we reviewed how to parse date from string and format it back to string. We held overview of Java util time zone class and you saw code examples with it. And at the end of the lesson we learned drawbacks of calendar and date classes. I am sure you enjoyed the lesson. After this lesson we are ready to learn more about work with date and time in JDK. In the next lesson we are going to learn classes from Java time package. And that's it for this lesson. Thanks a lot for your attention, team. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hello team, in this lesson we proceed learning how to work with date and time in Java. You already know the basics of working with time in Java and learned different time standards and key terms. If you didn't watch the previous lesson about time, please do not skip it. Make sure you watch the previous lesson before you get to this one. In this lesson we are going to learn classes from Java time package and how to work with them. We are going to start from general overview of Java time package. I am going to explain you more about structure of this package and I will share with you my classification of all classes inside this package, in order you can remember them easier. After that, we are going to spend significant amount of time during the lesson to review the source code of classes and code examples. We'll review in detail such important classes as instant, local datetime, zoned datetime, offset datetime, clock, period, duration, and many others. In this lesson, I will show you how to work with these classes. I prepared a lot of examples. As usual, you can find source code of examples in attachments to the lesson. Let's start. And before we get to code examples, let's learn a little bit of theory. Let's quickly perform an overview of this package before we get closer to the concrete classes and source code. The datetime package, Java Time, introduced in Java version 8, provides a comprehensive model for date and time and was developed under GSR 310. Date and Time API. The GSR 310 design ensures that each method of the core API is able to fully define its input and output by focusing the entire class on a single calendar system. Instead, users with advanced requirements have to study the API a little more closely and use the low-level temporal classes. Although Java Time is based on the International Organization for Standardization calendar system, commonly used global calendars are also supported. The API includes date and time, date without time, time without date, offset from UTC, time zone, durations, periods, formatting and parsing, a selection of calendar systems. In order you could understand package structure easier, I recommend to group time-related classes into two categories. We can classify dates and time into two basic use cases: machine scale and human scale. What is the difference and what classes in which group? Machine scale time represents the passage of time using a single, continually incrementing number. The rules that determine how the scale is measured and communicated are typically defined by international scientific standards organizations. Two key classes are defined to represent machine scale time: instant, an instant on the timeline; duration, a duration of time. These classes use nanosecond precision. The classes have sufficient accuracy to represent any nanosecond instant within the current age of the universe. Unix epoch is used as a starting point for time calculation. Human scale time represents the passage of time using a number of named fields such as year, month, day, hour, minute, and second. The rules that determine how the fields work together are defined in a calendar system. The design adopted splits the classes into value types and field units. The high-level API contains following key classes: local date, a date with no time; local time, a time with no date; local date time, this is date time type. These classes represent a time without a time zone in the ISO 8601 calendar system. These classes don't store or represent a time zone. Instead, it is a description of the local time as seen on a wall clock. It can't represent an instant on timeline without additional information such as an offset or time zone. In the classes above, there are methods that allow us to get the instance of the above-mentioned types with specific zone ID. I believe you're already familiar with zone ID from previous lesson, and you can understand that sometimes you want to have times that accounts time zone. And following classes has offset. Offset time, a time and zone offset with no date; offset date time, a date time and zone offset. It stores all date and time fields to a precision of nanoseconds, as well as the offset from GMT UTC. For example, the values that you can see on the slide next to offset time can be stored in offset time. Zoned data time, a data time, zone offset, and time zone. A data time with a time zone is the ISO 8601 calendar system, such as the example shown next to zoned date time on the slide. Zone offset, an offset from the time in UTC GMT. Zone ID, a time zone identifier used to find the underlying rules. Each of these date-time classes represent time in the ISO calendar system, defined by ISO 8601. This is also known as the proleptic Gregorian calendar system, and is the de facto civil calendar system used today in the vast majority of the world. Each date-time field can be represented as a value, which is expressed as the value of type long. I mean milliseconds since Unix epoch. Some fields also have an enum defined for code clarity and safety. These include months, day of week, AM, PM, and quarter. Although there are lots of classes and each class has lots of methods, the conceptual weight of the API is greatly reduced through consistent use of method name prefixes. That's why it will be easier for you to understand API of new class in Java time package if you're already familiar with other class from the same package. Some of the prefixes are get the specified value; with, returns a copy of the object with the specified value changed. For example, such methods as withHour, withSecond that set the specific value to a particular time unit. Plus, minus returns a copy of the object with the specified value added, subtracted. Multiplied by, divided by, negated returns a copy of the object with a specified value multiplied, divided, negated. 2. Converts the object to another related type. Add returns a new object considering of this date time as a specified argument, acting as builder pattern. Of factory methods that don't involve data conversion. From factory methods that do involve data conversion. Applications also commonly use the temporal adjuster interface, the standard implementations provided in temporal adjusters. These prepackaged common manipulation functions like next Wednesday or the last day of the month, they are especially valuable in capturing the intent of the business logic. Dates and time are formed from fields and units. A unit is a measurable unit of time, such as year, month, or hour. The set of known units can be extended by applications. A field is used to express part of a larger date time, such as year, month of year, or second of minute. The set of known fields can also be extended by applications. Now it is time to see the demo with some of these classes from Java Time package and understand how to work with these classes on practice. And we are going to start our examples from the super popular class from Java Time package. I use it many times and I have seen other engineers use it very often. We are going to start from instant class. Java instant class is used to represent a specific moment on the timeline. This might be used to record event timestamps in the application. Like many other classes from Java Time package, this class is also immutable and thread-safe. Unlike the old Java util_date, which has milliseconds precision, an instant has nanoseconds precision. Representing a point in time using nanoseconds precision requires the storage of a number larger than a long. To achieve this, the class stores a long representing epoch seconds and an int representing nanosecond of second, which will always be between 0 and billion. The epoch seconds are measured from the standard Java epoch of January 1st, 1970, where instances after the epoch have positive values and earlier instances have negative values. I open file that is called instant demo. Let's start from learning how we can create instant object. There are different ways to do this. Various static methods that take in different arguments may help us to instantiate instant object. Here are a few examples. With the help of now method, we'll return instant that is equal to the current moment of time. With the overloaded version of now method that takes clock argument. Later in this lesson we are going to learn clock class. But just to let you know that you can pass any object of clock type to instantiate instant object. Also, there are methods that allow us to create instant object either from milliseconds or from seconds. Here you can see example of epoch milli and of epoch second method. Considering the fact that instant object has nanoseconds precision, you can be super accurate by specifying nano adjustment to seconds. In the of epoch second method, you can pass two arguments, seconds and nano adjustment. And also you can parse instant from string date. Pay attention that there is a specific requirement to the format of the string. The string must represent a valid instant in UTC and is parsed using datetime formatter ISO instant constant. Besides that, you already know Java util_date class. That class has methods that allows to convert date to instant. So just call to instant method and you will get reference to the instant object that is equivalent to the date one. And it is also worth to mention that we can convert values in two directions. For example, I can easily convert instant to milliseconds. Here is an example. The epoch milli method returns us milliseconds. Let's move on. An instant object contains two fields internally which holds the time represented by the instant. Seconds since the epoch and nanoseconds, part of the instant which is less than 1 second. We can access both the seconds and nanoseconds via these methods. Get epoch second, get the number of seconds from the Java epoch, and get nano, get the number of nanoseconds later along the timeline from the start of the second. And also, there is another way to extract either seconds or nanoseconds. You can extract the value you need via get method or get long method that takes chronofield as method argument. Chronofield enum contains different constants, and depending on the API, you can use it with different classes in Java Time package. Pay attention that in this particular case with instant object, not all fields from chronofield enum are supported. If you try to get one of unsupported field, you will get following error: unsupported temporal type exception, unsupported field. The instant class also has several methods which can be used to do add, subtract operations. Let's review these methods. Minus, that takes amount to subtract and temporal unit, returns a copy of this instant with the specified amount subtracted. and minus with just amount to subtract. Returns a copy of this instant with a specified amount subtracted. Usually, duration is used here. We are going to learn how to work with duration later in this lesson. So you can see two new types here that are used in method parameters: temporal unit and temporal amount. There is a package Java Time Temporal. What kind of types are grouped in this package? This package contains types that ensures access to date and time using fields and units and date-time adjusters. This package expands on the base package to provide additional functionality for more powerful use cases. Support is included for units of date time, such as years, months, days, and hours; fields of date time, such as months of year, day of week, or hour of day; date time adjustment functions; different definitions of weeks. Temporal unit type describes a unit of a date time, such as days or hours. Temporal amount framework level interface defining an amount of time, such as 6 hours, 8 days, or 2 years and 3 months. As we look through the API of Java Time package, you would notice that we are using different temporals. So, I would also recommend you to open documentation of Java Time temporal package to review other types declared there. Other methods that allows us to perform add-subtract operations are minus millis, minus nanos, minus seconds. I believe you are smart enough already to understand what these methods are about by their names. And we have similar plus methods with temporal unit and temporal amount, plus millis, plus nanos, plus seconds. I have separate method here that is called add-subtract-demo. You can find different code examples here. I just want to draw your attention to one thing. Temporal amount interface has different implementations, and here we have example with duration and period. These are implementations of temporal amount. These classes have pretty intuitive API. I believe once you understand how to work with instant objects, it will be super easy to understand how to work with those classes. Sometimes you need to compare two moments of time. In a separate method here that is called date comparison, I want to show you examples of how you can compare two moments in time. Instant class also has intuitive interface for this. Imagine that we have two instant objects, and one of instant objects describes the moment in time that is before of another one, just for 1 second. We have methods isAfter and isBefore to understand which instant goes first. In console output, you can see that we received logically correct results. Instant 1 goes prior to instant 2. Also, instant implements comparable interface. That's why we can use compare2 method for comparison. Just to remind you, this method returns negative, positive, and 0 values to answer the question which object should go before and which object should go after during the sorting. By the way, the similar way you can compare two calendars. Calendar object has such methods as after and before, and here you can see result of comparison. Similar to the instant type, calendar is also comparable type and has compare2 method. But you already saw on instant example how you can use compare2 method. And you won't believe me, but Java util date class uses a similar naming convention for methods to compare two dates. Also, Java util date implements comparable interface. Thus, it also has compare2 method. The next example shows us how we can easily convert instant object to objects of another types from Java Time package. I know that this is crazy number of classes to represent one date, but this is Java. And sometimes, depending on the code you are working with or integrating with, you might need to convert objects to different types in order you could use existing API, for example. In this example, you can see how we can convert instant to local datetime, zone datetime, and offset datetime. I believe that we have learned about instant type really a lot already. Let's review the next class that I have planned to review with you today. During the review of the following classes, I will be a little bit faster because, as I said at the beginning of the lesson, the API in Java Time package is standardized. We have methods with similar names that follow similar pattern, so during the review of the class, I will focus your attention only on important things that are different from other classes. I open local datetime demo class. Local datetime class represents a datetime without a time zone in the ISO 8601 calendar system, such as example you see, often viewed as year, month, day, hour, minute, second. Time is represented to nanosecond precision. We can simply say that local datetime class is a combination of the local date and local time class. This class is immutable and thread safe. I didn't hold separate overview of local date and local time because in my opinion there is no reason to make this lesson even longer, because once we review local date time, everything will become clear for you. And on practice, most often you use date time classes instead of just using time without date or date without time. So let's start from the things that are common with instant class. Similar methods for comparison. I'm talking about is after and is before in case you want to compare two local datetime objects. Similar way to add and subtract time. You have methods plus, minus with different list of arguments. And considering this is local datetime, you can also add and subtract other time units, like days, hours, minutes, months, weeks, years. Similar way to instantiate local datetime object. Off method is overloaded with possibility to pass different time units in comparison with instant class. You can pass day, month, year, hour, minute, second, nanosecond, and different variations and combinations of these fields during the instantiation. Here's an example. You can find source code examples of local date time instantiation, and once you instantiate object, you can work with data that it contains. In method getInInformation example, you can find a lot of source code examples of how you can extract different time unit values from local datetime object. As you can notice from method names, it is clear what time unit value I want to extract. I believe so. In other method that is called add-subtract-time example, you can find code examples of how to add and subtract different time units from local datetime object. You can find the source code in attachments to this lesson. I will not stop on this since explanation is similar to what we have discussed during the review of instant class. Explore the source code examples by yourself if you are interested, and ask your questions in comments if you have any. Let's continue. The next class to review is zoned datetime. I open zoned datetime demo class. Zoned datetime class represents a datetime with a time zone in the ISO 8601 calendar system, such as example you can see on the screen. This class is immutable and thread safe, stores all date and time fields to a precision of nanoseconds, and time zone, with a zone offset used to handle ambiguous local date times. Here I have example of instantiation of zoned datetime object. To be honest, the naming convention of factory methods is similar to other classes we have reviewed. The only difference probably is of strict method. This method obtains an instance of zoned datetime strictly validating the combination of local datetime, offset, and zone ID. This creates a zoned datetime ensuring that the offset is valid for the local datetime according to the rules of the specified zone. If the offset is invalid, an exception is thrown. Once we created object of zoned datetime, we can work with it and extract any data that we need. In the method getInInformation example, you can find examples of interaction with zoned datetime object. In other methods that is called conversion example, you can find the ways how to convert zoned datetime to other objects, namely to epoch second, to instant, to local date, to local datetime, to local time, and to offset datetime. And also similar to the previous example, I have code examples here of add-subtract operations. You can check add-subtract-time example method. Now, let's quickly review offset datetime type. I open offset datetime demo class. Offset datetime class represents a datetime with an offset from UTC Greenwich in the ISO 8601 calendar system, such as example you can see on the screen. This class is immutable and thread safe. Offset datetime, zone datetime, and instant all store an instant on the timeline to nanosecond precision. Instant is the simplest, simply representing the instant. Offset datetime adds to the instant the offset from UTC Greenwich, which allows the local datetime to be obtained. Zoned datetime adds full time zone rules. It is intended that zoned datetime or instant is used to model data in simpler applications. Offset datetime may be used when modeling datetime concepts in more detail, or when communicating to a database or in a network protocol. Similar to all previous classes reviewed, in this file you can find code examples of different ways of instantiation of objects of this type, working with the object conversion example and add-subtract time example. Also in this lesson I'd like to cover a review of such class as clock. Let me open the source code of clock class. A clock providing access to the current instant, date and time using a time zone. Instances of this class are used to find the current instant, which can be interpreted using the stored time zone to find the current date and time. As such, a clock can be used instead of system current time millis method invocation and time zone get default method. Use of a clock object is optional. All key date time classes also have a now factory method that uses the system clock in the default time zone. The primary purpose of this abstraction is to allow alternate clocks to be plugged in as and when required. Applications use an object to obtain the current time rather than a static method. This can simplify testing. Best practice for applications is to pass a clock into any method that requires the current instant. The current date and time depend on the time zone, and for globalized applications, a time provider is necessary to ensure that the date and time are created with the correct time zone. This class helps us to test that our code changes work with different time zones, or when using a fixed clock, the time doesn't affect our code. As we already said, the clock class is abstract and you can't create instances of abstract type. But this class declares factory methods that allow to instantiate objects of this type. I would like to name just some popular ones that might come in handy. Offset method that takes base clock object as the first method argument and duration object as a second method argument. This method returns a clock that is offset by the specified duration. The main use case for this is to simulate running in the future or the past. System UTC. This method just returns a clock representing the UTC time zone. Fixed method that takes two arguments, instant and zone ID. Always returns the same instant. The leading use case for this is in testing, where the fixed clock ensures that tests are not dependent on the current clock. During the demo today, we are also going to review other methods to instantiate clock object. Let me now open clock demo class. Here in the class you will be able to find different examples how to instantiate clock object. Basically, there are different factory methods like system default zone, system UTC that we have already reviewed, system method that takes zone ID as method argument to return clock for that zone ID. Here is a simple example with fixed factory method. I can tell you from my experience, clock class is really helpful, especially during the unit testing, when you need to simulate some specific moment of time. And here you can see that I can get milliseconds by calling millis method. Also, super important method for testing purposes too. If you need to imitate some time offset, you can call offset method and pass base clock and duration to make time offset. Check these examples. And remember, in case something stays unclear and you can't understand something, you are always welcome to ask questions in comments to this video. I will be happy to answer your questions. And the last but not the least two classes that we are going to learn today are period and duration. Both classes can be used to represent an amount of time or determine the difference between two dates. The main distinction between the two classes is that period uses date-based values, while duration uses time-based values. Also small but important note is that durations and periods differ in their treatment of daylight saving time when added to zoned date time. A duration will add an exact number of seconds. Thus, a duration of 1 day is always exactly 24 hours. By contrast, a period will add a conceptual day, trying to maintain the local time. The supported units of a period are years, months, and days. All three fields are always present, but may be set to 0. Let me now perform an overview of duration class. This class models a quantity or amount of time in terms of seconds and nanoseconds. It can be accessed using other duration-based units, such as minutes and hours. In addition, the days unit can be used, and is treated as exactly equal to 24 hours, like I have already mentioned. The range of a duration requires the storage of a number larger than a long. To achieve this, the class stores a long representing seconds and an int representing nanosecond of second. The duration may be negative. I believe this is enough for an overview. Let's jump to source code examples. I open period demo class. Imagine that you need to calculate the difference between 2 days. I don't know the reason why you need this. For example, there is a special promotional offer that is applicable only if you buy goods within the same period after your last purchase. Anyway, you might have different reasons for that, and period class may help us to calculate this. You call static method between and pass 2 dates to the method. As a result, you receive the reference to the period object, which you can use to extract specific years, months, and days that passed between these 2 dates. Does this make sense? In case you need to create period object to pass to other methods, like we have already saw in examples today, you can use static of method and methods for specific time unit like you see in this example. You can create a period from days, months, years, and weeks. Also, another way to get period object, which I can say didn't use very often, but still it is possible to use it too, is to parse string. Pay attention, there is a specific rule for a string to be parsed. You can open documentation for parse method in period class to find rules that should be met. Basically, you need to specify p for period, after that number of units, and first letter of the time unit. If you need period of 2 years, you just write p2y. If you need period of 3 months, you just write p3m. And that's it. Is this clear? Great, let me open duration demo now. Similar to the previous example, you can get the difference between 2 moments in time. But taking into account this is a duration object, you can extract with getters seconds values, minutes, hours, and nanoseconds of the second. Another way to instantiate duration object is to use of method. There are different variations of this method: of seconds, of minutes, of hours, of days, of millis, of nanos. Here in example I showed just 2 examples with of days method and with of hours method. Similar to example we saw during the period demo, we can parse duration from string, and again, there are specific requirements to this string. In the documentation of the parse method from duration class, you can always check examples and rules, even you accidentally forgot what the pattern is. That's all what I wanted to share with you for today. Let's recap what we have learned in this lesson. We hold an overview of Java time package, and I introduced type classifications that's supposed to help you to learn classes, groups of them, and how they are different. After that, we have learned classes to work with date and time. They are instant, local datetime, zone datetime, offset datetime. We learned clock type. And at the end of the lesson, I explained how to work with period and duration classes. Wow, just think how much we have learned today. Now you can work with dates and time in Java like a pro. Believe me. That's it for this lesson. Thank you for your attention. Have a great day and see you in the next lesson. Hello team, in this lesson we are going to learn a really interesting topic that is called Java Reflection API. We have a lot of things to learn today, but as usual we are going to start from theory and gradually we will get to the code examples. So at the beginning of the lesson we are going to learn what a Reflection API is and what goals does it have. We'll review Java Lang Reflect package in order you know where you can look for the official documentation. And after that we will start our practical part of the lesson. I'm going to show you how you can work with different class entities such as fields, constructors, methods, interfaces, superclasses with the help of Reflection API. I will put special focus on the separate group of examples that relates to the work with private entities inside the class. As I already said, there will be a lot of interesting things. Believe me, this will be mind-blowing when you will understand what you can do with the help of Reflection API. So, let's start our lesson. And to start with, let's understand first what reflection is, when reflection is used and why do we need it. Reflection is commonly used by programs which require the ability to examine or modify the runtime behavior of applications running in the Java virtual machine. In other words, Reflection API allows us to inspect or modify attributes of classes, interfaces, fields, and methods during the program execution, at a runtime. That is basically after compilation process. How do you like it already? Additionally, we can instantiate new objects, invoke methods, and get or set field values using reflection, even if they are private fields and there are no getters or setters. Probably you will not implement code related to reflection on daily basis, but 100% you will deal with code that uses reflection inside it. Such libraries as JUnit, Makita, EasyMock, PowerMock, Spring Framework, and many others, all of them using elements of Reflection API. But as a consumer of the third-party library, you just enjoying its features without implementing your own version of JUnit, correct? That's why you need to know what reflection is and how to work with it. This is relatively advanced feature and should be used only by developers who have a strong grasp of fundamentals of the language. With that caveat in mind, reflection is a powerful technique and can enable applications to perform operations which would otherwise be impossible. And what are the cases when we need Reflection API? There are various cases when we need to use this API to achieve certain result. Let me provide you with just a few examples. The first and probably the most simple case that I assume all of you have worked with, if you are following the course, is debugging and test tools. Debuggers need to be able to examine private members on classes. Test tools also needs to be able to get access sometimes private methods, like you saw in case with PowerMock. Also, we need control the sequence of methods execution to make sure that methods annotated with before each annotation will be executed before each test case, for example. Or in case we need to initialize fields of an object with mocks, and we need to do this only for objects that are mapped with inject mock annotations. A lot of things needed to be controlled by test tools, and Reflection API helps in this. The next example of using Reflection API is extensibility features. An application may make use of external user-defined classes by creating instances of extensibility objects using their fully qualified names. This is also a relatively specific case and used during the advanced programming. But my goal is to make a pro coder from you during this course, and I'm not joking. So we are also going to learn how to do this. Visual development environments. Imagine a tool that allows you to generate programming code, or tool is used to perform any other visual development, and there is some digital information that is needed to be processed according to the specific rules. And now imagine that you can work in a visual development environment via selections that you do inside it. The whole development process may benefit from making use of type information available. This will help to make proper selections regarding behavior of some components and interactions between them. Hope that now you at least understand what reflection is for. Let's start learning the details. All classes that are related to reflection mechanism are already present in JDK in Java Lang Reflect package. I encourage you to look through the official documentation after the lesson to make sure you can navigate between different types in this package easily. There are numerous of interfaces and classes. Today during the lesson we are going to review majority of them. And as you already understand, you would need to import classes from this package in your Java file. Okay, so let me start screen sharing and proceed with code examples. Remember that all code examples from the lesson you can always find in attachments to this lesson. I open demo class from a reflection package of my learning project. I will run the program to walk you through the console output and each line of code in this example. And the first thing to start here is to understand that after compilation, class definitions are uploaded into the JVM, and there is an object of type class for each type. That object contains type definition and API to interact with it. So we can say that instances of the class represent classes and interfaces in a running Java application. Basically, it will be fair to mention that the objects of class type may represent all reference types. Those includes but not limited to arrays, enums, annotations, etc. That's why the first thing that we need to do is to get the reference to the class object of the specific type. If you remember lesson about object class, then you should remember that one of the methods that each object has is getClass method. So I create an instance of the user class. That is our nested class that I created here for the sake of example. And I call getClass method on instance of the user object. Now, when I have reference to the class object of user type, we can play with Reflection API. Let me come up with some tasks asked to solve, and we'll learn different classes as we go. For example, let's get the full class name. The API is pretty intuitive, so you just need to call getName method. As you can see, full class name is printed to console. Take into account that user is a nested class. It has $sign after the name of the wrapped class. This is a common convention in Java for the naming of compiled nested classes. We are good with this first simple task. Let's jump to the next one. Let's find out names of all fields in user class. Pay attention that I have 3 non-static fields and 1 static in user class, and they have private access modifier. No getters or setters are declared to interact with these fields. Using the reference to the class object, we can get array of all fields. Field is a type that contains information about the field of a single class or interface. It also provides you with dynamic access to it. I invoked getDeclaredFields to get the array of fields in return. This method returns all fields from the class. This includes public, protected, default, or so-called package access, and private fields, but excludes inherited fields. There is also another method that is called getFields. Pay attention that getFields method returns only public fields, and when we are working with reflection, often we need to get access to private fields too. That's why in this particular case I used another method, getDeclaredFields, that returns all fields including private ones. And after that I create a stream out of this array and apply consumer function to each of the fields. If you are not familiar with Lambda expressions, functional interface, and namely consumer type, feel free to take my course Functional Programming for Java Engineers. I explain these topics in details in that course. So, as you can see, I printed to console names of each field. And this is only one thing that we can do with field. We can do much more than this. Let me also show you other things. For example, you can explore the type of a field. Just call method getGenericType. As you can see, when I printed return type object to console, toString method has been invoked and we see full class name. Also, you can check field modifiers. Just call getModifiers method. This method returns int that basically will tell you nothing if you just watch at the number. To decode this int and understand its meaning, we need to use another class from Java LangReflect package, modifier. This class has different methods that takes int as method argument and return true or false. We can check is modifier private, is static, is public, is protected, is final, and many other things. And in example, you can see that I call is private method and I pass the int value returned from getModifiers method. Considering that all fields have private modifier in my example, I receive true for each field. Does it make sense? By the way, the similar way you can check modifiers of classes and methods. I will not stop on each particular case, but just remember that it is also possible to check modifiers of other class elements following this approach. Using the class, I can get the package name. Just call the package name and that's it. Also, there is a specific type package. You can get instance of this class by calling method getPackage if you need to do some operations with package object. If you want to investigate type hierarchy, you can always get the reference to the class object of superclass by calling getSuperClass method. The superclass for all reference types in Java is object, so I get a reference to the instance of object class. The next thing that I'd like to show you is how you can check the interfaces that are implemented in class. I print name of each interface to console. And here you can see proofs. I have implemented serializable and clonable interface in user. Pay attention that the coolest thing about all of this, you can explore code of your program during the program execution. So you don't need a developer to investigate code of each program to create some useful utility classes, because code of each program is different. Instead, you can create a code that investigates the code during the execution, and on top of that, you can build the logic you wish. Let's move on. There is also another way to get the reference to the instance of a class. We can load Java class into JVM by its name and get the reference to the class object. This is an important example, and we will do something like this later on in our course. Just use for name static method and pass the full name of the class. I pass here the full name of the nested class. We will use this way of class instantiation when we actually don't need the object of this type, or we can't create it and call getClass method. That's why we can load class by its name. Pay attention that this method invocation may throw class not found exception. This may happen in case you pass class name that is absent in a class path. Also, we can get constructors. Constructor is a separate type from Java LangReflect package. Having the reference to the constructor object, we can do really a lot of things with it. But for the sake of this example only, we will print number of constructors and their names. In this example, I call getDeclaredConstructors method. The naming pattern is the same as in other methods. GetDeclaredConstructors means return of all constructors that were declared in a class, including private ones. There is another method, getConstructors. That method returns only public constructors. There are also methods to get specific constructor, getDeclaredConstructor and getConstructor with class variable length argument. You can get the reference to the specific constructors that you need using the types of constructor parameters. For example, here I want to get the reference to the private constructor with parameter of type string. I'm just passing string class to the method invocation. This method may throw two exceptions. The first one is no such method exception. This exception will be thrown in case constructor with the specified parameter types wasn't found. And the second exception that may be thrown is a security exception. This exception may be thrown by the security manager to indicate a security violation. As you can see in console, we have managed to get the reference to the private constructor. The similar way we can work with methods. We get all methods including private ones. We can get only public methods and we can get specific methods. Let me show you a few examples here. I call getDeclaredMethods method and print method names to console. In the next example here, I am getting method by its name and by list of its arguments. This is how we can separate overloaded methods. The first method argument is a method name, just string value, and after that goes variable length arguments of type class. I wanna get methods that takes user argument. That's why I pass user class here. And I printed the method to console. As you can see, we have managed to get the object representation of this method to perform any actions we need with it. When we try to get method, always remember that we can face with no such method exception and security exception. These are checked exceptions and IDE will recommend you to handle those exceptions. For the sake of the demo, I put them next to throws keyword in my main method. Okay, we learned the API and the high level. Now you know how you can get the reference to the definition of type elements such as fields, constructors, methods, interfaces implemented, superclasses, etc. Now let's understand this topic deeper and understand how to work with objects of these types. Namely, I want you to understand what we can do with them. Let me start from the constructor. I am going to show you what important operations we may perform with objects of this type. I get the reference to the default constructor and also I am going to use the reference to the constructor with parameter that we got in previous examples. Having the reference to the constructor, we can create an instance of this class by calling new instance method. And in case we need to pass some arguments to instantiate object of this type, we just pass them and that's it. I print these user objects to console. Pay attention that I have managed even to instantiate object based on the private constructor. I have passed another email and the email field was initialized in user object with value given by me. Isn't that cool? Do you feel the power of reflection already or not yet? Let me show you another trick with the field. All our fields declared in user class are private and this makes this trick even more interesting. Different frameworks may insert values in the field even if there are no public setter method. For example, Mockito framework. When I use annotation inject mocks, fields of compatible with mock types are populated with mock objects. Or in Spring framework when I configure my Spring beans, I described object of what types are needed to be injected. Now I am going to show you how to do that. For example, let's get the reference to the first name field and initialize it. You already know that I need to use getDeclaredField method. I can extract fields that I need by its name. In addition to all previous exceptions, this method may throw no such field exception. I believe that from exception name you can understand when this exception will be thrown. The first thing that we need to do now is to set accessible mode. This is needed for private entities inside the class to avoid exception during the interaction with this entity. I call setAccessible true. After this, I can set the value to the field without any fear of exception. You already know that field is a property of some object. Thus, to initialize the field, we need to specify the object where we want to initialize this field. Does it make sense? Method set of the field takes two method arguments. The first one is the object that is used to initialize field, and the second one is the value that will be inserted to that field. When I print the object to console, you can notice that first name field was updated with the values that we have just set. One more thing to add here is that for setting primitive types there are separate methods, like setInt, setDouble, setBoolean, etc. For all reference types, you can use set methods that takes object as first method argument. What to do in case there is a static field? Everything is the same beside one thing. You don't need to pass the reference to an object in this case. Just pass null instead, like I do in this example. You can see that static ID field has another value now. We learned how to set field values, but how to read field values? Very simple. You need to use get method. The algorithm is the same. You get the reference to a field first. We already did that. So I would just use first name field and ID field. After that you need to change access mode in case fields are private. We already called set accessible methods for both fields. That's why I don't do it again. And after that I just call get method. I need to pass reference to the object where I wanna read field. In case field is static, you shouldn't pass the object. Is this clear? In console you can see how I managed to extract the first name and ID values. For primitive types there is a separate group of methods like getInt, getBoolean, etc. To get the value of reference types, you can call just get method like in our example. Let me show you how we can work with methods. We can invoke them on the object when we need. Basically, we have two methods that can help us to get the reference to the object methods: getDeclared method and getMethod. If I want to get reference to the private method, I have to use getDeclared method. In all cases, I need to pass the string that contains method name that I would like to get. And additionally, we need to pass classes of parameters types. This is variable length argument, so basically you can pass either nothing here or classes of all arguments. I pass private method name and string class here, because this method takes string. How I can find this during the runtime? Again, you saw the examples of how you can get information about all methods in class. After having references to all methods, you can explore their names and parameters. That's how you can build code that explores the program during the runtime. After I have reference to this method, I have to call setAccessible to true. Since this is private method, I need to perform this method invocation to avoid error during the program execution. After that, I can invoke method. And again, similar to the non-static fields, I need an object to invoke the method on. Because method, it is a behavior of an object. So once I get the method, I can invoke the private method on an object. And you can see that I pass string argument too. In console you may notice that private method has been called. How do you like it? As you can see, there are no borders for reflection API, and encapsulation means nothing for reflection. By the way, this is also one of the reasons not to use reflection API, because it may violate encapsulation. Via reflection you may access fields and perform operations that you are not supposed to perform. But as we discussed, there might be cases when reflection API is needed to perform some actions that will make the development process easier, for example. With the static method, everything is the same beside one thing. You shouldn't pass the reference to an object to invoke static method. Here is an example of static method invocation. As you can see, there is nothing special. That's all what I wanted to share with you today. Let's review what we have learned in this lesson. In this lesson, we learned what a reflection API is, and why do we need it. We reviewed Java-Lang Reflect package, and after that we started to learn a reflection API on examples. You saw how we can work with different class entities such as fields, constructors, methods, interfaces, superclasses with the help of reflection API. Separate group of examples were related with private class entities and how to work with them. Private constructors, private methods, private fields. That's all what I planned to share with you today. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team, today we are going to learn with you what annotations are, how to work with them and how to create new ones. Before we start this lesson, I must say that it is critically important you watching previous lesson about reflection API. If you skipped that one, please make sure you watch it, because in this lesson we are going to use reflection API to work with annotations. Basically, there is not so much other ways for us to take advantage from annotations without knowing the Reflection API. In this lesson we are going to learn everything related to annotations. We will start from the definition of annotation to make you understand what annotations are. To understand it better, we are going to discuss use cases when annotations may be applied and for what purposes. After that, we will start reviewing of the source code examples. I will explain you what target annotation is and what retention annotation is. We are going to create our own custom annotation and you are going to understand how to create it and process it. And at the end of the lesson, I will also explain you how to create repeatable annotations. Let's start. And the first question that we have to answer sounds like this. What is annotation? Annotation is a form of metadata, provides data about program that is not part of the program itself. Annotations have no direct effect on the operation of the code they annotate. Do you understand this definition? Do you know what is metadata? Metadata is a data that provides information about other data, or simpler, data about data. In programming, we can annotate types, classes and interfaces, fields, methods, parameters, constructors, local variables, packages, modules, and others. We can even annotate annotation itself. Basically, there might be cases when you need to provide meta information about your code and use this information on different stages, on the level of the source code, during compilation, and at the stage of a runtime. Later in the lesson, we are going to learn these cases on examples. I will show you where annotation can be applied and how long it will be retained. You already understood what metadata is and what annotation is, but probably it is still not clear for you how this can be helpful and when we need to use annotations, in which cases. The first one is information for the compiler. Annotations can be used by the compiler to detect errors or suppress warnings. For example, such popular annotation as override. I am sure you used it already, either on purpose or IDE just added it instead of you. Override annotation discarded by the compiler during the compilation. And there is a specific purpose of this meta information. As you remember, annotation tells us that this method should override method from parent type. Thus, there are specific requirements to access modifier, return type, method signature, and list of potential exceptions. There is a logic in place in JDK that analyzes this meta information. Basically, for all methods marked with override, this logic is applied. Compile time and deployment time processing. Software tools can process annotation information to generate code, XML files, and so forth. For example, such popular library and tool as Lombok. In case you have never worked with Lombok, I will tell you about it. It generates getters and setters for you and also helps you with generating other things. This mechanism also built on top of annotations and Reflection API. Basically, you can annotate type with information about methods that you need to be generated, for example. And when you compile your application and upload classes into JVM, those methods that you wanted to be generated are there on place. Is it clear? Another use case of using annotations is runtime processing. Some annotations are available to be examined at runtime. You can set configuration to retain annotations during the runtime. I will show you this in example. But let's understand why do we need this. You may need to keep annotations during the runtime to build some logic around this meta information during the program execution. Your homework will be related to this case. I believe that we have learned enough basics to start reviewing examples. Anyway, I will explain examples as we go, and I truly believe that understanding of this topic will be easier with source code and real code examples rather than with slides. For the sake of the demo and this lesson, I created separate package and separate demo file. You can find demo file in annotations package. Let's start from basics. Let's discuss annotation format. Each annotation is started with @ sign
followed by some meaningful name. The @ character indicates to the compiler that what follows is an annotation. The annotation can include elements which can be named, and there are values for those elements. Elements may contain additional meta information. Like in this case, you can see that I used suppress warnings annotation and element value has value raw types. That is basically for compiler to remove warnings for parameterized list. In case I would comment this annotation, there will be warnings during the compilation that I am using parameterized types without parameterizing them. You see this? Okay. Another possible syntax of the similar annotation. In case there is only one element is declared inside the annotation, you can omit element key and just put value, like in this example. It is also possible to use multiple annotations at once. And from Java version 8, there is even support of repeatable annotations, as you can see in this example. A little bit later in our lesson, when we will come to creation of our custom annotations, I will explain you how to create repeatable annotations. Let's open the source code of any annotation. For example, let's look at suppress warnings annotation. As you can see, there is no any logic in code here. There is no any algorithm or data processing or anything else. Some students ask me, then how annotations work? How override annotation works and others? Basically, annotations are nothing more than just an information, and what you can do knowing this information. This is up to you, and this logic is programmed in a separate place. Okay, that was annotations basics. Now you know at least on the high level what annotations are. Let's now learn annotations deeper. And to learn them better, let's create our own annotation. If you're already familiar with JUnit, we'll implement our own kind of test annotation. If you are not familiar with JUnit yet, just a few words. JUnit is a framework for unit testing. It provides a lot of different features and among them possibility to run specific methods separately to execute separate test cases. The purpose of that method is to reproduce the state of the system at the specific moment of time and assert the expected behavior. All examples will be stored under this package, so you will easily find them in attachments to this lesson in case you want to run examples on your computer. Let's start. I create test annotation first. I declare annotation in a separate file. And you can see in this example that I use interface keyword with @sign. The second important step is to add meta annotations to specify the scope and the target of our custom annotation. I am talking about two annotations. They are retention and target. Let's learn what are they. So what do we need target annotation for? This annotation indicates the context in which an annotation type is applicable. In simple words, where you can use this annotation. Target annotation can take array of any values of element type enum. So even in case you forgot where you can use annotations, just open element type enum and you would find enum for each possible placement of your annotation. Even despite the fact that target annotation may take array of elements in our specific example, we would use only one enum, method, because in our specific business context, we don't want to allow our client use it in other places. The next annotation is retention. This annotation indicates how long annotations with the annotated type are to be retained. That is exactly what we have discussed at the beginning of our lesson, when I explained that annotation may be used during the build time by the compiler and discarded from the class, on the class level but discarded during the runtime when class is uploaded into JVM, and during runtime. This annotation can take any value of retention policy enum. Even in case you forgot what retention levels for annotations are, you always can open the source code of this enum and explore this. As I said, there are three possible options here. They are source, class, and runtime.
In our case, we use runtime retention policy because we need this annotation to be retained at a runtime. Now it is time to add custom elements. Imagine that we want to specify expected exception in order we can test negative scenarios. For example, in case we expect exception to be thrown, but there was no any exception thrown, then this particular test should be considered as failed. Understand this? To declare element in annotation, we have to declare a method with the name of the element itself. Return type will be the type of the element. For example, in this specific case, we would like to specify class of the expected exception. Thus, returned type for this method will be class. When we declare this method, we should remember important things. This method can't throw any exception. There is a restriction on the return types. Basically, you can return only primitives, string, class, enums, annotations, and arrays of these types. Also, this method has default value. For example, in this particular case, default exception to be thrown is of non-class. This is our custom class that extends throwable and that basically is empty. This is needed because I can't have default null values. But in case I wouldn't specify default value, client will be forced to pass the value for this element. But what client should pass in case there is no expected exception? That's why I have default non-class here. Similar example of default value in our other element. Each test can be named, and default name is empty string. But client of this code can pass any custom name. One restriction with regards to default value, it can't be null. Is that clear? We are done with annotation creation. Let's now understand how to use it. As you can notice, there is no logic defined in the annotation. That means that I should have some place where logic for annotation processing is described. In this particular example, it can be some test runner class. Similar to the JUnit where we have separate runners that can execute my tests. I open test runner class. It has run tests method that takes class that contains tests to run as method argument. I use this reference to a class object to get the array of all methods. After that, I filter methods to keep in stream only methods that have test annotation. After that, I filter all static methods to keep only non-static methods in the stream. And now I need to call test method on the object. I create new instance using test class. After that, I need to split logic for annotations that have expected exception and those who don't. You remember that annotations without specified by client exception still has exception with none by default. I use this information during implementation of my logic, because in case I expect any exception specified by client other than default, I need to check that expected exception has been thrown. Compare classes of exceptions thrown, and here is the logic for that. By the way, in Reflection API, in case exception has been thrown on the invoked method, we receive invocation target exception that serves as the wrapper for original exception. That's why I need to call getCause method here to get the reference to the exception that caused invocation target exception. In case I don't expect exception to be thrown, method just should be executed successfully, and I just invoke method. Definitely, this is not the full replica of test annotation from JUnit, but we have goal in this lesson not to learn JUnit, but to understand how to work with annotations and process them. Now, let me show you class with tests. I open a class that is called testSamples. This class contains different methods that are marked with test annotation. Each test has name. For the sake of the current demo, I have two test cases here. Method that is executed without exception and method that throws exception of expected type. Nothing complex here. And now let's write a code that will use my test runner to run these test cases. I open another class that is called testAnnotationDemo. I create instance of test_runner. I call runTests method and pass in there a class that contains my test cases. That's all. Let's run this program. And in console you can see that test with exception has been passed, because we received exception that we expected. And test without exception also has been passed, because it was executed without throwing any exception. I recommend you to look through the source code that I left in attachments to the lesson, run it on your local computer to understand better how it works. And the last thing for today that I'd like to share with you is repeatable annotations. To be honest, in my opinion, this is a very rare case, because in case you need to pass multiple values, you always can define additional elements in the original annotation, or declare an array of values for some element. Anyway, it was hard for me to come up with real-life example in this case, but I just want to demonstrate you the feature that was added in Java version 8. Let me open our demo example. Can you see that I have author annotation here duplicated? Normally, it is not accepted. And to be able to use the same annotation twice for the same element, you need to perform additional actions. The first thing to do is to add annotation repeatable to the annotation definition, like I did for author annotation. The second thing to do is to create container for repeatable annotations. For compatibility reasons, repeating annotations are stored in a container annotation. In order for the compiler to do this, two declarations are required in your code. That's why another annotation that we need to create is here. I call it authors. Container annotation must have element value that returns array with objects of repeatable annotation type that we wanna repeat. In this case, value element will contain array of author annotations. Is it clear? Basically, that's all what I wanted to share with you. Let's review what we have learned in this lesson. In this lesson, we have learned what annotation is. Also, I explained you why we might need annotation and when we can use it. Now you know where annotations may be applied, you know why we need target annotation, and you know what element type enum is. Also, you learned what retention annotation is and what retention policy enum is. In the lesson, we created our custom annotation. And at the end of the lesson, I explained you how to create repeatable annotations. Basically, that's the summary of all what we have learned today. I have a homework for you in order you can practice in creation of annotations. You also can find the link to the homework in attachments to the lesson. Let's understand what you need to do. In this task, you need to create to-do annotation that will allow us to track the progress of not implemented methods. To-do annotation has different elements, such as author, priority, and status. Some of them have default values, and author element doesn't have. Annotation can be applied only to methods and should be available during the runtime. Also, you need to create separate class that is called ToDoAnalyzer. In that class, we should have a method that returns string value, that is, generated to-do report. Pay attention that in order your homework would be considered to be done, you need to follow specific pattern for each method analysis. Pattern is described here. You should specify method name, author, priority, and status. Is it clear? Anyway, you will be able to find my solution also in attachments to this lesson. But try to solve this task without any help and by yourself first, and only in case solution is not obvious for you, use my solution as a reference. And as always, in case you have any questions, feel free to add your questions in comments under this video. Thanks a lot, team, for your attention. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello team! In this lesson we are going to learn how to work with string builder and string buffer classes. Also, I'm going to explain you why we might need them. We are going to start from understanding what these classes are and why do we need them. I want you to understand the problems that these classes supposed to solve. We are going to have practical example where I will explain in details why you should never forget about string builder and string buffer. In this lesson, I am going to explain the difference between these two classes, and what is even more important, I will teach you when to use these classes and how to use them. I will show you example of string builder and string buffer usage, and also we'll learn char sequence interface. Let's start. Let's try to understand first what is string builder class. In the documentation, this class is described as mutable sequence of characters. By this moment in our course, you already know that objects of string class are immutable. In short, the class designed in the way that you can't change the state of original object after it was instantiated. All methods don't modify state of the original string object that we created. The class itself is final and you can't override it to change the logic of methods. That means that each time you modify string in your program, you actually create new object of the string. Yes, you might lose the reference to the string object in case new string object is assigned to the original variable. And yes, in case there is no strong references to the object, garbage collector will clean it up. I'm going to show you this case on the example later today. But the only question that I wanna ask you sounds like this. Do we need to rely on garbage collector and make it work? The answer is no. When garbage collector starts its work, it is also some computation time that potentially might be used by other operations, instead of cleaning up objects without strong references. And by the way, it is important for you to know and remember the difference between different types of references. In case you want to learn more about this topic, make sure you watched my lesson about references where I explained different types of references. But still, how to solve problem of constant creation of string object if I'm modifying string? The situation might be completely different. Either you process a lot of strings and you need all of them in one string, or you prepare a string before writing it to the file, it doesn't matter. But in some hypothetical case, instead of creation millions of string objects in heap memory, it is recommended to create one object of string builder type and use it. Does it make sense? Do you understand motivation of using object of this type? Great! Let's now understand what a string buffer class is. It would be easy to explain you what is this class about because it is almost the same as string builder class. They have similar methods, similar constructors, literally almost everything is similar. The only difference is that string buffer is a thread-safe class and objects of this type may be used in multithreading execution without impact on data consistency. What a multithreading is, we discussed in the separate section of the course. But still, I would like to remind to all students about multithreading one more time. In short, in case of parallel execution of multiple threads, when different threads update the state of the string buffer simultaneously or read its data, only one thread is allowed to execute these operations to avoid potential mistakes that may happen because of multithreading access. That's why everything what I'm going to share with you about string builder is absolutely applicable to the string buffer in multithreading environment. The rule of thumb is to use string builder whenever is possible, because it has better performance. This is just consequences of not having synchronization for multiple threads inside string builder, whereas all methods in string buffer are synchronized and this takes additional overhead during the execution. You should be alright with string builder in most cases. I believe that you already understood on the high level why we need these classes. It is time to dive deeper in details and understand how to work with objects of this type. And let's start from explaining the hypothetical problem. I have a file with text. This is lyrics of the song that I listened while thinking about the structure of the lesson. The song is called Never Coming Home by Sting. Pretty cool one, by the way. And according to business logic, I need to be able to read text from files and after that work with the content of the file as a whole. For example, text analysis or text statistics is needed. Probably you wanna implement programs that would analyze thousands of songs in order you could find the best rhymes. Anyway, you can be in any other situations that would make you to collect all strings in one string object. I open my example now that is called string builder demo. I have method that reads all lines from file into one string object and after that I print the string to console. Let's review this method. I create the reference of the string type that is pointing out to the object that is stored in string pool. If you don't remember what is string pool, please refer to the lesson about string objects and string pool in my Java course. In the next line, I read all lines from file into the list of strings. In case you are interested how I did this, please refer to the section about input-output streams in my Java course. After that, I iterate over each line and I concatenate each line with my result string and adding new line character at the end of each line. What is actually happening here? I create new string object after each concatenation. And this string reference pointing out to the new object in heap memory each time after concatenation. You are going to have the object that contains the first line only. The second object would be the first line and new line character. The third object would be the first line, new line character, and the second line, and so on. Why do you need so many duplication and so many string objects? And it is not a big harm in processing one Sting song, but believe me, you are going to work with files much bigger than we have in our example today, and this is going to become a problem. What would be the solution here? The solution here is to use string builder object. Let's look at another method that also reads all lines from the file, but do it with help of string builder object. I create object of string builder type with the default constructor. After that, I am doing the same thing. I am reading all lines into the list object. In for each loop, I call append method to append new line and new line character. I need to return a string object from the method, so I call toString method that creates string object based on my string builder. That's it. To prove you that concatenation of strings with string builder is more efficient, I evaluated time for both of these operations. I just take amount of milliseconds before the first method invocation, and after that I calculate delta in milliseconds by deducting the time that I already have from current time after method execution. Following this approach, I can estimate how long does it took to execute code that is between 2 points. And I did similar measurement in the second example for string builder. After that, I print 2 values to console in order we could have a chance to compare these 2 values. Let's run the program. So you can see, the difference in performance with one song of Sting is approximately 10 times more with string object concatenation. Imagine what the difference would be with gigabyte files. It is crazy. That's why it is important to use string builder during the processing of big number of strings. Basically, we have just reviewed probably the most popular example of string builder and string buffer usage. But let me also share with you a little bit more details about class structure and other methods. I open the source code of string builder class. And just to remind you, what we are going to review now is absolutely similar in string buffer class with only one exception: synchronized methods. The default constructor calls constructor of superclass, that is abstract string builder, specifying the original capacity of the characters array. By default, it is 16. Do not find any sacred logic behind this number, it is just 16. There is also a string builder with int parameter to specify any custom default capacity. When you should use this version of constructor? I believe that you already know how arrays work in Java. You can't extend array that was created already. So, to extend existing array, you need to create a bigger array and copy all old values in it. This is time-consuming operation. That's why, in case you know that you are going to process big amount of data, you can set initial capacity in order to avoid constant creation of new array objects to have enough space for all characters. Also, we can create string builder and initialize it with the content of the string object or any char sequence. Char sequence is an interface that is implemented by many different classes in Java. For example, string, string builder, string buffer, abstract string builder, and others. All of them implements char sequence interface. This interface declares construct for such methods as length to return total number of characters in char sequence, char add returns the char at the specified index, is empty default method that checks whether length equal to 0, returns true if character sequence is empty and false otherwise. Subsequence method will return char sequence from index inclusively to index exclusively, and you know what the string method does. Also, we have a few more default methods. Among them, chars returns int stream. Just to remind you that char easily may be converted to int. Why? Because integer value will specify sequence number of the character in the Unicode table. Code points returns int stream, where each int will represent character sequence number in Unicode table. I will be honest with you, I have never used this method, but at least it is good just to know that such method exists in learning purposes. And static methods that may be used to compare two character sequences. Let's get back to the implementation of char sequence that we are learning today. I open string builder class. As you can see in outline here, there are a lot of versions of append method. This method is overloaded to be able to accept parameter of different types. Also, we can delete from char to char from string builder, or delete char at the specified index. And again, it is hard for me to come up with example where you would use these methods on daily basis. Replace method from index to index and be replaced with this string. Another method that is overloaded in this class is insert. It is used to insert the specified value at the specified position. It is overloaded to have different parameters. IndexOf method returns the index within this string of the first occurrence of the specified substring. LastIndexOf returns the index within this string of the last occurrence of the specified substring. The last two methods also have overloaded version that additionally takes one more parameter of int type. That is the index from which to start the search. Reverse method causes this character sequence to be replaced by the reverse of the sequence. That's all methods of string builder class. What I would recommend you? Open the source code of string builder, string buffer, and abstract string builder class. Look thoroughly through the code and try to play with methods. We have discussed the most important ones and the methods that have chance to be used in production. But in case you would find any other method that you are interested in and you would like to talk more about it, do not hesitate to ask questions below this video. I will be happy to answer all of your questions. But I truly believe that we have learned just enough things in order you be able to start using string builder and string buffer classes. Now let's recap what we have learned in this lesson. After this lesson we know what string builder and string buffer classes are. I believe that you understood the purpose of these classes and use cases when to use them. Also, we reviewed the char sequence interface today. That's it for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team, in this lesson we are going to learn optional class API. We are going to start the lesson from the definition of what optional class is. Understanding of the goal and purpose of this class will help you to understand it better. Knowing this, we'll learn optional class API, and on real code examples I am going to show you how to work with methods from optional class. At the end of the lesson, I will explain you when to use optional, and you will understand in which cases using of optional will be efficient and will not bring more harm than good. Besides that, I will answer to the question what alternative techniques might be used instead of optional. Let's start. And let me start from explanation of what optional class is and why do we need it. Do you know what null pointer exception is? Probably this is one of the most popular exceptions that interrupts our program's execution. Just to remind to all students that null pointer exception is an exception that is thrown when we try to invoke some method on the reference that is not initialized. In other words, we have variable that doesn't store reference to any of objects in the heap memory, and when we call some method on the variable, we receive null pointer exception. That tells us that we actually can't invoke any method on the nothing. Is it clear? And to avoid cases like this, we should never forget to perform null check before any method invocation. The new class that has been introduced in Java 8 is supposed to alleviate some problems. In my opinion, the introduction of this class is controversial. From one side, it is great that Java engineers has tools like this one to indicate places where we may have null potentially. But from the other side, in my opinion, optional class often used by developers inappropriately and brings into the code more complexity and harm than good. But in this lesson I will share with you my tips in order you use optional class efficiently. Generally speaking, returning a null reference from any method considered to be a bad practice. For example, you call getter on the object that doesn't have all fields initialized yet, and you receive null reference. Indeed, what else you should receive if there is nothing yet? What if a field is really empty and doesn't initialize with any reference yet? Tony Hoare, one of the giants of computer science, wrote, "I call it my billion-dollar mistake. It was the invention of the null reference in 1965. I couldn't resist the temptation to put in a null reference, simply because it was so easy to implement. I can add to it that it wasn't just so easy to implement, it was also so logical to implement." Let me start sharing my screen to explain the problem that we have today that optional class is intended to solve. I open class problem statement from optional package of my learning project. In this example, imagine that we have instance of the computer. We have some computer and USB drive. Potentially, USB drive may be plugged in or may not. I can call getUSBDrive method on my computer object to get the reference to the USB drive. In case nothing is plugged in, I receive null, correct? But in case there is a USB drive, I can get access to the write protect switch to check its state. In this case, I need to perform null check again. Can you see how my code looks like? And the good thing about all this is that I am smart enough to perform such checks. It would be worse in case such checks wouldn't exist at all and my program would just fail during the execution. Do you understand the point? In addition, it's just annoying that these checks get in the way of the business logic. In fact, they are decreasing the overall readability of our program. What would be better than this? It will be better to build data structure that would indicate presence or absence of the value. That's what we need optional class for. So, we agreed that we need a mechanism that allows a method developer to explicitly denote that the return value for a method may or may not be present. Optional class acts as a wrapper for an object that may not be present. Therefore, if we know that our getUSBDrive method may not return a desired object,
we can change method return type.
Let me open solution class now. In this class, you can see that getUSBDrive method from my computer class has different return type now. It is optional parameterized by the USB drive. And in my USB drive, I have also updated return type. Now this is optional that is parameterized by write protect switch. Do not pay a lot of attention to the details at this moment. namely how we create objects of optional type, why I use this method and didn't use another one. We're going to learn optional class in a minute with detailed examples. Now I'd like you to understand the idea of problem and our solution. In my main method you can see that I use features of optional class, and I check whether some value is present in my USB drive wrapper, and if present, I execute function that takes USB drive as method argument. Namely, I am getting access to the switch, which is also optional, and in case it is present, I just print switcher state to console, and if no, then do nothing. And in case there is no USB drive object inside the wrapper, I execute another function. I just print to console that USB drive wasn't found. As you can see on this example, optional is similar to the wrapper that may or may not contain the actual value inside itself. In simple words, you can view optional as a single value container that either contains a value or doesn't. It is then set to be empty. Following this construction, you make client responsible to handle missing value. You just warn him that value here may not be present, and you decide what you want to do in this case. This client's responsible approach means that creator of the method is not in a position to define what should be done in case of missing value. The easiest thing is to throw exception, but throwing exception probably not always the best case and proper behavior according to the business logic in case of missing value. Now, I want you to look at this example with fresh eyes. If Java community and software engineers would like to call this more readable code than simple if-else statement, I am happy to accept that. Really guys, I just want we don't lie to ourselves. What we have instead of if-else blocks? We have few lambda expressions that are also located inside each other, and moreover, all our methods returning optional now, and we can't just take value and work with it in order we could avoid null pointer exception. Well, definitely optional is a very powerful tool, but guys, I can't see what we have won in this case. There are multiple other features in optional that bring us amazing flexibility and let us write less lines of code with optional than without it. That is true. But again, it should be also a special case to apply those features of optional. The true story from my life is when developer from my team created few classes with all methods returned optional type parameterized by other types. I asked him, why would you do that? And he replied, because we need to use optional everywhere where we may receive null. Well guys, not everywhere. And again, using optional everywhere wouldn't bring us for the better readability that we are so struggling for. So let's learn API of optional to better understand its power and understand cases when and where this might be applicable. I open optional demo class. We have a lot of examples here. Let me walk you through each example here. The first one that we are going to review is how to create an object of optional type. In most of the cases, to create object of type optional, we need to use static factory methods from optional class. The first way to create optional is to call static method empty. This returns empty optional. The empty method is often used when it is known a priori that no value exists. If you have some value and you need to create optional, call static method off. Pay attention, you need to have the object behind the reference that you are going to use to create optional object with off method. Because in case you pass null value to the off method, you will get null pointer exception. In case you know that value behind the reference may be null or may not be null, use another method, of nullable. This will create optional object based on the null and non-null values. For example, in previous example, in solution, I used of nullable factory method because I knew that I may need to create optional object based on null value. Now, let's review methods that allow us to check if value is present or absent. There are two methods that allow us to check the value inside the optional, is present and is empty. Obviously, these two methods are controversial. When isPresent returns true, isEmpty returns false, and vice versa. Here in example you can see that I have test string value and checking whether optional is empty or has value, and the similar test for optional that contains nothing. The result of method's execution you can find in console output. Now let's review example of conditional methods. I called these methods conditional because based on the specific condition, API allows us to perform one or another action. The first method in this example, ifPresent. You already saw me using this method in example in solution with USB drive. ifPresent method takes consumer as method argument. If you are not familiar with Lambda expressions and such functional interfaces as consumer, I recommend you to pass my course Functional Programming for Java Engineers. I explained these topics in detail there. Just to remind you, consumer takes some argument and returns nothing. So basically, if the value is present, we pass it to the function and perform any action with it what we need. In this particular example, I just printed to console. In case there is no value in optional, we just ignore this function and just do nothing. Another conditional method is ifPresent or else. I also use this one in solution of the example that I have already showed. I believe that from the method name it is already clear for you what this method for. So in case value is present, we'll use consumer and we'll work with the value. In case value is absent, we'll execute some runnable that contains lines of code to be executed in case there is no value. The next example is simple and regular get method. You can extract value from optional by calling get method, but be attentive. In case there is no value, you will get no such element exception. And here in example you can see this, that in case optional is empty, we are catching exception. In practice, it is recommended to use isPresent method that guarantees that there is a value inside optional. So just remember this. But imagine that we are using isPresent method, okay? Just look at this example. How far it is from null check from our problem statement with if block? We again have the similar if block. That's why in most cases we intentionally avoid use the get method and use one of the other methods, such as or else throw, to obtain the value associated with a populated optional or perform another action. Let me show you this. In the next example you can see how to use or else method. Basically, it returns the value if it is present, and in case it is not, it returns the value that I passed to the method. Also, we have or else get method. What is the difference between or else and this method? Different parameters. Or else get takes supplier as method argument. Supplier is a function that produces something. It takes nothing and returns some value. And what does it give us? Well, probably it is not obvious in this particular example, but let's look at the next lines. Imagine that you have some method that performs a lot of work and calculations, and as a result returns your reference to a string value. And in case you call or else method and you would like to pass the string returned by this method, the method is actually invoked, and you spend some time to wait until method got finished. But is it the same with or else get method? No. Look in this line. You are actually not invoking the method. You just passing the reference to the function that knows how to get the value for you in case this is needed. This is the main difference, lazy initialization. In the first case, we are invoking method no matter whether optional has value or no. And in the second case, we just use function that knows how to provide us with value only when it is needed, only when optional has no value. Does it make sense now? In case the value is absent and you wanna throw an exception, you can use or else throw method. This method is overloaded. The version without arguments will throw no such element exception by default. Or you can pass supplier as method argument to generate object of the exception that you would like to throw. Now let's learn how filter method works. In case you have the reference to the optional object, you can check it first to understand whether it is match your predicate. And in case verification is passed, you receive optional with that value. Otherwise, you receive empty optional. Let me explain this example. Imagine that I have optional that contains my full name. After that, I can call filter method on the optional object and pass predicate. Let me quickly remind you what predicate is. Predicate is a functional interface that declares one method that takes one argument and returns either true or false. So here is my function. I pass full name and I check whether it contains Andrei. If yes, then I receive optional with this name. When I call or else, I get the reference to my full name and print it to console. In the similar example but with different name, I will get empty optional, and you can check this by console output. In the second case, I print to console default string that I used in or else method. Do you understand why we may need filter method? It is normally used to reject wrapped values based on a predefined rule. Imagine now another case. We have a user object and we need to make sure that user that we received from database or from another method has birth year less than one number and more than another number. How to do that? We can use map method simply to convert the wrapped value to another type. The map method allows us to convert a wrapped value from one object to another if an optional is populated. This method can be thought of as a pipeline method, where the wrapped value is passed along the pipeline and transformed to a new value. Do you remember how Stream API works? The similar concept is here. This method works by accepting a function object that is applied to the wrapped value to produce the mapped value. If the optional is empty, the function object is never called and an empty optional is returned from the map method. Let me explain you an example. I have optional parameterized by type user. I have wrapped here user object. This user has name Yegor and his year of birth is 1990s. I call map method on my optional object to convert data in a pipeline from user to an int. I need to pass function that knows how to transform the current type to another. And when I have int value in pipeline, I can use filter method to check whether year of birth of the current user is within the expected range. In this case, my user matches the current filters and optional with value is returned. That's why I can print user's birth year to console. Watch this example please and let me know in case you have any questions. In case something is still unclear, please put your question below this video and I will be happy to answer it. Let's review another method that is similar to the map method. We also have the flat map method as an alternative for values transformation. There is one main difference between these two methods. The difference is that map transforms values only when they are unwrapped, whereas flat map takes a wrapped value and unwraps it before transforming it. Let's make sure that you understood this following the example. So imagine that we keep working with the same user, but interesting thing, inner method returns optional too. For example, getName method returns optional that is parameterized by string. Knowing all what we know, let's extract name from the optional parameterized by type user. The first thing that I do, I wanna convert optional of user to the just name. What I got instead? Instead I got optional parameterized by optional that is parameterized by string. That is because my getName method returns optional. Having this wrapper, I can extract optional parameterized by a string that should contain the name of the user. And only after that I can extract user. Don't you think that I did a lot of redundant steps? Similar to the stream API from GDK, flat map doesn't wrap the value with additional optional. So to achieve the same goal in a little bit simpler way is to call flat map and pass the reference to the getName method. And now I can apply other methods to extract value, like orElse method. And in console you can see that the results are the same, but the second option took us less lines of code to achieve the same result. Does it make sense? In my opinion, we have reviewed all the most important methods from optional API that might come in handy. But anyway, open the source code of JavaUtil optional class by yourself and investigate it. Now let's discuss when and how to use optional to make sure it is not dangerous and you don't bring more harm than good. Let's review different parts of our program and different use cases, and I will give you my advice. Returned values. Often, optionals are well suited for returned values. Originally, this was intended to be their main use case. In documentation, we can find that optional type is primarily intended for use as a method return type, where there is a clear need to represent no result, and where using null is likely to cause errors. And here I'd like to pay you extra attention in order you wouldn't follow code style of a colleague of mine who has all methods developed with optional type returned. You should return optional as it is set, where there is a clear need to represent no result, and where using null is likely to cause errors. Not everywhere, but still, this recommendation leaves area for interpretations. I would also add one more important thing to consider. Use optional only in cases when you wanna make client of your code responsible for handling of absent value. And this is really good reason not to put optional return type everywhere. Why? Because in most cases we need to provide ready-to-use API, but not make our clients think about each returned value. What to do in case value wasn't returned? Regarding fields, let me put it simple. You can create fields of optional type, but you shouldn't. Why? For me, it is a sign of a bad architecture. You have fields knowing from the beginning that they may not be initialized, but probably in this case, you have bad hierarchy and bad OOP architecture with not implemented solid principles. Probably there are some classes that don't need all these fields and it is just a matter of building of proper hierarchy. A lot of questions. So I'll put it simple. Do not use optionals in fields. Parameters. You can use optional method parameters, but again, it is not recommended to do that. It is recommended instead to have overloaded methods. If you know that you might need to invoke this method with null parameter, or with empty optional in other words, so just create method that takes no parameter. But you also can have overloaded method with the same name but which takes parameter. Is it clear? Some students ask me, what is alternative to using optional? Well, the simplest alternative is to live like our ancestors lived. Just use null value and do not forget put no checks. This is still the case in a lot of programs nowadays. Another alternative may be a throwing exception. If absence of the value really breaks the way of your program execution, then you need to be prepared to handle specific exception and to handle it properly. During the handling of this exception, you'll specify alternative actions what is needed to be done in case the value is absent. Almost the similar way you do with optional. And another alternative is null objects. You can create a type that has the same API, but it is empty inside, and all methods are error safe. And when it is needed, you just create an instance of the empty object or just passing the reference to the empty constant. For example, in collections class, there is empty list constant. And instead of returning null when list is expected, you can just return empty list constant that will save you from null pointer exception. Remember these advices. There are years of experience and millions of dollars behind these advices. Let's recap what we have learned in this lesson. In this lesson we learned optional class API and its methods. You know the purpose of the optional and when to use it. And at the end of the lesson I also explained few alternative techniques to use instead of optional. That's all for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students, in this lesson we are going to learn more about features that was added in Java version 9. I am talking about modules in Java. Today we have really a lot of new things to learn. Modules really powerful features that exist in Java platform, and if you want to become Java software engineer or get one of Oracle certifications, you have to be familiar with it. We'll start lesson from simple and general topics such as what modules are, and just talking about why we might need them. To help you understand modules better, I will explain what goals we are trying to achieve by using them and what benefits we expect to get. We'll review different module types. After that, we'll learn module directives that we use in module descriptor and command line options that might come in handy when you will work with multiple modules from console. And at the end of the lesson, we are going to create modular Hello World application, and I will show you how to configure Eclipse in order you can work with modular application from Eclipse. As you can see, we have really a lot of things to do. Let's start our lesson. Let's understand first what modules are. Module is a uniquely named, reusable group of related packages as well as resources, such as images and XML files, and module descriptor specifying the module's name, the module's dependencies, that is, other modules this module depends on, the packages it explicitly makes available to other modules. All other packages in the module are implicitly unavailable to other modules. The services it offers, the services it consumes, to what other modules it allows reflection. A Java module is a packaging mechanism that enables you to package a Java application or Java API as a separate Java module. A Java module is packaged as modular jar file. A Java module can specify which of Java packages it contains that should be visible to other Java modules which uses this module. A Java module must also specify which other Java modules are required to do its job. In more simple words, Java module is a package for packages. That is super simplified, but hope this will help you to understand this concept. You can group packages into modules, and to ensure encapsulation you may control access to different packages within the module. Modularity adds high level of aggregation above packages. Is it clear? Java Modules is a new feature in Java 9 via the Java Platform Module System. The Java Platform Module System is also sometimes referred to as Java Jigsaw or Project Jigsaw, depending on where you read. Jigsaw was internally used project name during development. Later, Jigsaw changed name to Java Platform Module System. There is a JSR 376. JSR stands for Java Specification Request. This is an actual description of proposed and final specification for the Java platform. At any one time, there are numerous JSRs moving through the review and approval process. In the JSR 376, we can find list of goals of modularizing the Java SE platform. Among them, such goals as reliable configuration. Modularity provides mechanisms for explicitly declaring dependencies between modules in a manner that's recognized both at compile time and execution time. The system can walk through these dependencies to determine the subset of all modules required to support your app. From Java 9 and forward, Java applications must be packaged as Java modules too. Therefore, an application module specifies what other modules, Java API modules or third-party modules, it uses. Therefore, the Java virtual machine can check the whole module dependency graph from the application module and forward when the Java virtual machine starts up. If any required modules are not found at startup, the Java virtual machine reports the missing module and shuts down. Before Java 9, missing classes, from a missing jar file for example, would not be detected until the application actually tried to use the missing class. This would happen sometime at runtime, depending on when the application tried to use the missing class. Having missing modules reported at application startup time is a big advantage compared to at runtime when trying to use the missing module jar class. Strong encapsulation. The packages in a module are accessible to other modules only if the module explicitly exports them. Even then, another module can't use those packages unless it explicitly states that it requires the other module's capabilities. This improves platform security because fewer classes are accessible to potential attackers. You may find that considering modularity helps you come up with cleaner, more logical designs. Scalable Java platform. Previously, the Java platform was a monolith consisting of a massive number of packages, making it challenging to develop, maintain, and evolve. It couldn't be easily subsetted. The platform is now modularized into 95 modules. This number might change as Java evolves. You can create custom runtimes consisting of only modules you need for your apps or the devices you are targeting. For example, if a device does not support graphic user interfaces, you could create a runtime that doesn't include the GUI modules, significantly reducing the runtime size. Before Java 9 and the Java Platform module system, you would have had to package all of the Java Platform APIs with your Java application, because there was no official way of reliably checking what classes your Java application used. Since the Java Platform APIs have grown quite large over the years, your application would get a large amount of Java classes included in its distribution, many of which your application would probably not be using. Greater platform integrity. Before Java 9, it was possible to use many classes in the platform that were not meant for use by an app's classes. With strong encapsulation, these internal APIs are truly encapsulated and hidden from apps using the platform. This can make migrating legacy code to modularized Java 9 problematic if your code depends on internal APIs. The unused classes make your application distributable bigger than it needs to be. This can be a problem on small devices like mobile phones, Raspberry Pis, etc. With the Java Platform module system, you can now package your application with only the modules of the Java Platform APIs that your application is actually using. This will result in smaller application distributables. Improved performance. The JVM uses various optimization techniques to improve application performance. GSR 376 indicates that these techniques are more effective when it's known in advance that required types are located only in specific modules. And this was a great improvement for Java as a platform. Nowadays, questions about modules are among main questions during different Oracle certifications. Let's talk now about different modules types. There are 4 types of modules in the new module system. System modules. These are the modules listed when we run Java list modules command. They include the Java SE and JDK modules. Application modules. These modules are what we usually wanna build when we decide to use modules. They are named and defined in the compiled module info class file included in the assembled jar. Today we are going to create with you our own module info file and see all examples. Automatic modules. We can include unofficial modules by adding existing jar files to the module path. The name of the module will be derived from the name of the jar. Automatic modules will have full read access to every other module loaded by the path. Unnamed module. When a class or jar is loaded into the class path but not the module path, it's automatically added to the unnamed module. It's a catch-all module to maintain backward compatibility with previously written Java code. The unnamed module concept is similar to the default package. Therefore, it is not considered a real module, but can be viewed as a default module. We can create multi-module projects comprised of a main application and several library modules. We have to be careful though, because we can only have one module per jar file. Let's learn now what module descriptor is and what are different directives that may be used in module info Java file. As we have discussed already, a module must provide a module descriptor, metadata that specifies the module's dependencies, the packages the module makes available to other modules, and more. A module descriptor is a compiled version of module declaration that's defined in a file named module info Java. And the first thing that we need to do is to create a file with name module info and with Java extension. This file should be located in the source root directory. Each module declaration begins with the keyword module, followed by a unique module name and the module body enclosed in braces, like you see in our example. A Java module name follows the same naming rules as Java packages. However, you should not use underscores in module names, or package names, class names, method names, variable names, etc. from Java 9 and forward, because Java wants to use underscore as reserved identifier in the future. It is recommended to name a Java module the same as the name of the root Java package contained in the module, if that is possible, because some modules might contain multiple root packages. The module declarations body can be empty or may contain various module directives, including requires, exports, provides with, etc. We are going to discuss each of these in a few minutes. As you'll see later, compiling the module declaration creates the module descriptor, which is stored in a file named module info class in the module's root folder. On this slide, I will briefly introduce each module directive. They are keywords only in module declarations and may be used as identifiers anywhere else in your code. Let's learn now directives. The first directive that we are going to learn is requires. This module directive allows us to declare module dependencies. For example, in this case, my module has both a runtime and a compile time dependency on some module that you should refer by module name. Each module must explicitly state its dependencies. When module A requires module B, module A is set to read module B, and module B is read by module A. To specify a dependency on another module, use requires. And all public types exported from a dependency are accessible by our module when we use this directive. Another important mention here is that it is not allowed to have circular dependencies between modules. In other words, if module A requires module B, then module B can't also require module A. The module dependency graph must be an acyclic graph. Another directive is require static. We might write a utility function that pretty prints our internal state when another login module is present. But not every consumer of our library will want this functionality, and they don't want to include an extra login library. In this case, we want to use an optional dependency. By using the require static directive, we create a compile time-only dependency. Now, let's learn transitive directive. Imagine that we want to use third-party library and that library in turn has other dependencies. How we can make sure that any module that we are dependent on will bring its own dependencies to work properly? We can force any downstream consumers also to read our required dependencies with requires transitive directive. Let's review exports directive now. As you already could understand that strong encapsulation was one of the main goals when Java Platform Module System has been introduced. By default, a module doesn't expose any of its API to other modules. Our code is significantly more secure if we don't expose our API to external users. But what if we created API that should be used by different modules and we need explicitly make it available for everyone? We use the exports directive to expose all public members of the named package. Please note that only the listed package itself is exported. No sub-packages of the exported package are exported. That means that if this package in my example contains a sub-package named util, then the comp my package name util package is not exported just because of parent package is. To export a sub-package also, we must declare it explicitly in the module descriptor. And one more rule. The same Java package can only be exported by a single Java module at runtime. In other words, you can't have two or more modules that export the same package in use at the same time. The Java virtual machine will complain at startup if you do. Having two modules export the same package is also sometimes referred to as a split package. By split package is meant that the total content classes of the package is split between multiple modules. This is not allowed. In case we want to limit access to our API and expose it only to some packages, then we have to use exports to directive. Similar to the exports directive, we declare a package as exported. But we also list which modules we are allowing to import this package as requires. And here is how it looks like. The next directive is uses. A uses module directive specifies a service used by this module, making the module a service consumer. A service is an object of a class that implements the interface or extends the abstract class specified in the uses directive. We designate the services our module consumes with the uses directive. Note that the class name we use is either the interface or abstract class of the service, not the implementation class. Because service in this context means an implementation of a specific interface or abstract class that can be consumed by other classes. But what is the difference then between uses and requires directives? We might require a module that provides a service we want to consume, but that service implements an interface from one of its transitive dependencies. Instead of forcing our module to require all transitive dependencies, just in case, we use the uses directive to add the required interface to the module path. Is that clear? We have discussed directives that consume the services. But this also means that we have modules that provide services. So, a module can also be a service provider that other modules can consume, and we can ensure this with provides with directive. We should write provides keyword first and specify the interface or abstract class name of our service. The next thing what we have to do is to specify what specific implementation of our service we are going to provide. With the help of with directive, we provide the implementation class name that either implements the interface or extends the abstract class. The next important declarations that I'd like to show you are opens and opens to. Let's learn these. Before Java 9, reflection could be used to learn about all types in a package and all members of a type, even its private members, whether you wanted to allow this capability or not. Thus, nothing was truly encapsulated. Like we have discussed already, the key motivation of the module system is strong encapsulation. By default, a type in a module is not accessible to other modules unless it's a public type and you export its package. You expose only the packages you want to expose. With Java 9, this also applies to reflection. For example, we can allow runtime-only access to a package. So directive open_some_package indicates that a specific package's public types and their nested public and protected types are accessible to code in other modules at runtime only. Also, all the types in the specified package and all of the type's members are accessible via reflection. Another example, we can allow runtime-only access to a package by specific modules. An opens to module directive, like for example, opens package name to some listed modules, indicates that a specific package's public types and their nested public and protected types are accessible to code in the listed modules at runtime only. All of the types in the specified package and all of the type's members are accessible via reflection to code in the specified modules. We have discussed already that one of the main goals of modules is strong encapsulation, and I believe that you watched previous lesson and you're pretty familiar with reflection by this moment already. So you can understand that before Java 9, it was possible to use reflection to examine every type and member in a package, even the private ones. Nothing was truly encapsulated, which can open up all kinds of problems for developers of the libraries. Because Java 9 enforces strong encapsulation, we have to explicitly grant permission for other modules to reflect on our classes. If we want to continue to allow full reflection as older versions of Java did, we can simply open the entire module by using open directive before module name, like you see on the slide. Does it make sense so far? And please always remember that in case you have any questions, please post them below this video and I will be happy to answer those. We have just learned directives that we can use in our modules info file. The next step would be to learn how to build our modules. And before I show you examples of how to do that, let me explain different command line options that we can use when we build Java modules. Even despite the fact that later in our course we are going to learn such build tools as Gradle and Maven, and they already have support for building modules in Java, it's still valuable to know how to use module system from the command line. We will be using the command line for our full example that I'm going to show you in a few minutes to help solidify how the entire system works in our minds. Module path. We use the module path option to specify the module path. This is a list of one or more directories that contain our modules. Add reads. Instead of relying on the module declaration file, we can use the command line equivalent of the requires directive. Add exports. Command line replacement for the exports directive. Add opens. Replace the open clause in the module declaration file. Add modules. Adds the list of modules into the default set of modules. List modules. prints a list of all modules and their version strings. Patch module. Add or override classes in modules. Illegal access, with values either permit or warn or deny. Either relax strong encapsulation by showing a single global warning, shows every warning, or fails with errors. The default is permit. Finally, we are done with the minimum theory piece. Let's continue learning modules with examples now. This would be our Hello World modular application. Thus, it wouldn't be super complicated, because the main goal right now is to make you understand key principles of modular application. The rest of the things will be super easy to understand if you learned how everything works under the hood. So, first of all, I wanna say that for the sake of the demo, I created separate multi-module project. I will share with you a link to it in attachments to this lesson. I have root project folder, and I created modules folder. Apparently, this folder will contain different modules of my app. It is rule of thumb to name modules as the root source package. For example, if the top level package of the module is com.it-bulls greetings, then I name the module in the same way. Notice the full stops in the module root directory name. These full stops need to be there because they are part of the module name. They are not to be interpreted as subdirectory path dividers. Is it clear? As you can see, I have two modules here. Let me start from greetings one. It contains class with name greetings and static method inside that prints hello world to console. Each module should have module info file. Let's look at the module descriptor of this module. On the top you can see module name. Basically module name and name of the module folder should match. And we export package from this module. Export directive is used with package name. Let's now create the second module. The name of my second module is com.it-bulls app. This is the main module that uses greetings module. It has only one class with main method, where we use greetings class to invoke say hello method. Pay attention that we also have import statement here to import greetings class from another package. This module also has module descriptor. Let's look at it. Here we can see that this module requires my greetings module, and this is obvious, agree? Because we are using class from greetings module in this one. Do you understand dependencies between these two modules? If yes, then great. If no, please press pause for a minute and think about it one more time. The next step that we need to do is to compile our modules. Especially for that, I created script that will compile all sources. It is located in the root directory and it is called build.sh. I use Linux shell commands here, so pay attention you run this script either on Linux platforms or from git bash on your Windows machine. And do not use Windows command line to run this script. You know what javac means? This is our Java compiler. After that, I pass name of the output directory to specify where I wanna put compiled classes. The next thing I do, I need to pass module source path option. This is different from the one I shared before. If you remember, we reviewed what module path is on a separate slide. There is a difference between module path and module source path. The compiler needs a distinction between the code it needs to compile in module source path and location of compiled dependencies and libraries, module path. Does it make more sense now? I pass here name of my folder with modules. After that, I use shell command to find all files with Java extension in modules folder. Once my modular app is compiled, I can run it. I have another script for this that is called runapp.sh. Let's look at it. In this script you also see program that is familiar to you, Java. I wanna start Java virtual machine. I use option module path to pass the reference to the compiled modules. And after compilation, all of them are stored in target output directory. You can see that all files here have class extension, and even module info file is compiled into class file. Then I specify the path to the class that contains main method. The path consists of module name and full class name. So, in this particular example, com.itbulls app is the module name and com.itbulls app is the full class name. Is this clear? For the sake of the demo, I opened git bash inside Eclipse. I run build.sh script first, and after that I run app script. And here in console we can see hello world from modular application. Can you see this? Congratulations to you with your first modular application. One more small comment here. By the moment of recording this video, there is no single and proper way of using Eclipse to run multi-module application. There might be some additional steps to configure multi-module application in Eclipse. That's why, even on your work, most likely you would use command line to build and to run your complex enterprise application. For the sake of convenience, you still can work in Eclipse, but you need to be prepared that sometimes you would see more errors than usual, because sometimes it is either hard to configure all dependencies not in the app, but in Eclipse itself, in order Eclipse would understand clearly dependencies between all modules. Here is an example. You can import two modules as separate projects and work in Java editor with Java files. But in app module, you may see error because Eclipse can't see dependency on another module, since technically, for Eclipse, this is a separate project, and Eclipse allows only one module info file per project. In order to remove the error, sometimes you may need to configure dependencies manually if Eclipse didn't manage to configure everything automatically. For example, in my app module, I open Build Path submenu, Configure Build Path, and here on Libraries tab, under Module Path, I select Add Class folder. Here I put checkbox next to the module that I need in this one, namely Greetings module, and press OK. Now you wouldn't see any errors in Eclipse. But in case you have multiple modules and not all of them are configured automatically, this may take time during the configuration of your project very first time. After these configuration steps, you may run app even from Eclipse. Can you see this? Great! Since you have learned these simple things already, let me show you how to add a service to our modular application. In my Greetings module, I declare an interface with name Service Status Logger that contains only one method, print service status log. I have implementation of this interface that is called Default Service Status Logger. For the sake of our demo, it just prints text to console. Now, in my module info file, I need to declare that this module provides such service with the concrete implementation. I use provides with directive for this. The next logical step would be to consume this service in my app module. I use uses directive for that and specify full class name of the interface. After that, in app class, with the help of service loader from Java util package, I can load my service. I use load method and pass the class of the service that I need. Service loader is iterable type. That's why it has iterator method that allows me to get the reference to the first service loader object in the sequence. Having the reference to the object, I can call print_service_status_log method. Let's now use our git bash to compile new sources one more time and run our app. In console you can see that we successfully managed to invoke service method. That's all what I wanted to share with you in this lesson. Let's recap what we have learned in this lesson. In the lesson we have learned what Java modules are. Also you know the goals that we wanna achieve and that are captured in GSR 376. We have learned different modules types. After that we reviewed in details different command line options to work with modules. And on real example you saw how to create, build and run modular application. Together we configured Eclipse to work with modular application from IDE. And at the end of the lesson I explained you how to provide and consume service in different modules. Thanks a lot for your attention. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.